people come. Maybe just 5 minutes and we will start, just time that people will come. Yeah. We go late. So, good morning. We can start with the second day of the Mobiliage Association Symposium and Workshop. It's a pleasure to have you here today, and we will start with 4 keynote from agency and space agency for sure. I'm really pleased to welcome on the stage as the first speaker of today Hulpia Botezatu, that is actually the chair of the UN COPWOS Scientific and Technical Subcommittee, and also for sure co-chair of the UN Action Team on Lunar Activities Consultation, so ATLAC. So thank you, Hulpia, to join us, and please, the stage is yours.
Good morning. That's very tall. May I just leave this like that? Okay. Good morning, everyone. Nice to see you, everyone here. I'm honored for the invitation and really happy to be here. So maybe with a couple of you that have interest in the United Nations Committee on the Peaceful Uses of Outer Space activities, maybe we could have a coffee later on. As I said, it's an honor to stand here in Torino, a place where engineering heritage, good morning, engineering heritage and European cooperation meet naturally. And it's especially meaningful to gather today at the moment where humanity is preparing not just to return to the moon, but to operate on it in ways that will define the next century. Our theme, towards a new giant leap for humankind, is more than an aspiration. It is a responsibility. Because unlike 50 years ago, we are not going to the moon alone. We are supposed to go together, or we're not going in a sustainable manner at all. So today I have 5 key messages to deliver, and I hope you will be in tone with myself. And I hope this kind of 5 key messages will actually see in the speeches following and the activities following today. The first message, as I anticipated already, the moon is to be governed together, or not governed at all. In the next decade, we will witness simultaneous operations from multiple nations, companies, universities, research teams, space agencies, and so on. Landers, rovers, relays, power units, prospecting experiments, scientific instruments, commercial payloads, all operating within a shared geography, shared orbits, shared spectrum, and shared risks. And this reality forces us to face a simple truth. No actor, however capable, can shape the lunar environment alone. The moon is, by definition, a shared domain. A shared domain demands shared governance. Shared governance does not mean uniformity. It means coordination, transparency, predictability, and respect for others' missions. It means acknowledging that every landing, every transmission, every mobility path, every experiment has implication beyond itself. We are not writing separate lunar stories. We are writing a collective chapter in human history, or at least we are supposed to. The second key message. Interoperability is the backbone of everything to come. We often talk about interoperability as a technical matter. In reality, it's much more than that. It's also technical, but it's much more than that. Technical interoperability talks about systems that speak to each other. We have operational interoperability, missions that coexist safely. We have normative interoperability, that is a shared understanding of expected behavior, and so on and so forth. Interoperability is the difference between cooperation and collision, between opportunity and fragmentation, between sustainable presence and operational chaos. Whether it is communication, navigation, power grids, mobility corridors, scientific protocols, emergency responses, or data sharing, nothing in the next decade will work as intended unless it works together. So interoperability is not a luxury, it is the price of admission to the lunar future. The third key message. Governance must evolve at the same speed as operations. And of course, as the chair of the UN Committee on the Scientific and Technical Subcommittee, I see every day, of course, I face this critique of UN not being fast enough, but I also see every day how fast missions evolve and how essential it is for governance to evolve with them. COPIOS does not build rockets. It builds confidence, predictability, multilateral legitimacy, and responsible norms of conduct. And because lunar activities are accelerating, member states created this new mechanism called Action Team on Lunar Activities Consultation, or ATLAC, that is supposed, and we are aiming to be inclusive, technical, non-political, forward-looking, and designed for exactly this moment. Its purpose is simple but transformative: to bring member states of the committee and observers to the committee into structured dialogue before problems arise, not later. And so we try to look at concrete challenges that we are currently mapping still: coexistence of missions at high interest sites, spectrum coordination and interference risks, safety practices for landings and mobility, emergency assistance information sharing, scientific transparency, environmental responsibility, interaction between public and private missions, and so on and so forth. The fourth key message: why the Moon Village Association matter more now than ever. Institutions provide structure, but community really provides the momentum. MVA brings something unique at the table. It brings people from agencies, from companies, scientists, engineers, emerging space nations, established space nations, students, entrepreneurs, you, legal scholars, mission planners, visionaries. MVA bring the operational reality that governance frameworks must reflect, and it's an example. There are some other organizations that do that as well. MVA also brings the creativity that technical solutions require. So the Moon Village idea has never been about a physical settlement, but about a shared mindset. A mindset that sees the moon not as a competitive frontier, but as a collaborative ecosystem. The fifth and final key message: a new giant leap must be a collective one. When Neil Armstrong stepped into the lunar surface, he spoke of a giant leap for mankind, humankind. Today, that leap is no longer a single moment. It is a collective process. The next giant leap will be made when our systems will interoperate, when our missions will coordinate, when our values align with our actions, when emerging actors are included, when safety is not assumed but ensured, when transparency would be a habit, not a favor, and when we choose cooperative over fragmentation every single day. The moon will test our engineering, but before that, it will test our capacity to govern. And governance is not created by declarations, as I'm doing now. It is created by choices. The choices we make here, now, together. Ladies and gentlemen, humanity stands at the threshold of a new era, one where our presence on the moon will be continuous, complex, and consequential. We can build that future responsibly and peacefully. We can ensure that no actor is isolated, no mission is endangered, and no nation is left behind. We can aspire to a lunar environment that reflects the best of human cooperation, not the limitations of our divisions. But only if we act together, only if we build systems that work together, only if we govern the moon together. This workshop is not just another meeting. It's a part of the infrastructure of trust, and trust is the first building block of any sustainable lunar presence. Thank you, MVA. Thank you to our hosts in Torino, and thank you to each of you for choosing collaboration when it matters the most. Thank you.
Presentation. There is any question or any comment from the audience? Someone want to ask something or? It's okay. Actually, we will have opportunity also. Ulpe will chair a panel later on. So she will stay with us still some hours. So thank you once again, Ulpia, for your talk. And thank you. And now, I'm pleased to call off the stage the second speaker of today from the Italian Space Agency. We have Simone Pirrotta, that actually is the head of the Robotic Exploration Office at the Italian Space Agency. Just
It's not. Oh, okay. Good morning, everyone. Okay, okay. It seems like it worked. Good morning, everyone. Yeah, and I also thank Ulpia for the very inspiring messages. And on my side, I will present current ASI, Italian Space Agency exploration activities, just recent achievements, but in particular what we are preparing for the future, for the near mid-term future. It's a pretty long presentation, so I'm sorry. Sometimes I will go fast through it. So please, in case we can talk later about something that could be of your interest. Our vision about exploration is, of course, it's homogeneous with the rest of the scenario, international scenario, and we want to maximize the heritage, the national heritage, implement the strategy that is coordinated with the scientific community. As I mentioned yesterday, ASI has its own national programs, but it's also strongly committed to support ESA and has a strong interest in bilateral or multilateral cooperation. We can say that we have, with some of the partners that you see here, depicted here, we have dedicated joint exploration working groups. We have with JAXA, ISRO, and CARI, and other, and also CSA partner. Well, this is our approach, and we also believe in coordination. As Ulpia mentioned, it's not yet cooperation, but coordination. One of the fora where we are very active is ISECG, it's the International Space Exploration Coordination Group. Now it's composed by 29 space agencies. It's only space agencies. Recently, we issued the Global Exploration Roadmap. It's now 1 year, and it depicts the vision for this decade. Of course, you can see the moon at the center. And for the different destinations, there are an elaboration of what are the key capabilities and elements. Here's the moon ones. But there are also other aspects that are common, like there are exploration principles, sustainability. You can find a lot of interesting inputs there. Coming back to ASI, how we see exploration. Of course, we try to cover all the destinations. We want to reinforce our activity in a LEO, trying to benefit of ISS as a platform, but also looking at the future opportunities in that. Moon is in the center. We have several elements there on the surface, and in orbit. I will briefly mention some of them. But of course, Mars is still there, and as for the future, and we have a pretty high interest in small bodies and asteroids. Okay, let's go to what recently happened. We had the first active payload on the moon surface as part of the Firefly Blue Ghost lander, which landed on last March. On board of that, there was a GNSS receiver that for the first time captured the signals that were from orbital, Earth orbital assets that for the first time were captured and from the orbit and then from the moon surface. It was a good demonstration, and we were considering to extend this in view of all the activities that are expected to build a real local infrastructure. I mentioned that we are strongly involved in ESA. We confirmed it at the recent ministerial meeting. We support the infrastructure that ESA is preparing for Artemis, for example, ASM, but also modules for the gateway. And we have projects and our companies are prime, are on the first line to develop Argonaut, for example, and Moonlight. The heritage gained by the Italian community in the drilling system is now going to be matured more with the prospect. It's not only a drilling system, of course, but it's the first ISRU that is expected to be part. In the past, it was expected to fly on a Russian mission. Now we'll go through Eclipse opportunity, and it will tell us a lot on volatiles in particular. This is what the PROSPA laboratory is expected to detect. One European mission with a very strong Italian contribution and leadership is Lumio. Lumio is a small sat that is expected to operate and to observe the far side of the moon and to detect impacts of micrometeoroids on the surface, to impact the flash, the optical effect of their impact on the moon surface. It's led by Polytechnic of Milan and an Italian industrial prime contractor. I just want to briefly mention that this is based on a strong heritage of Italy in small sat for deep space, because we, in the past years, in particular 2022, we had two good success. One was Argomoon on board of Artemis 1, was one of the few small sat that has been launched by SLS at its first maiden flight, and it depicted cislunar environment and the Earth and Moon. And a few months before, Licia Cube accompanied DART in the mission, the first planetary defense mission, active one, impacting the asteroid Dimorphos, and this small satellite at 12 millions of kilometers performed a capture 400 pictures of the impact on the asteroid, the effect of the impact. So we have this strong heritage in small sat for interplanetary mission that we want to value. Going back to the moon, probably the flagship element that I can mention is the multipurpose habitation module. Can be relocated, as you see. It's not a rover, of course, but it has this capability to be relocated. It will host two crew members for the surface time and support also EVA, so external activities. But when it will not be crewed, it is autonomous and can be operated to perform scientific experiments and support surface activities. It delivers power. It's really multi-purpose, I can say. It is officially part of the architecture of Artemis, and it's now in phase B. Another national program where ASI is involved has been named Earth, Moon, Mars, because there's a wide project involved with several small initiatives inside of it, and the key idea there is to deliver a scientific platform on the moon surface to use the surface as a privileged observation point to observe the Earth and other astrophysics phenomena from the moon surface. There are several interesting instruments there under design, and we hope that we could have a demonstration for them. Oracle. Yesterday I mentioned the importance of ISRU. In situ resource utilization is really critical. There was a few years ago good progress by a national laboratory here in Milan. They demonstrate the extraction of oxygen and water from lunar regolith, and we decided, ASI, that this will deserve a demonstration on the moon surface. So now we have Oracle project. It's progressing. We have already good design aspect to be already defined, and we aim, it's fully funded, and we aim to have the flight model ready at the end of 2028. Something that will be launched earlier is retroreflector. Italian national community that is involved in planetary retroreflector suggested us that one of them could be interesting to be on the far side. So we negotiate with iSpace a flight opportunity for one retroreflector to fly on the M3 mission to be launched. It was expected next year, but now it's planned 2027. And this will be an additional reference point of the network that is currently observed by the laser that is on board of LRO. But in the future, we hope that we will have orbital asset equipped with lasers to observe this type of element and to provide information on precise positioning. A few months ago, we completed 2 phase A study for a robotic mission on the moon surface to be implemented by elements with high mobility. We had 2 consortia working on that, and we present the result mid of January in ASI. We are ready to also support the phase B starting next year, because we believe that we have national capability in robotics and also in this type of new mobility, possibly. The target of both the 2 mission studies are regions with interest in for a future habitability, so resources, but also natural cavities like lava tubes. And they studied several options for these collaborative surface elements. The idea is to have a purely national mission in the future, or maybe to have a bilateral, multilateral opportunity for some partner, international partner that could be interested in taking part of that. So I think that once we will mature and we will select the one that will go in phase B, it will also be good to discuss with our partners, the ones that we are involved already in, and also other potential partners. So please stay tuned, because we think it's a good opportunity also for cooperation. In order to validate all that, we are also preparing a facility for testing, for ground testing, here in Turin, in Altec premises. They're hosting, the Rover Operation Control Center for ExoMars. So it was a Martian facility. Just in the building in front of it, there will be another big facility destined to test with the lunar yard and with thermal vacuum chambers, dirty thermal vacuum chambers, to reproduce the moon conditions, presence of dust, and a control center. So 3 main elements. We don't have already a name for this facility, so you will be soon notified. But it is intended to be again as a place where we can test robotic and also crewed operations. In fact, the multipurpose habitation module is the driver for the design of this facility. This is in a good state of maturity, and I hope that in the future you will be also you will see the progress when there will be the inauguration moment of it. So thank you. I apologize. It was really a fast, very quick description. If you're interested in some of this opportunity, whenever, please feel free to reach me by email, or I will be around for a few other hours. Thank you.
For the really interesting presentation. In this case, any question?
Thank you for your presentation. I have 2 questions. One is that I think one of the most important characters made by the ASA is during core attached with the Mars mission made by the SelectX and and so I have a one question. Is that for the prospector, ASI developed the Doreen core for the prospector mission, or other instruments such as water analysis. So I would like to know how to be related with the prospector in ASI.
We think that the data that we have for the prospecting, they already they're enough to inform the mission design, right? But the elements will carry instruments that will add more information. So for the mission planning, the 2 teams already started from a good basis, and they for the prospecting they already kind of well developed, okay, I can say. But of course, we see prospecting as a key element for resources in particular. Our I0 system is quite agnostic with respect to regolith composition. So we are negotiating the lending opportunity with no main interest in the lending area, but prospecting in general is a key element.
I think so.
Yeah.
So I read some papers, and in this paper, the prospector consists of some instrument such as mass spectrometer for the water volatiles, and drill cores for drilling the ice-bearing regolith. And so I have interest in how country or how institute does make such institute. There's many institutes in the ether. So DLR, for example, DLR made the water mass, but ASR made a drill core. I would like to know. But not it done.
No, yeah, the Prospa part of Prospect contains, I don't know if you're familiar with the architecture, but there's this element that given the collected samples, it will expose it. The prospect is tailored around volatiles, search for volatiles, yeah, right? So the samples will be stimulated in order to release the volatiles, and that will be analyzed by several instruments. And so there are different contribution from European countries. So.
Okay, and this last short question. When will we launch?
Next year.
Next year?
Yeah. Prospect, yeah.
Okay, we are a little bit out of time, but okay, one very short, please. Because,
so it's more like a comment when you are strategizing the systems for Mars and Moon. Many of the systems will be common, and there will be certain systems that are significantly different as far as the exploration of lunar and Mars surface is concerned. When you are planning it, when you are planning your programs, you consider this commonality part and make sure that the systems that are developed for lunar exploration will be fitting into the Mars exploration also to a significant extent.
So Mars, okay, this is focused on the Moon, you say? Yeah, we'll talk later. Sure. We believe, of course, in the philosophy of Moon to Mars, and submodel technology will be, of course, functional to that. And we plan this in a way that is consistent with this vision. There are Martian initiatives, mainly based in ESA, and we contribute to that with our usual technology where we have a strong leadership. At the moment, no national initiative for Mars, but the usual strong commitment because our scientific community grow with ExoMars as a source of data that is now expected in a few years.
okay. So thank you, Simone, for this great talk. Once again, a round of applause for. And I'm pleased to call on the stage the third speaker of today. It's a pleasure to have here Professor Ikon Funaki, professor at the Institute of Space and Astronautical Science and part of the Japanese Aerospace Exploration Agency. So, please, Professor, stage is yours.
So, good morning, everybody. Welcome to this very early morning sessions. So I'd like to talk about a very brief overview of space exploration mission at JAXA. My name is Ikko Funaki. I SAS JAXA. So I tried my best to make my presentation simple, including some movies, beautiful pictures, so that you can relax and enjoy my story. So first movie shows you to introduce JAXA just in 1 minute. So after following this movie, I'd like to talk about exploration missions. So first of all, I'd like to talk about goal and approach, followed by robotic exploration at the frontier of solar systems. And you may be interested in activities toward sustainable lunar surface exploration. And I'd like to summarize today's talk. So JAXA's exploration goal is to reach, first of all, every part of the solar system, to explore planets, moons, to find the history of their formation and the origin of life. And another one is to make the cislunar region a sustainable field with aggressive and continuous research and development efforts in new technology through intensive collaboration with academia, industry, and of course, international partners. So, as for the robotic exploration, our next mission is, I'm sorry, it's not the moon, but moon in the Martian system. We are preparing Martian moons exploration missions that will be launched next year. So in this mission, following the successful results of the Hayabusa, so the Phobos, the moon of the Martian system, and take a sample at the surface of that moon to take it back to the Earth to find scientific new things. And I quite appreciate so that there are many participants, international partners in these missions, and we are very happy to lead that activity. So not only these MMX missions, we are intensively working on a variety of solar system exploration missions. Yeah, we are working on so many missions. Not only, so only a few JAXA-led missions, but we also participate in various partners, international missions such as NASA, ESA, and so on. And we quite appreciate these opportunities to have to visit various sites inside our solar system. And we are also often open to any new collaboration. And if we go to the lunar surface exploration, we successfully completed the first of our lunar surface missions, SLIM mission. It's a smart lander for investigating the moon, and the summary is shown using this slide. So this is a very small lander missions to test just precise landing on the moon, and just before landing, a small robot was deployed. You saw it. And these robots are level 1 and level 2, or we call the smallest one Soraku, and he captured the image of the mother satellite stream. So SolarQ Level 2, this very small rover, is the first Japanese rover on the surface of the moon. And this is as a result, this is a result of very intensive collaboration between JAXA and Japanese industry, Takara Tomy Sony, and academia, Dosha University. So it's a very unique and good example of our industry, academia, and agency collaboration. And stimulated this activity, a lot of Japanese industry partners, as well as academias, are wishing to use the surface lunar activity opportunity. So we are in a very interesting atmosphere here in Japan. And next of our lunar mission is LUPEX, Lunar Polar Exploration Mission, under development. He's going to conduct lunar observation, in particular water in lunar polar region, to understand the distribution, condition, and form of water and other volatiles. And I appreciate a very good partnership with ISRO. It's a ISRO-JAXA joint mission. JAXA provide lunar explorer, and ISRO provide lunar landing technology, lunar lander. And he's going to search for the distribution on the surface of the lunar surface. Something like that. Distribution in the region and distribution in the depths. And in the following section, I'd like to talk about activities towards sustainable lunar exploration. And this picture shows JAXA's Moon Mars exploration roadmap. You can see LEO activities that is moving on to the commercialization of space activities. And on the center, you can see sustainable lunar activities in the 2030s or 2040s. But our focus is on the later 2020 missions as well as former 2030s missions. As for the Artemis missions, JAXA commit to 3 kinds of components and systems. One is HTV XD on the left-hand side, and another one is environmental control life support system for IHAB module. So, okay. Yeah, of course. And this is the HTV XG development scenario. Following successful HTV-X mission, this is the recently developed ISS logistic module that is tested last month, October. And this technology will be expanded to the Lunar Gateway logistic module. And also that will be used for post-ISS missions. And a third contribution to Artemis mission is a crewed pressurized rover that is under development also. So it is an all-Japan endeavor for the world's first mobility system on the moon. And Japanese Toyota Motor and Mitsubishi Heavy Industry with the traditional space industry. Maybe Toyota is identified as non-space industry, following the definition of Satoru-san yesterday. And by multiplying these technology, we can make the very comfortable stay on the surface of the moon with very high mobility capability. And following these commitments, JAXA it's intended to send 1 or 2 asteroids on the surface of the moon. It's defined as in the agreement between NASA in the frame of Artemis missions, and Tsuba-san and Yonesa-san were the recently hired and recently joined JAXA astronaut. It's not totally decided, but they must be the very good candidate for the lunar surface JAXA activities. And in terms of lunar infrastructure research and development, JAXA is continuously working on various activities. On the left-hand side, lunar communication, positioning, navigation, timing system. And in the bottom line, JAXA is also working on, it's still in very preliminary evaluation phase, mid-size cargo lander. And in terms of the participation of non-space industry or academia, they are very interested in lunar surface activities and science and infrastructure such as energy, construction, food, and so on. They use their own funding by the Japanese government, and space strategic funding was added to the list, and also to JAXA Center, JAXA Space Exploration Center, and JAXA's Exploration Innovation Hub Center are working continuously on that topic. And as one example, this is my favorite movie. It's a housing module targeting at the future lunar housing set. So it's very easy to construct and easy to maintain. You don't have to make additional effort, maybe 10 or more years. Just put it on the surface of the moon and you can use it. So Misawa Home, it's our industry partner in Japan, tested it in Antarctic continent so that they can test it in a very harsh environment. So such activities, a lot of such activities are going on in Japan, looking forward to some new participation in the surface of the moon activities. So I'd like to summarize this presentation outline JAXA's goal, approach, and current effort in space explorations. And as I said, most of these missions are carried out through international collaboration, and we greatly appreciate the contribution of our partners and looking forward to continued or new cooperation in the future endeavors. Okay, thank you so much for your kind attention.
So, okay, time for one question, very short, and then we have to move forward. For sure, I think that Mr. Funaki will be here still all today.
Thank you very much for a very inspiring presentation and looking in the future. My name is Mikhail Shipansky from Deep Space Energy. Mm-hmm. I'm very curious. JAXA's SLIM mission is famous for the fact it survived on the moon surface for 2 nights without having radiator power on board.
Yeah.
Which, as far as I have been talking with a lot of my colleagues internationally, is very curious. I mean, how it can be possible? Can you actually comment on that?
Yeah, I think I don't know the exact answer yet. In fact, it's 3 nights. He overcame 3 nights, and yeah. SLIM mission was, we have a Japanese industry partner contractor, but all the subsystem designs were conducted within our institute. So selection of components, fabrication of every parts are within our ability. So maybe our choice is of such component and devices and so on good enough to survive that very long-term 3 lunar week. And you can see on the right-hand side, the top side down picture. That status is not intended in our design, but that situation was very thermally stable. Yeah, I cannot imagine why, but so as far as the thermal issue is concerned, maybe this is the best setup to observe good enough amount of solar energy to survive the lunar night. And maybe this is another reason that contributes to the very long lunar missions.
Okay, thank you very much once again for this very interesting talk. And it's a pleasure now to invite on the stage the last speaker of this session. Please, Mr. Padma Kumar, distinguished scientist, is the director of SDSC SHAR Spaceport in India, has a master in science, system science and automation, expert in mission design, guidance and control, simulation, avionics, and ground system. So, thank you very much to be here. I just put your presentation and stage is yours. Please.
Yeah, good morning to everyone, all the fellow presenters. So basically, I am just going to give you a brief about whatever we have achieved in our lunar exploration program and what are our future plans. So our first attempt started 20 years back. That was the Chandrayaan-1. The name comes from our language. Chandra means moon. Yan means journey. So Chandrayaan is basically a journey to moon. So the Chandrayaan-1 we conceived about 20 years back. At that time, we didn't have a rocket launcher which is really capable of doing a good mission to moon. We had about 1,600 kg we can transfer to moon. That was our best ability, and the challenge was to configure a mission which can do something very important for lunar exploration. So that is how Chandrayaan-1 was conceived. And the idea was basically to reach the moon. The mission design was the most important thing as considered as an objective. And there were some scientific experiments also, which was payload capability was about 105 kg of instruments we carried. And Chandrayaan-2 was the next attempt where we had a much bigger rocket. And we had a very good orbiter in that mission and a lander and rover. Unfortunately, we couldn't do a soft landing. At the last minute, it crashed. So the lander and rover were never really used, but the orbiter had very good instruments and still it is giving us good inputs. And the Chandrayaan-3 that was there in 2023, we learned the lessons from Chandrayaan-2 and we modified the mission and we achieved the soft landing near the South Pole. And we had a rover also, and the rover, we had planned the mission for 1 day basically. So because the lander was not designed to survive beyond through the night of the through the night. So, but the rover was actually designed, but we couldn't use rover because the entire communication goes through the lander to rover. So the Chandrayaan-3 was really a full-fledged success, and we were able to get a lot of scientific data from that mission. So this is the Chandrayaan-1. I have already briefly talked about it. In that we had an orbiter and an impact probe also. So in 2008, we could do that, and it had a significant scientific outcomes also. This mission actually discovered the presence of hydroxyl and water molecules on the lunar surface, which is well known. And there were other outcomes also, and a lot of scientific publications based on this mission. We had payloads, international payloads from India, Europe, and US. Especially this M3 payload, which detected the hydroxyl and water molecules, were from US. Chandrayaan-2, it was a landing attempt, which I have already mentioned. We couldn't fully succeed. And here we had a much bigger probe that was almost 4 tons of spacecraft. And its design life was about an year for the orbiter. And right now we are expecting that about 7.5 years it will stay. So we had an orbital lander rover configuration, which is a classic configuration for any lunar missions. The way that the communication and the commanding can be achieved. So you can see that some of the pics that has been images that has been taken from the orbiter in Chandrayaan-2. And it has got a terrain mapping camera which has got a 30 centimeter resolution. So with this camera we were able to mostly have an excellent map of the lunar surface. And still it is going fine. And there are some images that are captured by the the terrain mapping camera, as well as other synthetic aperture radar. You could see that the quality of the images that these two systems were able to provide, and also it were able to give some subsurface aspects of the lunar surface also. And Chandrayaan-3, we made certain changes from Chandrayaan-2, but basically it was almost the same mission. And we achieved the soft landing on the lunar south pole. And we did certain in situ measurements. The measurement of near surface plasma was one of the most important aspects that we looked at. And of course, the presence of sulfur was an outcome from the study of the components. And if you look at the way where we have landed is, you can see from here, almost very near to the South Pole. And you can see how the other landing points of most of the other missions. Okay, of course. And the payloads were, we had a Langmuir probe payload on the lander. We had changed, it is called surface thermophysical experiment in order to carry out the measurements of thermal properties of the lunar surface near the polar region. And we had a lunar seismic activity monitor also. On the rover, we had an alpha particle X-ray spectrometer and a laser-induced breakdown spectroscope, which allows you to determine the elemental compositions in much more detail than the earlier system. The on-propulsion module, we had one module called SHAPE, which was a spectropolarimetry of habitable planet Earth, which was looking at Earth in order to create certain signatures of habitable planet in general, in the NIR category. So these are some of the outcomes from the Chandrayaan mission, 3 mission. I will not go deep into it because of the scarcity of the time. And this was about how we tried to look at the electron density very close to the surface of Moon. And we were surprised to find that the energy of the electrons that we much more higher than, almost an order higher than that was expected. And then the temperature of the Moon's epilayer, that is the first 10 centimeter, the temperature probe was inserted, and we have looked at the temperature profile. This was one of these very specific instruments built for this, and really worked fine in the very first time. And vibrations on the ground, it's a seismic monitor, and we have found several indications of seismic motion. And these results are still under full analysis. The measurements of the component analysis from the ASPS spectrograph is shown here. The characteristic lines from the elements are highlighted here. And Yeah, the major measurements by Chandrayaan-3 rover actually validated the lunar magma oceans hypothesis that the moon was once covered by a global ocean of molten rock that cooled to form its crust. So the rover's APX results analyzed the elemental composition, and it was found to be uniformly composed of Faroan anorthosite, a rock type formed from solidifying magma. So this was a real significant outcome from this study. You can see that there were other measurements done by the rover also. They were also pretty exciting, but for scarcity of time, I will just skip all of them. So now I will come to the Chandrayaan-4 mission, wherein we will be looking at a sample return mission, and this is expected to go in 2028. And therein we have a descender module and an ascender module, standard configuration, and with an orbital module. And in Earth, there is a re-entry module, which will be carrying the sample back to Earth. So this is, it is planned as 2 launches because the current launch vehicle doesn't have the capability of carrying 10 tons to the entire stack has to be moved to the lunar orbit. So what we are planning is as 2 missions, and then we will do a docking in the Earth orbit and move as a single vehicle to lunar orbit. So there are actually 2 dockings, one on the Earth orbit as well as on the lunar orbits, in order to achieve this mission. Otherwise, we don't have that capability to lift such a big system onto lunar journey. So this is all worked out, and now I think almost the configuration design is completed and it is going ahead fine. And the next one, my friend from JAXA has already highlighted, the LoopX mission, which we are doing along with JAXA. And we are making the lander, and JAXA is giving us the H3, that is the launcher in the H324 configuration. And they are making the rover also. So ISRO's part is the scientific payloads. So there are several scientific payloads identified and getting ready. JAXA is making the rover and the launch service as well as some of the payloads. I understand that the configuration design is already over, preliminary design is already over, and the reviews has been completed. And in both organizations, this activity is now continuing. Here also the target is between 2028 and 2029. An early target is getting pressurized into. So here the objectives, as he has already mentioned, is a direct exploration of a permanently shadowed region in the lunar south pole, and the characterization of the volatiles and water in the lunar south pole, polar region. So it is going to be a landing site is already identified, but it is still under consideration. That's the connecting ridge CR1, one of the shortlisted landing sites that we have identified, but it will be further, it is still undergoing some additional analysis, and then only it will be finalized. So our mission for 2047, we have thinking of landing an Indian on moon. That is one of the national target that has been given to the organization. And the other missions that will be part of this final goal will be the Gaganyaan mission, which is capable of carrying humans into Earth orbit and beyond, as well as the Bharatiya Antariksha Station also is planned, which will be coming up around 2035. And these 2 developments will allow us to build the systems that are required to land an Indian on moon by 2040. We are hoping that we will be able to do this. And the definition of that system is taking place, as well as the launch vehicle that is capable of doing this also is under development. So this is part of our this 2 decades vision is actually. I should say that there is a lot of focus on the lunar exploration compared to the other explorations. We have a great support from the government also for giving us all the fund and the support for this mission. So that's all I want to highlight. And this pic has been taken by the rover, Chandrayaan-3 rover, and what you see there up there is the Chandrayaan-3 lander. So it was on the 3rd day of the mission, and this is one of the pics that gave us a lot of joy. We could see that the baby sitting there very finally. Okay, thank you. This is what I just wanted to convey to you.
Thank you very much for the really, really interesting presentation. Maybe there is the time of one question, if there is any in the audience. If not, for sure, I think that Mr. Padmakumar could be around this morning, so you will have the opportunity to meet him. So I think that just to close, we can just have a picture with all the speakers of this session. So please, all the speakers on the stage, so we can take a picture. In the meanwhile, just information, we are a little bit late, so we can now have a coffee break just in front of the room, so maybe 15 minutes. And then we will start again at 10:15 with the panel here. All the program will be a little bit late of 15 minutes, and then we will recover in the lunch break that will be a little bit shorter, but for sure I think that all the sessions are so interesting that we don't want to remove time from that. So thank you very much for attending. We will start again at 10:15 in this room. Chiedo solo alla regia di mettermi la slide dopo. Grazie mille.
Ora sì.
Io ti introduco e poi dopo ti...
Sì, quella cosa del capo dell'Exploration Office non è più valida, quindi...
Quindi, come? Okay. So I invite all the people from the coffee break to come back, and because we are going to start the next session. I'm really happy to invite once again on the stage Simone Pierrotta, part of the Exploration Office of the Italian Space Agency, that will chair and for sure will introduce the next panel. So Simone, please, the stage is yours.
Thank you. Thank you again for having me. Welcome to the panel number 7. As you saw from the program, it is oriented to discuss ISRU aspect, in particular resource prospecting, and in particular I would like to stimulate with our panelists that are people strictly involved and directly involved in this sector to stimulate one specific aspect. We know that how ISRU is an enabling capability for exploration, in particular for a sustainable exploration. And we saw how now there is a strong interest in prospecting of resources, in particular in the assessment. We can not only rely on the identification, we need to have a very detailed quantification and an assessment on accessibility. So in order to consider the resource as a reserve, so something that can be used to be converted into a commodity. To enable all of this, we can rely on actually data sets that were collected during scientific missions mainly. So in the standard old exploration world, we had scientific missions stimulating in particular the institutions, the agencies, and we were sensitive to this message, and we were implementing the scientific mission, having collected data. Now the world is quite different. There are private sector is entering into the game. We need to rely on a precise assessment and quantification, and we need to rely on a different set of information. How all the heritage gained in the science-born mission and approach can be transferred to this new world, and what should be modified. I would like to discuss this with a set of distinguished panelists, and I'm going to invite them on the stage because I think they can really provide a good contribution to this topic, and in the end we can have a plenary discussion with all of you to understand if we can progress on that. So I please invite, join me on the stage, Fabrizio Fiore, which is director of Trieste Observatory, that is part of Italian National Institute of Astrophysics. Fabrizio, please. Thank you for joining us. You can sit there. We'll all sit there. Thank you, Fabrizio. Then we have Ernestina Bini, which is advisor of the director at the European Space Resource Innovation Center, ESRIC in Luxembourg. Hi, Ernestina. Thank you for being with us. Please, Mohamed El Awag. He's a PhD student in aeronautic and space engineering and is part of the Space Robotics Investigation Group of Sapienza at University of Rome. Thank you. Then we have the full professor at Politecnico of Milan, Professor Michel Lavagna. Thank you, Michel, being with us. And last but not least, Logan Ware. Thank you, Logan, Commercial Director of Blue Origin International. Usually stayed in Paris. Before starting the discussion, I please will ask a colleague from ESRIC, Larry Kutko, to provide us information about this ERIC Startup Program Support Call that is going to be released soon. I've been asked to it's strictly related to our discussion, so you have a presentation. And, can you quickly, first 5 minutes of our session will be devoted to this point. Let's look for it.
Of course I can. Good morning, everyone. I will try to make it quick because we have a great panel today. I'm Larry. I'm from the European Space Resource Innovation Center and also member of the Moon Village Association. Thank you for having this opportunity to be there here with you. So the idea is to just introduce very briefly ESRIC, the European Space Resource Innovation Center, and to announce a call for application that we launch as of today for the startups, for the economy in the field of space resources. So quickly, who we are, so that people can understand who is ESRIC. We are European Space Resources Innovation Center located in Luxembourg with different, I would say, segment and thematics. So we do research and innovation, commercialization through different funding programs, and of course, we have a big community and knowledge management activity. We have, within the commercialization department, 3 main segments: what we call hackathon, venturing, workshop organization to strengthen the community, an incubation program where I will announce the future call that's opening today, and we have an acceleration program. So everyone has some specific leaders inside ESRIC, so I'm leading the incubation program. My colleague here, Ernestina, is leading the acceleration program. And to explain to everyone what it is, it's a funding program which is happening in 3 different stages. Like a lot of incubation programs, we have different phases, but the interest here is that it's a worldwide outreach program. So every company around the world, it's eligible to apply. So we don't strictly limit our application to Luxembourg or Europe. There are some conditions, of course, for the phase 2 to get the funding to get it. The most important here is for the phase 1, where all the companies are accepted or not, depending on the eligibility, to be part of an acceleration program during 12 weeks. So you stay in remote. So again, if you're from Japan, from India, from Italy, from all around the world, you are eligible to apply to the program. It's for project owners. You need to have a use case and an application in the field of space resources. What we do during the program, we want to increase in terms of TRL, moving from 2 to 3 up to 5 at the end of the incubation program. Then we have other additional programs, which are more acceleration programs. Our target, to understand who we're targeting, it's really all along the space resources value chain, so activities in the field of prospecting, excavation, manufacturing globally, and all transversal fields like autonomous systems, power and energy, and many other robotic systems which can be used for lunar applications. Lunar or celestial body. We don't limit ourselves on lunar application, but let's say this is the first target currently and the first step for other, planetary body missions. So the value chain consolidation for us is very important in the sense that we want to be sure that there is an economic model behind that we have an economic impact in terms of GDP, return on investment for the companies, and of course we want to define a predictive model in the future. And this is what all is about here, understanding the economics of the space resources. As I mentioned, we are a worldwide outreach program. We have companies from all around the world currently in our incubation program in Technoport, which is an incubator, business and technology incubator located in Luxembourg. And we open, as of today, the 6th call for application. We have initially focused on power and energy, but we think that all technologies related to RSRU, in situ resource utilization, are very important in the field of prospecting, lunar exploration, and any type of technology with a use case. Please consider the use case is very important for us, are eligible to apply today. So I will not spend time. You can visit our website. I can share the presentation. Those are our incubated projects currently in Luxembourg. I put the flag of where they come from initially. And we have also the for information and acceleration program, and those are the companies who are also part of the acceleration program. But the idea is not to explain you all the details of the program, but it's really to point out the interest nowadays with the field that our panelists will discuss today, and that this is a worldwide and European program as well. So all the companies are eligible, and we want to target companies with dual applications, so having terrestrial potential application or for civil versus defense applications. We have labs to support the companies, definitely. My colleague Ernestina will talk about that later. We are part of the ESA network. We work with our greatest incubator in Luxembourg, the Technoport, focusing on technology and business. And we want to move really from the research to a real market. I know the commercialization of the space resource is quite complex nowadays, but there are different ways to reach that. That's why the dual application of the company is for us extremely important. Having a business on Earth with, I would say, Earth-based companies, maybe tomorrow lunar-based companies. And the support we offer to companies, it's a funding up to 200,000 euros, non-equity based. So every company which is selected in the phase 2 will have to be present in Luxembourg. So this is the only, I would say, constraint, not a constraint, but an opportunity to be part of the network of different agencies, European space agencies, a different Italian space agency, or the French space agency, the CNES, and so on. So in detail, this is the support that we provide, multiple opportunities in phase 1 and in phase 2. You will benefit from the support of our experts who comes from different horizons. We will help you provide funding, we provide expertise support, building a proof of concept, a POC, bridging with the companies, and of course supporting you in research, because there are a lot of companies who are still doing a lot of research to get funding, additional funding to support the development of their prototype. So we want to say that within our network at TestWeek we have multiple experts in multiple fields, but we also work with a set of worldwide experts. This is very important for us. We work with the Colorado School of Mine experts, with experts from Blue Origin who are part of us to support the mission planning for some startups, with PwC France, maybe I hope with Japan soon, and multiple other experts from all around the world. So we launch the call for application. It will be available in our website, I hope in the coming minutes, maybe hours, due to technical issues always happening in the last minute. And just to give you the presentation, and I will conclude with that. This is the overview, if you have the sound, entirely dedicated to space resources.
Who's the customer? What is the business plan?
Access to its facilities, offer technical support directly from the European space agencies. We're part of this vibrant ecosystem in an international network of partners.
future of space resources
starts now.
Find out how you can be part of the story.
So, if you have any question, we are present in the booth, the team from ESRIC and from Technoport. Here are our beautiful pictures, I hope. And do not hesitate to visit us in our stand. We have immersive VR to explain you how the space resources works. So the connection between the different, I would say, companies, applications is very important for science, for research, for innovation, and for the commercialization. Thank you very much, and sorry for the long discussion.
Thank you, Larry. Okay, now we'll be back to the format of this panel. We'll back to the focus of this panel, which is more related to the prospecting and exactly what we need and what we can transfer from the science-born instrument, method, and models. So the format first is 5 minutes of discussion presentation from the panelists each, with the 1 minute for one quick question potentially, and then we will have a roundtable discussion on several specific topics. So at first, I will ask Michel Lavagna, please, to join us. That's your presentation. Thank you, Michel.
So, I think that is not projected. I shall do here. Perché cercavo.
È un PDF, giusto?
Ti tengo. No, è un PPT. Cioè, non so, io non lo faccio. Questo qua. Non so però, perché è dentro i filmati anche, ma non so.
Perfetto, dovrebbe funzionare tutto.
Ok, grazie.
Adesso glielo proietto subito.
Okay, so good morning, everybody. What I would like to do today is to, let's say, give an hint on how, from a technological perspective, measurements and data could be useful, coming also from science, also from the typical, let's say, approach that scientists has, but that could be in a completely different perspective of application, let's say. So, of course, starting from something that I think the audience knows very well, when we talk about in situ resource utilization, we have in mind some classes and some categories here. I don't want to be, of course, whole comprehensive, but we know that we have a topic about the cultivations and biomass support, that is a resource itself. We have the whole environment of the environment control and life cycle support systems as well. That means gases, water vapor, temperature, recycling, and so on. The construction topics that has been also mentioned by Ezrik a few seconds ago. The supply for power, that means to have not only the power as a resource, but some other, let's say, meta resources to build up all that in situ. And then, of course, propellant. So this is quite well known in this community. And this means to have some other infrastructures available for that. So to have mobility, to have habitats and connectivity, and to have the capability to land. And this is just to put, let's say, spots to understand that there are a lot of connection, but a lot of, let's say, technologies and support that shall be concatenated to arrive to having the ISRU actually working for. And then last but not least, as it was again presented briefly by Ezrik, when you have a plant, whatever it is, it's physically or chemically processing the materials you have there, you need to collect it, you need to manipulate, to transfer, to potentially storage, and then maintain all the plants. And all that means that you shall know very well the environment in which you are working, and basically the feedstock, and the feedstock that is interacting with the environment, in this case the moon, that is the focus the more for me. That is quite impressive. I mean, the environment interaction with the soil. So what I tried to do here in a very simplified way, trying to connect what scientific instruments can give or typically give, and what it is needed by, as you see, in terms of the ISRU focus, so ECLSS, biomass, power production, constructions, and so on. So I tried to cluster in the cones what I mentioned before in terms of what it is at a very high level needed in terms of measurements to get rid of doing what it is in the cone. So it's obvious that there is the need of knowing quite nicely the granularity in some cases because of beneficiation. In some other cases, not needed. Of course, I have no time to go through all the cones, but you can do by yourself. There is also the contaminants, so to know even the percentage that are very, very low in the materials that you are using, not necessarily just the classical chemical compositions only. Thermal and optical properties are really important because many processes are related with temperature, and temperature could be by conduction, by radiations, and so it's a very relevant aspects to be known in a mixture of elements. Of course, it's not a pure elements. Then the shape distributions, so for locomotions, for printing also, to have sharp elements instead of very smooth elements could be really critical. Of course, there is also the environmental interaction. So what happens when the radiation interacts with the surface composition? So the electroactivities, if you have materials that is adhering to whatever is your furnace, whatever is your scooping, and so on, it's a matter of needed to be known very, very precisely. And last but not least, the distribution of the species, as I was mentioning before, not just the composition. And something similar, I just go quick, with respect to the infrastructure. So what you see here, there is... Okay, what you see here is reported with respect to what is needed for ISRU. So in this case is mobility, constructions, collection, manipulations, and so on. There are the same measurements needs. So this is the front end, or if you want the interface with instruments, there are classically scientific, but could give, of course, informations from remote, but the more in situ. And what I want to stress is that those measurements are definitely useful in two ways, I would say, with a preparation mission, so as a prodromic mission to whatever is then the infrastructures on the surface, and during the operations on the surface. So there are these two aspects that are really important to shape the design and properly work when you prepare the missions on ground, let's say, and then when you are there. And I just go, I don't know why. Okay, so I just want to focus on two examples that I have the hands-on that are, let's say, the post from where I got what I was saying before. This is a plant that we built in Politecnico di Milano. It's used a carbothermal reaction with solid material, so without reaching the melting point for the feedstock, to extract the oxygen from the dry regolith. So what you see is the plant, the demo plant in the lab, and what you see on the left, on the right side is the frozen water, and then of course distilled and then melted water obtained. The message here is, so let me see if I can start also that. Okay, so for us it was really important to have a well notion of the granularity distributions to understand how it affects the yield of the process, to understand the shape, to select the materials for the main furnace, to have the idea of the maximum temperature of a mixture that is not so easy as if you do for a single materials, not to have the clogging in the furnace, because we want to automate automate the whole process. And also what happens at the end, so understanding not only the surface of the particles in the DEM that you see at the bottom right, but also to understand the layers and the hash how could be deposited to enhance the yield of the process. So there are a lot of information at a very microscopical level that are really important to be known, to be sure, again, as I mentioned, in lab, to build the plant that is properly shaped according to the environment, and then to operate properly and collect what is in favor of the process that we are working with. And then the last slide that I have is on another process that similarly highlighted the same aspects that would be really important for us to be known in a very, let's say, sharp details. And of course, scientific instruments are there for being converted towards the technology. This is basically 3D printing. What we did, we used our wasted feedstock from the carbothermal process to print some construction materials. This is just, of course, the first steps on that. And we found how it was important, as mentioned before, to know very precisely the thermal behaviors of the feedstock. This is not beneficiated, so the scope is have no binding, no beneficiations, and to simplify the process at the most. And what I just reported here is the sharpening of the particles was detrimental for the process. The reflectivity was really important to tune the laser and the sintering, and also the granularity in this case was important to guide the sintering. And so just to end up, the message is what is already available in terms of scientific instruments are definitely capable to collect all these data, merge them, and then post-processing in situ during the operations and in front, let's say, when you build the plants as we are doing prototyping in the labs. So thanks for the opportunity.
Thank you, Michelle. I'm sure we'll be back to some of this point later. Please stay with us, of course, on stage. And yeah, the message is clear. We have a lot of information, but we need to characterize also the environment and also many other aspects. Now, I please ask Mohammed, please, to join us and to elaborate more on this topic. Yeah. I should.
Okay, yeah. Okay, thank you for the introduction. I would like to speak a little more about what the Professor Lavagna introduced to us. So, of course, datasets are needed for actually mission planning about in-situ resource utilization mission in future years. We know a lot about the moon, thanks to the heritage of previous mission, but a lot is still under development, under investigation. And in particular, we need decision-grade information, engineering data to size extraction and processing plant as the one we saw earlier. We could develop flexible mission to cope with our lack of information about the distribution and specific characterization of materials. But if we really want to push for efficiency and effectiveness of extraction and processing of materials, we really need to gather more data. And as long as the exploration assets do not have the capability yet to do this directly from the surface, we really need to rely on remote sensing and orbital missions. So starting looking at the past, so this is a very brief highlight of what previous lunar mission told us about the moon in general, starting from the Apollo program in the 70s. And just a quick highlight about key aspect for in-situ resource utilization in the early 2000 in general, we started understanding the presence of hydrogen enrichment at the pole, hinting to the presence of hydrated species. Later on confirmed by other missions, in particular spectrometers on board the Chandrayaan-1 missions, and future radiometer, basically, which hinted to the possibility to have water ice in those regions. Regarding the characterization in general of the lunar surface, we had radiometers, such as the diviner instruments on LRO, but also an highlight on radar sounder instruments on board the different other missions, which provided us with the information we nowadays have about the lunar stratigraphy, and the hinting also to the presence of particular structures, which are lava tubes, which were also named earlier today, and which are of particular interest for future in-situ resource utilization missions. However, from these missions, we discovered a lot, but we didn't unveil every secret, basically. And highlighting all these different aspects, what is actually missing. So, starting from the water ice present at the poles, what we know is that there is the possibility to have these deposits in permanently shadowed region, but all the measurements we have are actually not direct sensing of possible water ice deposits. They are basically no instrument was specifically tailored and designed to target and unambiguously detect water ice presence. So there is this ambiguity level between the presence of water ice and other hydrated species, so hydroxyl-bearing compounds, we need to solve by essentially developing new instruments and prospecting new missions to gather this kind of data. Regarding the mineralogical composition, all the data we have are have a coarse resolution. We characterize the lunar surface in a global way, but now it is time to target specific areas, such as the named South Pole, with the instruments capable to achieve the high spatial resolution needed, since the Moon as a planetary body has a high mineralogical variability on the local scale. So we need really to go in detail on that. And regarding the lava tubes and in general, what we saw and we detected from the lunar surface, also with respect to the water ice possible deposits, is our only surface measurement. We really need to target the subsurface in order to characterize the depth level relevant for robotic and human exploration. So the first 100 of meters haven't really been targeted by previous mission in a specific way. So what we suggested and we evaluated in a study I will cite later on is the necessity to develop instruments in order to target and tackle this lack of information. So in particular, we highlight the possibility to gather this data through a shortwave infrared spectrometer, extending the current capabilities of spectrometers already flown to the Moon, a radar sounder able to target the subsurface level we need to investigate, and with enough spatial resolution to geometrically characterize target of interest for both in-situ resource utilization, but also lava tubes could be used as natural mines, habitats, and things like that. And in the end, these data gathered by these two instruments shall be supported by a multispectral context camera, able to provide calibration data, context information, which will be useful to analyze and further enhance the capabilities of the first two named instruments through a data fusion approach. So just to conclude, I want to be brief. You may think all these instruments should go on a orbital mission, but what will be realistically the possibility to deploy such a mission? We actually did a pre-phase A study in Italian Space Agency concurrent engineering facility, where we actually tackled this problem, developing the whole mission concept, and I hope there will be possibility to talk more about this later on. Thank you.
Thank you, Mohammed. Thank you for having stressed the importance of multiple sources of data and also data fusion, probably. Now I please invite to join me here, Ernestina, please, from ESRIC. And please, she will add more information and data on the topic of the prospecting in ESRIC, although the ESRIC slot has been already used, so you have only 15 seconds remaining for you, so be quick. I'm sorry. Yes, I need to access the right. Enrico, can you please help me to find the right folder? Londra and Moon Village.
Yes,
right.
Sorry.
That's great.
It should be here.
Thank you, the floor is yours. I'm kidding. Go, please.
So good morning, everyone, and thank you, Simone. Thank you, Moon Village. We are very glad to be here. So, yeah, I have a few minutes, and I'm going fast. This is a presentation on prospecting in ESRIC, as this one was the topic of the panel. I would like to start just, to give an overview, because a lot of people are asking us, and to me as well, how you define your strategy in ESRIC for research and for everything that you are doing. So I would like to give this answer at first. As I said before, we are in partnership with ESA, so our strategy is mainly built with them. And for ESA ISRO initiative, they have three main pillars. So one is the community engagement, then we have the technology de-risking and the market de-risking. This is the focus of ESA, and then is the focus of us in our point of development. So the first one is the ground-based research facility and technology. Then the second one is prospecting and data modeling. So this is where I'm coming from our strategy. The space resource challenge and the commercialization that was explained by my colleague, and then the community engagement. So I will go through them with the focus on prospecting activity. As you probably know, in ESRIC we do all the activity around the value chain of the space resources. And so starting from prospecting in a linear way, but as explained by Michelle very well, prospecting is needed everywhere, and which one is the scope of ESRIC in the value chain is mainly to target the product that for us at the beginning was oxygen, water, and metal extraction. Through that, what we discovered is that we need prospecting everywhere from the beginning, so to understand where we have the material, which kind of material we have, their composition and the deposit types, and as well later on during the process. This one in before to go on the moon, and then when you are there. So the prospecting activity, it's quite, let's say, the focus of everything in the space resources utilization. I'm going, and we start, sorry, I'm going up, and the beginning of ESRIC 5 years ago, we started with the Space Resource Challenge that in fact was focused on space resource in prospecting activity. So this is, let's say, to put the focus on the fact that we start already 5 years ago with this prospecting idea. It was quite interesting because the challenge was to make a remote prospecting on the moon, and through that challenge we understood a few things. And first thing that we understood that there is too many gaps still to fulfill. We did another challenge, but this is just now on lunar excavation and beneficiation. We started with another activity in ESRIC that was mainly to understand the origin of lunar ilmenite. So this one was done by our lead researcher Abigail Calzada, and the type of analysis that she did, so in the last years together with a master student, was mainly a description model. Through these two activities, so the challenge based on the prospecting and our first study on the description of the model, we build all our strategy on the prospecting. So what we are going to do now in prospecting will be, together with ESA, to have a resource assessment and mapping. Mainly what we would like to do is to create a lunar environmental mapping, and through that to understand which one are the gaps that we should still to fulfill. As said by our colleagues Mohamed, we know a lot of things, but in ESRIC we say, wow, we miss a lot of things. There are a lot of things that we don't know yet. And many times we do a lot of assumption. In parallel to that, we know that there is a measurement activity to develop, also explained by Mohamed, in the sense that we should understand which instrument we need to fulfill the gap. And then, so we started this activity together with the University of Brno and a company that is in our commercialization area, that is Litigo, and is also here, explaining their activity. And as also said by Michel Lavagna, we are also studying the sampling strategy, because granularity is very important, and because all the information that we have today are coming for few samples that are mainly kept in a certain area, while when you speak about prospecting, you really should understand, let's say, more broadly and wide what you have. Another gaps, for example, that we noticed that we would like to fulfill is how many samples we should taken and where and which distance. This is something that the community is asking also to us. To finalize, for the prospecting area, where is come from all of that? A lot of company, and also the agency, and also ESA is asking us, but you as a European Space Resources Innovation Center, what you want the mission will take, which gap you want to fulfill, which one are the sample that you shall take, and when and what, and so on. So this is the research in prospecting activity that we are starting now. Our team will grow, so stay tuned in eventual open position that we will have, because what we would like to create, it's really this lunar environmental model, fulfill the gap, analyze what we need, give instruction to the mission provider, and also, let's say, to all the commercial company in what we need, and which one are the instruments that we should do to develop, the payload that we should put inside our missions. We are already working on that with our company on the commercialization. This is why for us it's very important, this connection between research and private partnership. I would like to finish just giving an introduction of what our facility are, because in our idea there is to support the community in de-risking their technology. So we have a lot of facility that we are developing in partnership with ESA, where all the missions, a payload can be already tested. So, for example, as the main part will be the dusty thermal vacuum chamber, probably you know what it is to simulate the moon condition. So we are thinking that a lot of instrumentation can be tested there before to go, let's say, directly on the moon, and value and differentiate them and see what's will be better. As said, there is also in our partnership strategy with ESA, the community part. So every year we will have our conference, annual conference. This year will be first, second week of May. And there is a session completely dedicated to prospecting. So there will be people around the world speaking about prospecting activity, instrumentation, and data. So I will invite you to come with us. I just want to remember that we are only 5 years old, so I think, reviewing our activity of prospecting, that anyway we did a lot of things, starting from the challenge to understanding which mission and how to build the mission, and what we really need to build together with this, and what the market is requiring us, and here we are. Thank you.
Thank you, Ernestina, and for giving us this very unique point of view. I think that ASRIC plays a very important role, and it's a bridge between research community and commercial with the connection with agencies and our strategy. So thank you for that. And now, I invite Fabrizio Fiore to contribute to the discussion again on the topic of how prospecting. He's a purely scientist up to a few months ago. Now he loves resources and is attracted by all this sector. Can you share? Yeah. I don't know how to make it. Devo proiettarlo io?
Devo metterlo io o loro? Sono PDF. Sì. Dovrebbero metterla loro, della regia. Ok. Dovrebbero mettere loro. Okay.
Okay, thank you. In 3 minutes, I would like to make just 2 or 3 points. The first is that high resolution, precise moon resource prospecting can be today efficiently obtained using instrumentation that has been developed in the past for scientific purposes. And the reason is that this instrumentation was developed with very tight scientific requirements, which means that we have very high-level performances. And even more important is that this instrumentation has a very high TRL, because in many cases this instrumentation has already flown, which means that the repurposing time can be very quick, few years. And finally, the other important point is that this instrumentation has been developed by experienced teams. So we do not have to build up the knowledge from zero. And here there is an example of this kind of instrumentation. This is an X-ray and gamma-ray spectrometer that was developed by ENAF, and it is flying on the Spirit satellite since 2 years, and is working really very, very, very well. Now, which prospecting? This is the standard pyramid for resource prospecting and ground truth exploration for mining. And the point I would like to make is that on Earth, we can do ground truth exploration on scales of many kilometers. But in hostile environment, drilling and detailed ground analysis must be carried out on much smaller scales to save money and time. So the prospecting must be pushed to obtain the detailed, at the level of tens or hundreds of meters, of reliable composition maps from both remote, low orbit, and in situ rover observations. Now, I'll give you 3 examples that are the examples on which we are working in a project called ARLOC that is funded by ENAF and CNR in ENAF. The first is gamma-ray spectroscopy. Gamma-ray spectroscopy is to detect nuclear lines. Now, the important point here is that this is a direct measure of abundances, because basically we are counting atoms. So this is not it is not an indirect measurement, direct, which means very small systematic errors. The second is X-ray fluorescence spectroscopy. Here we are targeting again atomic lines, and again this is a direct measurement. These 2 things can be done from orbit. This has been done by, for example, Lunar Prospector or Selene in the past, or by Chandrayaan 2. Or this could be done also in situ, hosting this kind of instruments on rovers, meaning that we can reach footprints of the order of tens of meters or even smaller, centimeters, if we use XRF on rovers. Again, the point I want to stress is that these are direct measurements of the compositions of the surface of the moon. Optical near-infrared imaging spectroscopy for example, refractory minerals, or to look for water or oxygen, are indirect measurements. In fact, M3, it was the best instrument that was used so far, had to be calibrated using Lunar Prospector gamma-ray spectroscopy data, meaning that you have to add a large systematic errors on these measurements. This could be done from orbits, of course, it has been done for orbits, but it can be done also in situ. For example, using illuminators with the UV diodes to provocate fluorescence of materials. So these are the kind of things that I think would be done in the near future. In fact, with Arloc, we are using all these technologies. We are using gamma ray observations to map thorium. You know that thorium is associated with CRIPS terrain materials. So using gamma ray prospecting, we can understand which are the regions that maximize the emission. Then we can go with the rover toward these regions and have prospecting on smaller scales, say meters, using hyperspectral cameras. And then we can perform even more detailed observations on smaller scales to look, for example, for rare earth elements using UV fluorescence and X-ray fluorescence. And all this is aided by artificial intelligence running on edge computers to assist on the fly data analysis and autonomous operations. So this is the core of our project. This is a 3-year project. Again, it was funded by the Italian Ministry of University and Research through INAF and CNR with 2 main goals. One is water and the other are precious minerals like rare earths. And the point is that we want to understand whether there are ore deposits for these elements. The goal is to reach a demonstration model by 2028 to demonstrate full functionalities and operation in proper environment. And I would like to end with this point that, of course, our thought today and plans are based on what we can imagine based on our current knowledge. But keep in mind that breakthroughs happen when we go beyond that. Thank you.
Thank you. Thank you, Fabrizio. Is another confirmation on how we can strongly benefit of what we already gained from scientific investigation applied to this field. Last contribution from Logan. It will take us the point of view on private company that decide to invest also in this aspect, and please complement to us. Sorry, it seems like we are really marginal, so thank you very much.
Thanks, Simone, and thanks for the invitation. And it's important to be able to participate in the Moon Village Association conference and have these conversations with people that care about the topic. This is a very growing community that cares about this topic, and it's clear that there's getting a lot of traction and interest in space resources, and there's very clear and consistent need. From each of the previous presentations, it's clear that there is a clear need. There's a clear need to map. There's a clear need to understand the resources and where they are on the moon. So my intent is to provide the industrial perspective. There's a very clear need. What are we doing, and what are we doing right now in order to meet those requirements? So a bit of background about our company. Blue Origin is quite old now. Not many people know this, but it's been around for 25 years. It was founded in the year 2000. It was a research and development house for quite a long time, and we've started to make progress, I would say, over the last 10 years in improving capabilities that help us to achieve our mission. And our mission is broken up into 3 phases. And we've held this same mission throughout the life of the company. So the first phase we talked a bit about yesterday, which is building a road to space. This is accomplished through launch capabilities and transportation capabilities if we're talking about getting to the moon. So an example of that is New Glenn, which is a very heavy launch vehicle that you launch and you reuse and reduce the cost of accessing space. You apply the same thing to the lunar transportation. The second phase in this mission is leveraging the vast resources that are in space. And that's what everybody's been talking about already for the last 30 minutes or so. This is critical and core to the vision and mission of our company. And we are investing in this. And we've been working on this for years now. And the central hub for that is our Space Resources Center of Excellence based in Los Angeles. It's the largest space resources center in the world. There are people that are dedicated to building in-situ resource utilization capabilities as well as prospecting capabilities, which is going to be my focus of the next, let's say, 2 minutes, is a campaign that we announced at IAC called OASIS. OASIS is a lunar prospecting and mapping campaign. It's broken up into 3 phases as well. The first phase is the mapping activity, where you use orbiters in order to understand at a very high resolution where each of these required and high value resources are. That's the first step. The second step is basically scouting. You use rovers and you go into high interest areas that you identified through the mapping, and you understand a bit more. And then the third phase is extraction and utilization. So it's a 3-phase campaign. We announced at IAC not only the campaign itself, but we also announced the first mission, OASIS 1, which is happening now. This is quite advanced. This will be a mapping mission. It's a very novel mapping mission that will use orbiters, low-flying orbiters with different sensors on board. The primary sensors that we'll be using, as an example, are a neutron spectrometer. We'll be using magnetometers. We'll be using other sensors on board these low-flying orbiters in order to develop, understand water ice at a meter depth. And the low-flying nature of these orbiters that we talked about earlier helps to prevent, or helps to really define at a very high resolution where these concentrations or reserves are for water ice, rare earth metals, high value metals as well. And basically the idea is very consistent with what everybody's already discussed, is once you understand where those resources are, we can also understand how to extract them. So I think the Oracle system was brought up earlier. How do you extract the oxygen from these resources that are in high concentration? So that is the OASIS campaign. It is leveraging a lot of heritage in technology and capabilities developed in our Space Resources Center of Excellence in Los Angeles. But the first mission is in partnership with the Luxembourg Space Agency and the Ministry of Economy there in Luxembourg, who is also helping us to get support from ESRIC and GomSpace that are Luxembourg partners. And it will be led by Blue Origin International, which is our headquarters in Europe, and it's based in Luxembourg. So this is a fully fledged international prospecting campaign, OASIS. Thanks.
Thank you, Logan, for the perfect timing. I'm sorry, it seems like we don't have time for the plenary discussion around table and questions. I'm really sorry for that. But hopefully you can you capture the main message from the discussion. A quick wrap up from my side. We understood that this important contribution to ISRU, this is the prospecting, it really needs. It basis comes from the heritage, from scientific, from all the decades of investigations, and now we need a step forward. And in particular, we need to act as a community. There are so many so many like different points of view to be merged here and to benefit. So please meet the panelists outside and later for further discussion. Thank you for participation and thank you for your participation.
So thank you all the panelists for this really interesting panel. We can move to the next one, and it's a pleasure for me to call on the stage once again Ulpia Bottezzato, Scientific and Technical Subcommittee Chair in COPWOS and ATLAC Co-Chair. So please, Ulpia will chair the panel about lunar governance. So please.
Thank you very much. I'd like to invite my distinguished panelists to the stage, please. Mr. Iko Fnaki from JAXA, Mr. Sudhakar from ISRO, Mr. Wang Zongmin from DSL, and Mr. Simone Pirotta from ASI. Good morning, everyone. It's very nice to be here to talk about lunar governance. We will adopt this dialogue-driven format. We will focus a little bit on the technical and operational governance issues related to the moon, lunar exploration in particular, and some cross-cutting strategic themes before I give you the floor to present yourself would be interoperability as a governance instrument. How can harmonizing key systems provide a foundation for coordination between different lunar programs? That would be one cross-cutting question. Also, to question how can operationalizing the outer space, some of the outer space principles would be in the benefit of all countries into predictable, non-interfering lunar operations. That would be a second question to tackle. Look a little bit at the multilateral frameworks and what it means really to have an inclusive governance. And so this would be like the major framework that I would like to give for our panel on lunar governance. With this in mind, I would like to invite each of you to present yourself. Probably you would be doing that better than myself, and present a little bit about your activities in perhaps 30 seconds to 1 minute each. Please. Mr. Iko Funaki.
Yeah, good morning again. My name is Iko Funaki of ISAS JAXA. So my technical expertise is in fact a spacecraft propulsion system, so it's not related to the lunar governance itself. I'm sorry, but I was the director for JAXA's Space Exploration Innovation Hub Center. I worked about 4 years to make a collaboration between Japanese industry and JAXA to make up a foundation for the future lunar activities. I'm currently the director for international coordination and strategy at my institute. I'm responsible for any kind of space science and space exploration mission activity coordinations here at my institute. So thank you so much.
Thank you very much. I would like to give the floor now to Mr. Wang Zongmin from Deep Space Exploration Laboratory to say a couple of words about yourself, please.
Okay, thank you very much. My name is Wang Zongmin. I'm working in the Deep Space Exploration Laboratory. So yesterday I have the presentation in the morning to have introduced this lab. It's the responsible institution that's responsible for the deep space missions in China, for like the lunar mission, Mars mission, and also its other planetary exploration within the solar system. My background, I have studied in China, in the French, in the Russian before, so I can speak a little about the Russian and French. So it's I'm working technically in the CAST, the China Academy of Space Technology, also for the international cooperation, and also working before in the China Great Wall Industry Corporation for the satellite, the export to the world. So I'm working closely to the international cooperation since from the Galileo cooperation between the China and ESA. So I'm very glad that now is also the contributor to the deep space exploration mission, especially the lunar mission. And currently I'm working in the MVA, the GEXLA, the working group 3 of the co-chair, and will have some of a contribution that's excellent report will be distributed for the stakeholders, how to recommend it for the state and the country for the coordination and the cooperation. Yeah, thank you.
Thank you very much. I would like to give the floor now to the distinguished representative from ISRO, Mr. Sudhakar.
Good morning. Thank you very much for making me part of this program, and it's a nice place in Torino. As I'm not an expert in lunar governance anyway, as I told, so I've been part of the onboard computers which were doing the orbital missions of Chandrayaan, or lander missions and the docking missions and the mobility systems, rovers of Chandrayaan-3. So I've been part of the onboard computers which are taking care of all these activities in the ISRO space programs. So ISRO space program, as our director had explained, had been an orbital mission right from Chandrayaan-1, and Chandrayaan-2 is giving an excellent images which are being used in the various space programs, which will serve the purpose for the humanity. And we also had the successful landing in Chandrayaan-3, followed by we have the mobility operations on the lunar surface, which is also a good experience for us. And we have the excellent deep space network, which also will serve the purpose for our future programs. And we have the expertise in the hazard avoidance and such activities, which we'll be able to take care. And like Ms. Ulpia had told, the governance, interoperability, all this we will try to address in our future. Thank you.
Thank you very much. Last but not least, Mr. Simone Pirotta from ASI.
Thank you, Ulpia, and good morning again. I'm basically on the technical side. I'm usually act at ASI as a project manager for instruments or missions or elements of exploration initiatives. And so you probably saw in my speech in this morning some of the activities that I described. I'm trying to coordinate them at the national level, so with the also industrial community and scientific community in Italy. So I'm acting as a project manager. And my background is a mechanical engineer, and so I had also some experience in systems engineering of space initiatives. And I also represent ASI in some of the exploration board. I'm representative at ESA. So as I mentioned, we try to harmonize our contribution to ESA with what we try to do at a national level or in partnership with other, in bilateral partnership. And so I'm at the Exploration Utilization Board representative, and I also, as a delegate at ISECG, International Space Exploration Coordination Group. I'm currently vice chair of ISECG, and I'm co-chair of the working group that is focused on the exploration roadmap preparation, is the ERWG. Thank you for having me.
Thank you very much. We have the honor of having you all here. You have plenty of experience, and I'm sure that you will have plenty of ideas to share with us today. So our panel today will talk about lunar governance, right? So what do we mean by lunar governance? And we have seen that we went from the UN Committee on the Peaceful Uses of Outer Space to ATLAC to ESA to MVA GEXLA to space agencies, to commercial actors, so we have bits and pieces of everything here. And so I would like to ask Mr. Funaki to start with you. JAXA, and we have had the opportunity to see this in the morning, JAXA brings deep experience with operations, with space operations, and substantial contributions also to the Artemis architecture. I would like to share a little bit with us which are the most critical systems maybe for cross-program interoperability. Maybe that would be something that we would be interested to find out.
Yeah, so I suppose you are asking a very difficult question, I suppose.
You can make it easy. It's
because,
fine.
JAXA has a lot of experiences. I introduced in my presentation this morning, about HTBX, our cargo system toward international station. So in that case, that cargo vehicle will dock with international station and provides various material onto that ISS. And after that, the cargo module is released from the system, ISS, and go back to the Earth. And such system is quite trained for our institute or agency, JAXA. But in the case of lunar surface, the situation is quite difficult to expect because, it's not just a space operation. Maybe we are on the surface of the lunar. So, of course, you can try your docking with, for example, your station, maybe by using our pressurized rover system. We may try, but we have to preliminarily prepare some interface design. Because, in case our JAXA pressurized rover want to be connected to your space station by China, if the docking interface is not clearly defined, or if our docking system is not uniquely designed, our docking will not be successful. So, we have to, first of all, have interface standard. So, in the case of ISS, we usually employ international docking system standard, and it's quite unique, but it's quite good standard to be employed if we operate it in the space. But on the surface of the moon, it's much, I think, difficult because lunar has a dust effect. Lunar has many other environment because in the case of ISS, we usually monitor almost everything, but we cannot monitor the surface of the situation of the lunar easily. So we have monitoring system, but we cannot monitor them all. So that means we cannot control the docking mechanism just by the ground operation. So we have to also rely on the in-situ or local activity. I mean, astronauts has to operate some of the docking mechanism. So I think we need, first of all, standardization for the lunar surface system, and we have to consider how we operate such docking or berthing system, because in the case of ISS, usually ground-based operation is the best. But in the case of lunar surface activities, it's much difficult. So that means we have to employ a hybrid system that will be monitored by the ground system, providing very important strategy. But on the surface of the moon, we have to locally decide, depending on the situation. They cannot be seen from the ground. Maybe that's the first comment I can make.
Thank you very much, Mr. Funaki. You have offered us a very valuable input, and I would like to make a connection with the activities that we currently have in ATLAC. We have invited member states, in fact, Japan, I think it's going to come in December. We have invited member states to make presentation of their lunar activities, and we have been identifying until now 2 challenges which are supposed to address the whole community. And the first one is the lunar dust, as you mentioned, lunar dust, and the second one, or the other way around, doesn't matter, the selection of the landing sites. So you were right on point with your comments today. Thank you very much for this. I would like to continue with the Israel representative, Mr. Sudhakar. We know that India's Chandrayaan missions, and of course you have presented this morning, it positioned Israel as both a technologically mature lunar actor and a trusted interlocutor across geopolitical lines when we discuss the lunar governance. So the question for you is, where does Israel see the strongest opportunities for India to help convert subsystem standards across various lunar initiatives?
Okay. ISRO as interoperable trust with other spacefaring nations. And as it was told, we had the orbiters right from the 20 years back. We had orbiter-based technologies which can be utilized. And the Chandrayaan 2 had an excellent imaging system which where we can share the data. And we are also had I think in the leader in the long-term sustainability discussions has been happening in a TLAC program where they can define. And as you had seen, Chandrayaan 3 had the lander configuration where we had the guidance navigation control systems, which we are having. I think with JAXA, we have a coordination in the Chandrayaan 6 program. And we also had the hazard avoidance kind of activities, which can be shared with the other people, that technology, the elements of which were used during the Chandrayaan 3 mission as well. And with respect to mobility also, we have the rover activities which can be better utilized, and we also had the in-situ experiments. Some of the experiments was told, which can be again provided as a payload requirements for the further systems. And another major requirement which has been projected is the lunar PNT. So where we are also trying to provide some solutions, and ISRO is proposing to go for a pseudolights based systems, and it also proposing to suggest each lander should have some pseudolight kind of provision which has to be providing the information on its location to all the navigation, which is the most important thing for a safe landing. So we need to have a very good navigation system with a lunar PNT system, which ISRO can definitely participate. And with its own, the STRAC systems, where it can do the navigation operations and ranging operations, which all these facilities are available, ISRO can definitely provide the inputs to the entire community. So another major thing is the DSN network. ISRO is having a wide, that's an important deep space network, which will provide the interoperability requirements from the other space requirements of lunar programs. Definitely it will be able to provide with all the facilities. Recently, you are aware, ISRO went for a docking, and which was successful docking of 2 spacecrafts, which will again has to be a very important technology, which where ISRO can provide the subsystem standardization into all the systems. As was told by JAXA, see, basically the docking and other things, the interfaces have to be defined to avoid duplication of the activity, and there should not be, the standards have to be defined, and everything should be made interoperable, and to also avoid the interference in all the communication systems. These are the major things which have to be taken care. So ISRO can definitely provide this in these activities and further activities. And as was told, the lunar sample return mission also is in the pipeline, where we'll be able to handle the return samples. So all this will be defined, and we'll continue further in our endeavors. Thank you.
Thank you very much. Again, a very, very important feedback we learned from you. 2 comments here. One related to the PNT on lunar cislunar. We have this ICG on GNSS group. under the UN COPOS, and they just became observers to ATLAC, and we'll also be in the future becoming observers in the ICJ on Genesis, and we are going to look together with the 4 co-chairs, which are coming from ESA, JAXA, Chinese Space Agency, and NASA. We are going to look together to see how we can develop jointly meaningful concepts. A second point that I wanted to make is related to this information sharing. You have mentioned information sharing and no interference, which is currently in line with our mandate under the Article 9 of the Outer Space Treaty, that is no harmful interference. Thank you very much for this. With this in mind, I would like to move to Mr. Wang Zhongming from Deep Space Exploration Laboratory that manages the scientific and the engineering framework for the International Lunar Research Framework development. The question for you, Mr. Zhongming, is which ILRS subsystem domains or system domains are most amenable to technical coordination with external partners at this stage?
Okay. So it's the people have mentioned a lot of about the lunar cislunar PNT, and it's also from the yesterday presentation and today's presentation is also a lot of a project is talking about the landing on the solar region and also even the dark side of the moon. That would be needed the data relay system. So it's of course it's several plan, several proposal have issued from the NASA, from the ESA, like the LunarNet, like the Moonlight. But as one is I can want to mention that it currently is only China have the 2 of the data relay satellite. It's called the Churchill-1 and the Churchill-2. Is still working in the cislunar orbit in the locking point. They can provide the data relay service. Yeah, we already have successfully made the soft landing on the far side of the moon and the sample returns from the far side. And in the next year, we will also have the polar exploration in the South Pole. So it's all of the activities is a relay on those of the data relay, the satellite. So it's this is already part of the lunar PNT can be contribute to the international community. So I'm thinking that before this the LunarNet, before the Moonlight, they have launched the first satellite to providing the communication, providing the navigation system. So we just the China can contribute to the helping for the other international partners, if you like. So this is also that if you like to use that service, you can just also to study, to coordinate with the China and the CNSA for the interface, for the frequency, and how to provide those for the services. Beside of the lunar PNT, because in China we have push the next generation of the PNT system. That's not only the GNSS around the Earth, also the on the ground, also on the cislunar space. So we can just have integrate of the GNT system. So we also would like to contribute under the frame of ATLAC. We would like to participate into the working group. We would like to coordinate with all the partners from JAXA, from Israel, from NASA, from ESA, to have to establish the standards together for the lunar PNT. And another part, as I have mentioned in my presentation, that is we also would like to push for the international cooperation project. Why that? Because it's a go through those of the large scale, the international cooperation project. So many of the countries can participate. For that project, we need to set up the standards. We need to set up the unified interface. So there will have some the interface between the payload to the satellite, between the satellite to the launchers, and also we should have the interface and standards for the constellation, how to control, how to TNC, how to manage all of the ground station together, working together, and to have a scientific study together, and how to manage for the transmission and the distribution of the data, and to also have jointly to organize the project. So those of is also quite important for the compatibility and the interoperability of the lunar activities. So we can just starting from the one of executed the project, we can just rehearsal by the international community to make to see that how we can just working together, how we can just set up the unified standards and unified the coordination, so we can just then just how push to the even further bigger the project. For example, like the intercompatibility and the interoperability between the RS and ADMIS and other projects. Yeah, so everything we can just under the framework of the United Nations of the ADLAC. And thank you very much.
Thank you very much. A bonus question for you, because you mentioned so vividly this international coordination. I was wondering, maybe you could also share a little bit about your work in GEXLA, Global Expert Group on Sustainable Lunar Activities under the MVA, because Mr. Wong is the co-chair of the Working Group 3. So maybe you could also share a little bit about your activities there.
Yes, so the Working Group 3, we have about 20 of the experts from the different countries. They come from the government, from the industry, from the universities. So every month we have the joint the meeting, the webinar, as we are the Zoom under the chairs, and we will have to find out one of the topic. And we have to yearly to make one of the reports. So we will study different the opportunity of the international cooperation, and we will find what is the difference and what is the best the organization format, and also we'll give some suggestion for the best the solution for the stakeholders. That could include the government, like include the intergovernmental organization or non-governmental organization, the academicians, and even the public. Yeah, so that's we hope that that is a recommendation that will be helpful for all the coordination activities within the United Nations. Yeah, to make some suggestions. Thank you.
Thank you very much. Finally, Mr. Simone Pirotta from Italian Space Agency. As the head of robotic exploration and vice chair of ISEC-G, how can Italy leverage this global exploration roadmap to align technical standards across different lunar programs?
Well, first of all, I'd like to give feedback and an answer related to some technical aspect that comes from our experience in Europe, running now from a long time joint project among all the European countries through ESA. I think that one is an important experience because we work under a set of technical standards that are named ACSS. And this common background that they are, I don't know if you're familiar with that, but there are a set of technical standards covering management, engineering, and quality assurance aspect. And when we participate as a European member state to an European project, we have to incorporate them as applicable basic elements. So having them as a common technical basis guarantees that the elements that, I don't know, the French payload that will be embarked on a German platform will have a common base of interfaces at least. Then there are requirements that are tailored to that application, to that unit, to that instrument, whatever. But having a CSS as applicable and that it's needed, this is an important example. I think it's a good basis to be a good positive example on how standards can facilitate the cooperation and different contributions. And of course, Italy is strongly convinced that of the importance of this aspect. We that we are active member of both of ISACG, but of many of these initiatives, including ATLAC. We recently joined ATLAC, and we wanna contribute to it. And again, in the exploration roadmap, the roadmap itself. I don't know if you're familiar with the document. It's as different sections. The roadmap itself, the chart depicts the roadmap is the time plan of the different steps to reach to Mars, with the moon in the middle. But the document highlights many aspects, including interoperability, the importance of this element, and we think that leverage on that common basis that have been agreed between 29 agencies, including China, JAXA, and CNSA, we have for China, and JAXA and ISRO, all the main agencies, they agree that one is the vision, not only the roadmap, so how we can move step by step, but what is the common vision. We recently were working on a common vision on sustainability too, not an additional definition, there are so many definitions about it, but how the sustainability is mapped with respect to the exploration principles. So as Italy, we are strongly convinced that our experience in ESA is a good background, and that all this more wide and global vision should be based on that good experience.
Thank you very much. Italy now has a pivotal role, at least for starting with 2026, as also the country holding the chairship of the United Nations Committee on the Peaceful Uses of Altitude, but also as the presidency of the IF, right? And perhaps many others. Thank you very much for this. Before we go to the second round of questions, maybe we can open up to the audience, see whether you have some questions or comments.
Dr. Wang, thank you very much. Can you tell me about how you relay the data? Because it should be the real time, right? For the controlling the landing, right? So are you using the very fast the telecommunication skill, or can you store the data once you get the other side of the moon? And then it will send to the control module, or what is the operation? Operation is given from the Earth, or operation is given from the satellite, or how the relay will work?
Yeah. Okay. So you know that is it's difficult to have communicated once it's making the landing activities on the far side and also the polar region. So therefore, they needed another satellite like the rotor they put on the cislunar space. So therefore, we have the Churchill 1 and 2 of the data relay satellite put on the lockdown 2 point. So that will be to see that both of the far side of the moon and also the ground station in the Earth. So they can just have the data relay, the communication real time, the service to support that missions. Of course, if one have such international cooperation to support the other of the missions, we also have the cooperation experience before. So before ever of the China lunar mission from the Chang'e 1 to Chang'e 6, we have agreement between the agency to agency. So it's China Space Agency have agreement with ESA. That will be the backup support, the TTNC, the stations. Yeah, because China have their own global the TTNC network, and ESA have their own TTNC network, so they can just support each other. Whenever one have the lunar mission, there will be such of the backup support. So therefore, I think we can go to the existing, of course, the technical channel that also is a political channel that we have the experience to do that. The support if the further of the international partner want to have also the mission on the polar region and also even for the far side. Yeah, so that will be experience could be learned. Yeah, could be used. Yeah, for those of the coordination between the TTNC network to the TTNC, another TTNC network. Yes, that will be to making the real time the support to the another mission. Yeah, that's my so. Thank you.
Thank you. Maybe you have some other questions or comments from the room? No? Okay. Then you still have time to think because we're going to the second. Okay, there is someone there.
Thank you very much for discussion. I have a very particular question about nuclear launches. So currently, actually, lunar night survival and a lot of things develop on the ability to deliver nuclear payload there. Currently, only U.S. has authorized actually nuclear launches, also going into the direction of the commercial launches. Now, Europe tried to do that, but not yet. My question is whether other countries also see the opportunity to develop nuclear launch capability, maybe commercially. Is there any idea of international collaboration or treaty for that? Thank you.
Thank you for the question. Who would like to answer, to try and answer that? Or the question was targeting... no. Okay, to everyone. Yes, please, Mr. Funaki.
Yeah, so as you might know, JAXA doesn't have so much capacity to make large nuclear devices, but using Japanese government space strategic funding, we are working on the development of radioisotope heater, not power generator. It's a very small aluminum type heat register, and we are working on the development of the cell and the system unit, and also we are trying our best to identify the both technical or safety issues of launching that from Japanese launch sites. And so we are considering to use, in the long term, heat generation device or preferably power generation unit. But it's quite difficult for making up, for example, 10 kilowatt or 50 kilowatt or more, 100 kilowatt unit. It's quite time-consuming technology challenge, and it's very costly. So yeah, maybe our style is starting from a very small unit, not including plutonium.
Thank you very much.
Similarly, ISRO also is working on the RHU, radio heater unit, isotope, and RTGs also, that radio thermoelectric generators, which is very important. See, one more, the morning presentation also was told, the JAXA presentation was telling, selecting the component, whether it will survive for the post-lunar night is another way of handling the system. So that also we are into that to select the components such that they survive their lunar night so that they are available. Thank you.
Thank you. With that in mind, I'd also like to mention that there is this working group under COPOS, working group on nuclear power sources in the outer space, that soon in June, I think, they will have this joint workshop with the IAEA on this topic, and perhaps that will be an open event, and of course we invite everyone to take a look and see what member states are doing in this subject matter. Thank you very much for the question. With this in mind, I've learned that we don't have much time left, so we probably don't go to the second round of questions. But I would like, as a conclusion, from each of you to share a little bit some thoughts, perhaps on the yesterday's event, on today's discussions, and perhaps where are we going from here in terms of lunar governance. Please.
Yeah, I can just comment that it seems that we are all aligned with what we need to do, and it's good to see that there are this initiative like ATLAC that they're trying to harmonize the approach and balance the different needs and the different visions that are around, as well as we are doing at ISAC-G. We're trying to find a good compromise to have a shared vision. Moving it to the technical side to guarantee interoperability and inclusivity, it's a further step. You were ready to ask me about how to include also emerging space agencies, which is something important too, because here we are talking about established ones. And there are different approaches. We consider, for example, also natural analogs or other geographical features that can be a way to make everyone part of this important challenge for humanity.
Thank you very much. Mr. Funaki?
Yeah, so when I received your document from you about this organization, you are talking about to explore how Artemis partners and ILRS partners can advance interoperable lunar activities. And that was the first time I was asked to consider that theme. So within our European partners, yeah, as you said, we have a very good standard concept. So all we have to do is just follow the standardization and to talk about the interface design. So it's not a problem. But if we explore more a variety of cooperation, including China, so we have a lot of issues for establishing our RUPEX project because our standardization is different. So standardization is, worldwide standardization is quite important, I suppose. And another one is COPAS role is quite important for us because you can reach our Artemis partners and China ILRS partners. So maybe we can continue our discussion because, first of all, we just make stations in the Artemis team and ILRS team, but we have to interoperable in the long run. So yeah, your role is quite important, I suppose. That's my message.
Thank you very much. A very nice message. I'd also say that in addition to the work that we're doing under the UN COPOS, we also have some other levels and layers. And one of the layer is, of course, GEXLA, where we are trying to bridge these communities together. So thank you for this comment. Mr. Sudhakar.
As was told time and again, the moon of the future will be basically a collaborative, safe, and sustainable environment which will pave the way. The different nations and commercial entities and emerging states also, future emerging states also will operate on interoperable system. A harmonized way of intercommunication and navigation, mobility and power architectures, and which coexist. This Artemis and ILRS, every mission will be coexisting along with each, and we see that we collectively respond to the challenges which are going to be put, and the backbone of all this is going to be defining the standards and developing the trust between the systems, which is the important thing. And I understand that COPOS and ATLAC is going to provide the framework for doing all these things. And teams like MEA is going to organize the programs so that people interact, come to a place and discuss all this so that they are all settling into that. And a practical step may be to organize a framework, how to go about further in the ATLAC, similar to that ATLAC framework, and go for the registry and interoperable system, how to start about a framework and then work on that. And so this is what is the future, and it will be interesting to go further. Thank you.
Thank you very much. Last but not least, Mr. Monk.
Okay. It's my second time in the MV's workshop and the symposium. So every time I learn a lot of, especially this quite the quick development and progress of the the global, the lunar activities. So it's a lot of the new design, the new mission, new prospect that we'll be discussing, and also it's a lot of topic to go through all of the panel discussions and all the other methods. So it's therefore I'm thinking that is such of the platform is very, very important. So it's on the top at the United Nations level, so that the ADLAC, so it's working very well, and it's the government will be state will be and have the political people and also technical people have such a state level to coordinate to discuss. But we also have such of the platform like MV, like the GEXLA. So it's, I'm working in the GEXLA, so it's the working group every month is working together to have a lot of idea to discuss, to focusing on one of the problem, to make some suggestions, to make the final result, to have contribute. And also that is, we have the more of the such of a platform like the ICG, the ISAC, and also the ITU. And also yesterday I present that is, we have the new of International Deep Space Association. So we are also the new platform. Therefore, I would like to also invite people, everybody just learn more about our association. So the official the website will be launched very soon. So we would like to invite you, because every first week of September we will have the ceremony also. This called International Deep Space Exploration Conference. We call it the Tiandu Forum. The Tiandu is the peak of the Chinese very famous mountain. So we already have 3 years such a forum. So it's many of this already have been in Hefei. So it's Pacific. Every year we have a different topic. So it's for the whole of the deep space program, for the LRS, the lunar mission, and for the asteroid exploration defense, and also the next year maybe for the lunar PNT, for the Mars mission. So I welcome to everybody can just come to participate into those of a discussion. I think it goes through not only the government level, but also the academic institutions, even the public level. So it's using all of the platform. So we can just enhance those of international collaborations, coordinations, interoperations, everything just very quickly. Yeah, this is my feelings. Thank you.
Thank you very much. Also, I would like to share that I'm a proud member of, individual member of IDEA. I look forward to the forum next September. With this in mind, I understand that we have one more question, comment.
Yeah, I have a question to all of you. Well, first of all, thank you. It's an excellent panel. What is the role of industry in interoperability? Because, of course, we keep talking about, rightfully so, ISAC-G and all other, which are space agency level. So could you please, each of you, maybe very briefly tell us what do you think should be the role of industry in the definition of the interoperability on lunar mission? Thank you.
Maybe at first. So that it's in the industry, especially the commercial industry, is very important right now for the deep space, the missions, especially the lunar mission. So in China, under the agency, we have the new bureau just established a few weeks ago, is to enhance the commercial, the space development, and so also for the policy have published by the government. So therefore, currently in China, have thousands of the commercial companies. Some of the startups, some of them already have a few years. So they are working on each of the chain of the space, and also is we are willing to contribute into the lunar mission. So, for example, in the all association is already have a lot of the institutions, the companies, the commercial companies to be the member. And also, yesterday when I mentioned about the International Cooperation History Project, this is also a lot of the commercial investment. They are willing to invest. And the launcher, even we are not using the government launcher, we are using the commercial, the launcher. That will be have to push that for the industry more actively to participate into the lunar mission. So yesterday have also a lot of presentation talking about the lunar economy, and so this year we also have mentioned that the new concept that the deep space economy. So there will be many of the opportunity. I think there will be ever of the opportunity will be realized and make a lot of money for those for the commercial companies. Thank you.
Thank you very much.
So we expect the industries should be coming for the standardization as well to identify the problems early and finding the cost effectiveness, identifying the failure modes, and bring the standards on implementable standards. Somebody has to come into the implementable standards, so we get into the prototyping very faster and get the results. And then that's most important expected from the industry, where a lot of expertise is there, which we'll be able to use the systems and get going. Thank you. Thank you.
So in my opinion, agency's role is very limited. Maybe making some base station, but servicing is industry's part. For example, power grid, maybe PNT, mobility, they will be provided in the future by industry partners. Maybe that's the best approach.
Yeah, just a quick comment. Of course, industry must be involved in this process of establishing. Of course, as your question provoked this reaction. The standards should have a solid technical basis. Of course, they must be flexible enough and must be adopted in a way that is effective. So, of course, they will play an important role. The risk is that they will anticipate and they will go through a path that is not coordinated enough, maybe because they are going through the best option that is not necessarily the most widely adopted. So there must be a strong dialogue between all these actors to coordinate, to guarantee that it will be accepted and shared.
Thank you very much. I should also say a couple of words about that. As per our mandate, methods of work, Article 10, ATLAC is supposed to have the support of the United Nations Office for the Outer Space Affairs, for the Secretariat, and the perhaps connection with the industry. And they have launched this platform called One Moon for All, where we hope that MVA and GEXLA will be part of it, but perhaps some other organizations. So there is an attempt to basically bring the voice of the industry and the voice of other actors, maybe even academia, NGOs, and so on and so forth, to the United Nations. So that when we're gonna talk next time about lunar governance, then we will talk about having in mind all the voices that have something to say on that. And with this in mind, I would like to draw the conclusion here by saying that lunar governance is basically performative. It means whatever we make out of it. We have heard so many keywords here: interoperability, harmonization, balance, communication with the audience, with the industry, with other actors, interface design, registry, and so on and so forth. I leave you with these keywords as food for thought, and thank you very much.
Thank you for the really nice panel. Maybe we can take a picture all together, so please all the speakers there. In the meanwhile, I just few words about next session. Okay. Yeah. Now this panel, and then if there are also the speaker of the previous one, we can also make the other picture. And in the meanwhile, now we have two parallel sessions. Actually, in this room, we will continue with the human physiology and the astronautical panel. And in the room Lisbon, there will be an interesting panel about public-private collaboration model to foster lunar economy. So, in case you are interested, Lisbon room is just here behind, a few meters far from this room. So, it will start in a while. So, please, you take a picture. Perfect. There is. Okay. So, introduco subito. Grazie mille. There is. Okay. If there is not, there is also my colleague.
Che siamo evasi, va bene? Unisciti. Noi lasciamo una traccia di questa cosa. Logan Wave, please, can you join us on stage for the picture of the panel 7?
So if there are the panelists of the previous panel, we can still take a picture together, actually.
Sure, I'm sorry. Antonio, c'è Mohammed in giro?
Okay, so please. Thank you. We missed Michel Lavagna. I don't think he's here. Michel, probably. Non so se arriva Michel Lavagna. Come? Se no, non possiamo fare. Facciamolo così, facciamo. Ok. Okay, so I think that just the time to take the picture, and we can proceed with the next panel about human physiology and astronaut panel. I'm happy to invite on the stage the moderator. So please, Carlo Aleci, you are welcome to the stage. So please, I give you the stage.
Yeah. Thank you. Thank you very much. Well, may we start with the first slide? Yeah, this is. Okay. Well, great. Yeah. Just a second.
Questo come faccio ultima in data?
L'ho messo già come data di modifica.
Space V. No, non è questa, no. C'è scritto chiaramente Moon Village. Ah, ecco, forse c'è un folder.
Quale delle due?
Quella Moon Village, la prima. Ecco fatto.
Is already there. It's already there. Ok, so.
Questa qua,
Perfetto. E poi dopo io gli faccio parte delle altre.
Perfetto, very well. Ladies and gentlemen, welcome to the panel 3 of this symposium. I'm deeply grateful to the astronauts Franco Malerba and Dori Prunario in alphabetical order who joined us today. And please, you're welcome on the stage. Thank you. You're welcome. Dori and Franco, welcome. You make us feel the moon closer. more reachable. I've tried to read your biography, but it's too long, too rich, too full of words that I've not been able to learn it by heart. However, thank you for here today, for sharing your experience, for feeding our space dream. Feeding, by the way, is an interesting term, to feed. I imagine it's not easy, Franco, to... Sorry?
Is there a control of the pictures?
Yeah. I know that providing food up there on the moon is kind of rocket science, but I'm sure that Franco has something in store for us to tell us afterward. However, let me introduce you the working group of human biology and physiology of the Moon Village Association. The working group is chiefed by Thais Russomano, Professor Thais Russomano, and it aims to investigate and discuss the effects of space and moon environment on the human organisms and possible countermeasures. This includes, but is not limited to, the physiological and pathological alteration at that multi-organ level induced by micro or hypergravity, to the pathological alteration determined by radiation, to the psychological aspects related to isolation and confinement, and to the psychological issues stemming from particular social dynamics and co-interaction. In addition, we intend to inform and sensibilize the public. Online meeting and webinars are the main tools of the working group. And the research with publication of articles on international journals is naturally welcome and supported by the group. Well, so we invite whoever is interested to join us. You're welcome, and we need your help. So please consider this possibility. Dorian, Frank, well, before giving the floor to our guests, let me remind you with a brief presentation that once the challenge of establishing on the moon is completed, a new crucial challenge arises. I mean, staying healthy, and in particular, maintaining good vision. If we really aspire to become lunars and truly intend to live on the moon in our lunar village, in our lunar houses, well, then we must know very well what to expect there. On our planet, there is an atmosphere that protects us against space radiation. And there is a gravitational force that is constant in module and in direction. Well, evidently, on the moon, there is no atmosphere. This means free way to radiation with its well-known oncogenic and degenerative effects. Gravity is weak. And last but not least, there is a lot of dust. Hypergravity and radiation, in particular, are the main threats of all living organisms, including humans, naturally. Here you see, here is a not exhaustive list of the health issues posed by space, and with all probabilities by the moon. You see, down, the visual system is at the end of the alphabetical list, but it jumps to the top of the classifier, according to NASA. Between 1961 and 2020, consider that 269 ocular complaints have been documented. As reported by TIMCO, visual impairment is currently the National Aeronautics and Space Administration's top health risk for long-duration space flights, and millions of dollars have been allocated for research funding to investigate the mechanisms responsible for visual impairment after space flight. On the one hand, gravity is the fiercest foe when it comes to launch a rocket beyond the atmosphere. But on the other hand, in gravity, life developed. Gravity has molded our biology, our physiology, some our organism. We are all gravitational beings, and our body cannot do without gravity. We know it very well. In a world with reduced gravity like the moon, the organism suffers, and suffers a lot, and the eye is not an exception. In condition of micro or hypergravity, a redistribution of fluid with a shift of blood from the lower part of the body toward the head takes place. This body shift leads to engorgement of the cerebral veins and reduced drainage of the cerebrospinal fluid that fills the space between the meninges, including the meninges that wrap the optic nerve behind the eye. This generates a mild but sustained increase of the intraocular pressure and, what's more important, of the pressure around the optic nerve. In fact, you see, the meninges of the brain and the meninges of the optic nerve communicate. Now, increased perioptic pressure squeezed the optic nerve like a chewable toothpaste, causing swelling of the optic nerve head, deformation of the eyeballs that shortens, in technical terms, we say it turns hyperopic, and other less evident neuro-ophthalmological alterations. Here you see the optic nerve swelling, as on the right, the ocular globe flattening post-flight compared to pre-flight. This explanation, you understand, is way too simple, as you can imagine, but it serves for our purpose today. This particular neuro-ophthalmological condition was first reported by Mayer in 2011 in astronauts after returning from long-term missions on the International Space Station. It has been defined spaceflight-associated neuroocular syndrome, or SANS. Astronauts affected by SANS complain reduced visual acuity, especially for near vision. But these astronauts were engaged in relatively brief space missions, let's say 6 months, 1 year at maximum. Now see the slides. We know the longer the mission, the higher the risk of having SANS and the more severe the symptoms. Well, but now we are not talking of a mission, of a brave mission. We're talking of a long stay on the moon, several years, maybe a whole life. So we should expect other visual problems in addition to reduced visual acuity, namely abnormal color perception, decreased contour sensitivity, and visual field defects. You see, this could be the final outcome, hopefully in the worst of the cases. This is, I hope, the worst of the scenario. Now, the crucial question is this. Is the 6th of gravity of the moon enough to prevent SANS? Well, it is unlikely. Because to prevent or minimize the risk of SANS, at least half the gravity of the heart is required. So, the weak gravity of the moon might mitigate the signs and symptoms of these clinical conditions, but it is unlikely it can prevent them. And it follows that countermeasures are mandatory to prevent not just SANS, but a general multi-organ deconditioning. The centrifugal force is able to generate periods of artificial gravity that counteracts the upward shift in the body induced by hypogravity. So we could exploit it. The most straightforward solution would be a rotating habitat on the surface of the moon. This is conceivable, sure, but at the moment it is hard to realize for a number of problems. As an alternative, small centrifuges to be installed inside the lunar habitats are under investigation, as well as the so-called low negative pressure chambers that exert a negative pressure on the lower part of the body. This way, fluids and blood in particular are sucked from the head and pulled toward the feet. But you see, it is not only hypergravity the problem out there. You know better than me, I'm sure, that outside low Earth orbit, where the shielding provided by the Earth magnetic field is lacking, astronauts are exposed to a lot of radiation, in particular solar particle events and galactic cosmic rays. Consider that on the moon, radiation exposure is about 250 times higher than on Earth. Radiation enhanced the oxidative processes typical of the elderly, leading to cancer and tissue degeneration. And the eye, not covered by the skin nor shielded by bone like brain, is extremely sensitive to radiation. Lens opacification, that is cataract, is a main consequence of radiation exposure on the eye. And cataract means sight loss, as if it is not treated, it means blindness. The NESCA study shed light on the characteristics of the cataracts in astronauts. The main responsible are the HZE particles, but what's more interesting, there is a dose-effect relationship. Now, thanks God, surgery is most of the time resolutive here on Earth. But how can surgery be performed on the Moon in condition of microgravity or hypogravity? So evidently, as for hypogravity, effective countermeasures are mandatory against radiation. These countermeasures are both physical and pharmacological. Physical countermeasures are protective shields made of innovative plastic and high content of hydrogen, are wearable protective shields, and electromagnetic shields called active anti-radiation shields. Active anti-radiation shields create an artificial magnetic field that mimics the Earth's magnetosphere. Thereby, it would deflect the radioactive particles. In addition, pharmacological countermeasures should be considered, namely dietary supplementation with antioxidant substances. Antioxidants counteract the effect of the radioactive particles at the cellular and subcellular level. Let's consider the fact that vegetables are very rich in antioxidants. We said that the Moon is a dusty world. And outing outside the habitat for a picnic, let's say, to the mare cognitum, means getting back covered with dust. A dust that is harmful for the lungs and especially for the eyes. Moon dust, we know, is called regolite. It is a compound made of silicon dioxide, aluminium oxide, calcium oxide, magnesium oxide, titanium dioxide, and iron. Compared to the common dust on the Earth, moon dust particles are jagged due to the absence of weathering. Moreover, they tend to remain in suspension due to low gravity and move blown by the air currents generated by the ventilation system. For all these reasons, regolite is more dangerous than Earth dust when entering in contact with the ice surface. Indeed, regolite may be responsible for eye irritation, like the exposure to volcanic ash here on Earth. As a matter of fact, the likelihood of ocular injury is higher in space compared to Earth, so that 67%, more than 2/3 of the ocular complaints in astronauts are due to an eye abrasion from a foreign body. Wearing protective goggles may be sufficient to prevent this issue, but a device able to remove the dust from the suits and the space and the surfaces on the habitats is desirable. Indeed, this is the moon duster. The moon duster exploits the electric charge of the metallic composition of the particles to remove up to 85% of the material from surfaces and spacesuits. But apart from the dust, in the lunar habitat, the clearance of carbonic dioxide is reduced and there is no natural ventilation. Indeed, ambient CO2 levels on the International Space Station are about an order of magnitude higher than on Earth. In addition, the absence of convection currents causes exhaled packets of CO2 to remain close to the face, particularly when sleeping. Now, even at moderate concentration, we know that CO2 may induce disruption of the tear film with corneal and conjunctival irritation and burning and stinging pain. To address this issue, the 4-bed carbon dioxide scrubber has been developed and it is operational on the International Space Station as of August 2021. Last but not least, environmental humidity is reduced in space habitats compared to Earth. Low environmental humidity increases tear evaporation, predisposing to the so-called dry eye syndrome. Dry eye syndrome is characterized by eye irritation, ocular redness with sensation of foreign body, and in the worst of the cases, reduced visual acuity. In addition, dry eye increases the risk of infection and irritation, including those induced by the lunar dust. Note that the recommended humidity level must be more than 30%. Dry eye in astronauts can be avoided by an effective humidity regulation system. The temperature and humidity control system on the ISS ensures a relative humidity level of 60%. That is well above the recommended 30%. And finally, drops that simulate the tears, the so-called artificial tears, are already part of the medical kit on the ISS and must be available in the moon habitats. Well, you see, this is all a small piece of a huge puzzle. And this is just one of the reasons that makes this man in blue jacket here close to me true heroes. We can and must trust that despite microgravity, despite radiation, despite dust, despite all odds, we will go up there. And we will do it to stay. Determination. It is, after all, the characteristics of the human being. Determination to overcome the challenges that seem impossible and go on with a new one. Determination, the characteristic, but let me say, the vocation, and I believe probably the ultimate meaning of the human existence. Thank you. And now, Franco and Dorian, full speed ahead. We're all yours. Is there any question? Before we let we give ground to...
Okay. You should see this slide. Yeah. Thank you very much. I have two. You showed Kajima's project, and I will talk this in today about artificial gravity, because we are doing the joint research. So if you can take a look at the why you say it is not possible. It is difficult, but it is possible. But they will take a lot of money. It is real. And also my other question is, how do you deal with radiation protection? You are saying the rigorous protection, but how about radiation protection? I think it should be very serious, but how do you?
This work. Well, the problem of radiation under a neuroophthalmological point of view is a crucial one, because radiation affects the eye probably more than other organs. I know that there are projects to prevent the effect of radiation on the eye. Radiation generates cataract, but radiation may induce also a particular form of retinopathy called radiation retinopathy that is very aggressive and may lead to severe symptoms and signs. So it is mandatory to provide shields, effective shields, wearable shields, and other kind of shields that allow astronauts to work safely and to live safely on the moon. Okay, so we can we go on with our astronaut Dorin?
Thank you. Thank you very much, and I'm very glad to have the opportunity to present so important topic for the space flight, and my presentation will try to compare my 8 days space flight around the Earth with possible 6-month space flight on the Moon. Okay. Changes? Or maybe enter? Just one moment.
Okay. Oh, they are sharing.
Yeah, okay. That up? Left, right? Okay. So, well, when I flew in 1981 aboard Soyuz 40 and spent 8 days docked with Salyut 6, Romania became part of humanity's journey beyond Earth. That mission performed in microgravity offered the first-hand experience of how profoundly space affects the human body and how remarkable our capacity for adaptation can be. Okay, no, the other one. Today, as we prepare for a 6-month human mission on the moon, the challenge is no longer survival in orbit, but sustained life in a partial gravity environment under intense radiation and deep isolation. As a member of the Moon Village Association's Lunar Human Psychology, okay. Okay. It's so easy to touch the test and change the slides. So as a member of the Moon Village Association's Lunar Human Psychology and Biology Working Group, LHPNB, I have contributed to analysis and discussions about how humans may adapt physiologically and psychologically to prolonged residence on the lunar surface. From microgravity to hypogravity, in low Earth orbit, I experienced complete microgravity. Body fluids shifted to the upper body, muscle tone declining, balance systems readapting. Yet all these effects reversed quickly after landing. On the moon, gravity is about 1/6 of Earth's, a condition we call hypogravity. It is not weightlessness, but a weaker constant load. We still know very little about its long-term effects. The LHPNB group stressed that the steady-state physiology of human in lunar gravity remains uncharted. Bone loss, muscle atrophy, and cardiovascular deconditioning will continue through perhaps more slowly than in orbit, requiring intensive exercise and medical monitoring. About radiation and lunar dust, new biological frontiers. During my flight, Earth's magnetic field offered protection for most cosmic and solar radiation. On the moon, that shield is gone. Radiation dust could reach hundreds of millisieverts in 6 months, significantly increasing cancer, cardiovascular, and neurological risks. The LHPNB group highlights the urgent need for radiation shelters, regolith shielding, and biological dosimetry. Lunar dust represents another major hazard. The sharp electrostatically charged grains can irritate lungs and eyes as infiltrate equipment. Apollo astronauts describe it as smelling like gunpowder. Over months, chronic exposure could damage respiratory tissues and immune defenses. Preventing dust intrusion in a biomedical priority for future missions. So, medical and psychological adaptation. The human body in space must re-establish equilibrium in every system. Fluid redistribution in hypogravity will stress the cardiovascular system and may cause post-flight hypotension. Radiation and confinement weaken immunity. Latent viruses may reactivate and microbiome may lose diversity. Bone density might drop by 1-2% per month, while muscle mass could decline up to 25% without countermeasures. On Salyut 6, these processes were mild due to the mission's brevity. Over 6 months, they could become chronic and clinically significant. Our MVA working group recommended continuous psychological monitoring, tailored nutrition, and precise exercise regimes using resistance and vibration systems. On orbit, Earth was always in sight, vivid, near, alive. Communication with ground control was immediate, and the knowledge that one could return home within hours was reassuring. A lunar mission transforms that context. The crew will leave 3 days away from Earth, maybe 4, facing a communication delay and the sense of distance that no technology can erase. The lunar nights last 14 Earth days, enveloping the base in long darkness. Isolation, monotony, and confinement become existential challenges. In our LHPNB discussions, we emphasize the need for psychological countermeasures, structured routines, meaningful work, social cohesion, and regular visual contact with Earth. Multinational crews will require training in empathy, cultural adaptation, and emotional regulation, qualities as vital as technical skills. About nutrition, water, and sleep. In 1981, my meals were dehydrated and standardized. On the moon, crews must develop partial self-sufficiency, growing fresh plants, recycling water, and adapting diets to reduce inflammation and muscle loss. Food becomes medicine and moral. The LHPNB group sees nutrition as a countermeasure to both psychological degradation and psychological fatigue. Sleep regulation is equal critical. The moon's 29.5-day light cycles forces the creation of an artificial 24-hour rhythm inside habitats. Proper lighting and scheduling will protect circadian health and cognitive performance, just as strictly daily routines supports us aboard Salyut 6. Something about medical autonomy and emergency preparedness. On my mission, medical support was only minutes away by radio, and evacuation could occur within hours. On the moon, it will take at least 3 days for a return to Earth. Therefore, medical autonomy becomes essential. Lunar bases must include diagnostic tools, telemedicine systems, and at least one crew member trained in emergency care. The LHPNB group underlies that in future exploration, healthcare must evolve from remote assistance to on-site practice, using robotics, artificial intelligence, and additive manufacturing to produce medical supplies in situ. A few things about reproduction and the future of life beyond Earth. As exploration turns to long-term habitation, new biological questions arise. Can human reproduction process proceed safely under lunar radiation and hypogravity? How do embryonic development and genetics respond to these conditions? These are profound challenges for the decades ahead, and our working group identifies that as critical frontiers for future research, the foundation for any sustainable human settlement beyond Earth. So, some comparative perspectives between my spaceflight and the 6 months lunar mission. Duration, my spaceflight 8 days, lunar mission 180 days. Environment, my spaceflight microgravity, protected orbit, lunar hypogravity radiation dust. From communication point of view, during my spaceflight, instant, constant. On the month, 1-2 seconds delay. Medical evacuation. During my spaceflight, hours. During the moon flight, several days. Main risks. My spaceflight, short-term decommissioning. 6 months lunar mission, chronic psychological and physiological stress. About the support system. My spaceflight, frequent Earth coordination. On the moon, high autonomy and resilience required. And the goal, during my spaceflight, cooperation, science demonstration, during a 6-month lunar mission, sustained human presence, adaptation study. Lessons from past and guidance for the future. The Intercosmos experience taught me that international cooperation and human adaptability are limitless when united by a shared vision. The same principles guide the Moon Village Association today. On LHPNB Group insists that human presence on the Moon must be built on scientific evidence and ethical responsibility, ensuring health, safety, and psychological integrity for every explorer. My own journey demonstrated that courage and training can take humans into space. The next step demands that we learn to live there. The Moon will become our laboratory for understanding life itself, how it endures, evolves, and thrives beyond its native world. Conclusions? Between science and the human spirit, a 6-month stay on the Moon will assess not only technology, but the essence of humanity. It will push our biology, physiology, psychology, cooperation, and to new frontiers. When I look on Earth from orbit, I saw how small and fragile our world is, yet how united humanity can be when it reaches upwards. Now, as we prepare to establish a sustainable lunar presence, we extend the unity and resilience beyond Earth. The mission is no longer just exploration. It is the continuation of life's evolution into the cosmos, built on science, experience, and the indomitable human spirit. Thank you.
Thank you. Thank you. Thank you, Dorin. Very amazing presentation. And so we can go on. If there are no questions, we can go on with the astronaut Franco Malerba, who will, I'm sure, has in store for us interesting things about vegetables and cultivations and so on. Welcome, Franco.
Thank you.
Please.
Right, so I've put together a presentation a little bit, how should I say, to my taste. When Ray Baldi invited me to this event. By the way, he's not here, so I will pull his ears, Len. Anyway, so I broke my participation to the aerospace meeting at the other side of the fence to join you here, Moon Village Association, who are looking very much far out in the future of space exploration. I am still active in this world, looking more at the short term. In fact, I've set up a startup, a company to build the greenhouses for lunar environments, but also for low Earth orbit space stations. And I'm very much in the doing, more perhaps than in the thinking. But stimulated by the theme of astronauts' isolation and how to help them in this syndrome, in this environment, I brought a connection between the fact that they may be able to taste earthly food, real food, rather than pre-packaged, processed food. This should be a good step ahead. The picture you see is the MPH, the multi-purpose habitat, which is reality, because it's being designed right now by Thales Alenia Space and with the cooperation with NASA in the framework of the Artemis program, is really the environment where our greenhouse would ideally fit. Let me see if I can go ahead. Yes, so this is a picture picture much more, say, science fiction-like, but it helps us understand how in this village, indeed, there will be greenhouses, because it will be time to bring to the moon seeds rather than plants. Actually, we could even rediscover the old days architecture, agriculture, where plants were producing seeds which could be planted on their own. In fact, in the Genesis book, God created plants with seeds so that they can regenerate themselves. So we follow the Genesis in this path. And by the way, I would make a word of, how shall I say, of comfort to those who fear so much the radiation. Once we are on the moon, we can have shelters. So after all, although it will not be particularly pleasant to live in a shelter, however, we will be more protected from the radiation from cosmos and from the sun and from cosmos. The terrible thing will be flight to Mars, as a matter of fact. In fact, I believe that as far as the exposure to radiation is concerned, what is really difficult is the travel more than the installation, the survival in a planet, be it Mars or the moon. Of course, the challenges are very many. But if we take only the one related to exposure to radiation, the worst of all is the 6 months or more months travel to Mars, where we would be protected only by the shield of the vehicle itself. As a matter of fact, now I'm a little bit inventing on the spot. My friend Franklin Chan-Diaz, whom most of you may know because he's an extraordinary astronaut who flew 7 times with the space shuttle. We flew together. He is an excellent plasma physics scientist. He set up a company called Adastra rocket, whereby he would have on board an extraordinary magnetic field to actually confine the plasma beam. And so maybe that this magnetic field that he generates for propulsion could be useful also to screen from radiation. I challenged him on this topic. He says, well, we have already one problem, let's not make it two. But I think this might be a solution. The other thing has to do with the distance, isn't it? So I put together 4 pictures, 4 views of Earth. The one bottom left is a picture from my mission on the shuttle Atlantis. It's Florida, as all of you have recognized. It's important, Florida, because that's our spaceport. But it's really at arm's distance. Geosynchronous satellites see the whole of Earth, so it's after all a more convincing people who believe that the Earth is flat, when they see this, cannot sustain the theory anymore. But the other picture which made all of us extraordinarily emotional is the view of the Earthrise, the Earth coming up against the horizon of the moon. This was Apollo 8. It was, by the way, around Christmas time in 68 or 69, 68. And it was a very impressive experience for those who were in my age at that time. The other picture, the upper right picture, is a view of the Earth and the Moon from Mars. By the way, from this perspective, we really acknowledge the fact that the moon is part of the earthly system. It's the brother or the sister to Earth. So it makes sense that we, after we have exploited, colonized, if I may use this bad word, every single corner of Earth, we think of going a little further and land on the moon and start working and operating on the moon. By the way, probably we will not do it for many months, as it was hypothesized before. We know by the people who are designing the MPH that the plans are for shorter stay in the order of 1 month, just before of the challenge with radiation. But anyway, it will be an extraordinary experience to be there. And I envy Luca Parmitano or Samantha Cristoforetti, whoever of the two will be chosen eventually to fly over there. We've heard by the ministerial meeting that indeed there will be 3 European astronauts and one of them will be Italian. So of course I praise for him. Another lesson that we learned, that we heard of, and which I think is very, very nice and somewhat emotional, is the case of the zinnia, the space zinnia. Well, the zinnia is a flower which can be eaten, by the way. It's an edible flower. It was grown with some difficulty in the veggie greenhouse on board the International Space Station. Scott Kelly, one of those astronauts who have been there for over one year, took care of it, fell in love with it, since it was a little was not doing too well. Then he took it in the cupola to have direct sun impact on it. And eventually he brought the seeds to ground to continue this generation of space flowers. This tells us that gardening in space is a very good experience for astronauts. They cannot have a pet. They cannot have a little animal to love, but they can love a plant. So it's better. It's another way of feeling closer to Earth. After all, we are earthly. We are all earthly creatures, and Earth is really our natural place to be. We've also learned from another situation. This is a pure science fiction case, but it was inspired to some extent also by NASA consultants. This movie, The Martian, whom I think all of you have seen, with Matt Damon interpreting Mark Weiler, I think it was the name of the astronauts left alone on the Mars soil. He managed, since it was a biochemist, to build a greenhouse, a very large greenhouse, using the leftovers, say, by his fellow astronauts, and fertilizing the Mars regolith, and produce potatoes, by which he survived for a couple of years. So indeed, the idea is really connatural to the exploration. And I wrote a book. This is a little publicity, by the way. I have a copy over there, Il cibo nello spazio, rehearsing a little bit of the experiences over there with the, say, old-fashioned food, and dreaming about what we would like to have. As a matter of fact, Luca Parmitano was kind enough to write a sentence. We call it uno strillo. on the last page of the book. He says, in a spectacularly unusual environment, food becomes a cultural sharing, a source of comfort, a moment of relaxation, and of course, an indispensable source of nutrition. I think this is a good summary of what space food should be. In fact, there is also a medical dimension which it did not particularly underline, but which is part of the discipline of this the food discipline. In fact, our ancestors were curing sickness with plants, isn't it? So that is an old type of culture. Now, here I change my hat, if you like. I talk to you as the founder of this enterprise, Space V. Space V is an innovative startup incorporated in Genoa. Genoa is my hometown, but in fact we are incubated in Torino in the Polytechnic incubator. I am one of the founders, so of course I give a little bit of praise to this initiative. We've been in the ESA BIC for a couple of years, and now we are in the I3P, and probably we will move further, because maybe in the Città dell'Aerospazio, in this meeting we've been talking about the aerospace city of Turin, and there will be places for startups, so possibly we will move there over time. A quickie about present space food, which is of course brought from Earth. There is a low variety food. It may degrade during the mission, but mostly it lacks of fresh vitamins and nutrients which you can find only in fresh food. So there is as I said, there is already a greenhouse on board the International Space Station. It's called VEGI. There is also a new one, APH Advanced Plant. I forgot the age, what is it for? But any habitat, maybe. And actually, this has proven, if there was a question in mind, that plants can grow in micro-G. In fact, the leaves look for light and the roots look for humidity. So if you provide them with light and humidity, they grow. Not exactly as on Earth, but fundamentally they grow. So we are happy with that. And we can work with that. Oops, I went too fast. Well, never mind. The idea was what is the ideal greenhouse? It should have a high yield, should be very reliable, should not generate contamination, and we have patented a type of greenhouse which moves the cultivation shelves according to the growth of the plants. Plants are not at the same height all the time. When they're just sown, they're very small, and then they grow. So if we distribute our planting in a sensible way, maybe some artificial intelligence may come into play, then we will have always all the volume occupied either by plants just sown or by plants already grown, ready for harvest. And in this way, we can double the yield of the greenhouse. Greater yield, thanks to this mechanism, reduce consumption, because actually we need to climatize only the volume which is indispensable to the plant and not the whole volume. When the plant is just in the beginning of its growth, there is a significant amount of volume which has to be conditioned, but it's not really useful. If the different environments, the different shelves are conditioned in different ways, you can have different crops, and this is good because you don't want to eat always the same cicoria or rucola or whatever it is. And of course we can can get support from machine learning and similar things. We have developed a proof of concept which we have shown last year at the International Astronautical Conference in Milan. Engineer Tappino was there helping us moving around this box. You can see it's different colors, but different colors because the LEDs have been lit in different colors. But of course, the color is chosen as a function of the type of plant that you are growing and of the type of phase in growth of the plant. Because we have learned, by the way, by this science, which is the science of cultivation in a controlled environment, agriculture in a controlled environment, that modifying the environment either by temperature or by even more by light exposure, you can get the plant with different characteristics. You can, for example, enhance the vitamin C content or these antioxidants which are so useful for the stressed astronauts in space. So the next step is to see, by the way, you see now the prototype in operation as it was at the Yak 75, and through a computer rendering, we have already installed it inside the ISS in a rack, in an express rack, one of those that Giuseppe Ribaldi was designing and manufacturing during the development of the ISS. The European express rack, isn't it? It's one of your babies. Anyway, of course, we are looking at those who are building space stations. We hope to have a chance with the International Space Station if we manage to fly by 2030. Our goal would be to fly even before that time, but anyway, the challenge is on us. But there are these new perspectives with the commercial space stations, be it Blue Origin, be it Axiom. In fact, Axiom, Thales Alenia Space is building modules for Axiom. Starlab, we met Tim Copra at Yak 24 last year, and we have a good relation. And of course, VAST is a little bit less on our radar. Anyway, so this is the challenge we are working on. We want to think of this not as much as a payload one spot event payload. We are working with Altec, the specialists of space services. We look at it more as a facility where scientists can bring their seeds, their plants, and exploit the facility without having to develop themselves an instrument to grow their preferred seeds or plants, and eventually it should become a production unit for astronauts' food on the moon. Mars is a bit far. I'm not planning to be there because I'm an old man, but my son and my nephew will certainly do it. Fine. The greenhouse can have also some ground applications. In fact, we are talking about sustainable agriculture on Earth, and starting from harsh environments, places where water is scarce, where the climate is particularly unfriendly. This picture is a picture I took from the Shuttle Atlantis during our flight. These are cultivations in Saudi Arabia. They are strange round green circles, and it's because they pump water from underground. It's actually fossil water in a sense that they pull up to wet the cultivations. And this is definitely a non-sustainable approach, because that is a reserve like oil, say, that one day will be finished. There won't be any more. It's not replenished by the rain. In fact, there is also little rain over there. So water managed in environments like that is certainly very opportune, and our system, our patented system, might be of interest for them. Well, this is it, and thank you for your attention. I took 10 times from your rights to a lunch, but let's launch the Moon Village. Thank you.
Thank you very much, Franco, for your very inspiring relation. Is there any question from the public? Yes, sir.
Thank you very much. It's an excellent project. I have two questions. One is light. Are you using the LED or the space light, which is a very strong UV component is in, or are you using the artificial light? And that is one question, because you want to use space without eliminating UV component. I don't know, the UV component increase the productivity or decrease the productivity. That is one. And the second one is how do you deal with the bacteria near the root? Because the productivity might be affected by the presence of the bacteria, and that may affect the most of the product. So thank you very much.
The question is for me, I suppose. Right. No, definitely our greenhouse generates its light with LEDs. So it's all artificial, all controlled by the software, by ourselves. Of course, the agronomists are the ones who tell us what is the right mixture of colors at different times in growth of the plant, etc. We have an agronomist in our team, so he would be perhaps in a better position to answer your question. But fundamentally, the first question, which is the one you are looking for, it is artificial light, nothing to do with the external environment. If I may, since you yourself mentioned artificial gravity, you may know, actually, I'm sure you don't know, but I'll tell you, that in my space shuttle mission, STS-46, we deployed a tetrad satellite, a satellite attached to a long cable, isn't it? So we started experimenting a system based on a flexible connection between two bodies. We had some difficulties with the deployer mechanism. Eventually, it was also an electrodynamical exercise, so the second mission got a short circuit which cut the cable. So it was not a very happy type of experimentation. But after all, cables in space would be very useful to provide artificial gravity in travel. If we think about the travel to Mars, for example, 6 months traveling, with simple calculations, you can find out that if the vehicle is made of two bodies attached with a cable, and it's rotating something like 1 rotation per minute, which is bearable. You don't get disoriented by that. Then with the cable, I think it's a couple of kilometers long, so it's long, but space is big, so you can afford it. Then you have on board something similar to 1G, or maybe a bit less, but anyway, so a very good artificial gravity, which may help astronauts arrive at destination in better shape. I don't know if you were thinking of something similar.
I have just a curiosity. I know that a way to mitigate the upward fluid shift that occurs in conditions of microgravity is the use of the so-called tight cuffs. And these are sort of cuffs that are donned at the level of the tight, and they compartmentalize the fluid in the lower part of the body. I know that this is a solution in particular used by cosmonauts. This is the reason why I'm asking you this, because maybe you can tell us something more about this solution that it remains actual because it is still used.
So what I may say during my space flight before landing a few days, we used a lower body suit, let's say, like trousers, named chibis. Yep. It lowered the pressure from our bellies down and increased the blood flow from up down, just to be more used with the Earth gravity when we come back to adapt faster. So we use that maybe twice a day for 2-3 days exactly. I don't remember now exactly, but we use it into space. Even I have pictures with me using the device on me and train my body for landing.
Well, there is one more question. Fast question, please, that we have to close. we are getting hungry.
Yeah, all right. Yes, we need to eat, of course, and that is the exact reason why I'm going to ask this question about this cultivation device. How do you hold the soil in place, and where do you intend the soil to come from? Are you making synthetic humus, or how are you making it? How did you think of that?
Since we are mainly in micro-G, we use hydroponics, so there is fundamentally not a something like on Earth, isn't it? It's more of a spongeous substrate on which we have to deliver water and nutrients. As a matter of fact, we are thinking of a new development, which might be a little bit secret, a little bit to be patented, but actually to concentrate the nutrients in what I called little tile, so that if something goes wrong, you throw the tile and you put another one on. Instead, if we have only one substrate for the whole tray and something goes wrong, the whole greenhouse is in a sense problematic. Instead, if we concentrate the the nutrients for the plant, the environment for the plant, etc., in a movable tile, then we only need to supply water to it, and the design of the greenhouse becomes easier. I have this analogy with the laser printer. The toner is, after all, a sophisticated piece of equipment, but if something goes wrong, you pull it and then you throw it. And something similar, something intellectually similar, we should be doing with the greenhouse. So the greenhouse is as simple, being anyway fairly complex, but as simple as possible. By the way, managing water, you were complaining about the dryness of the air. The greenhouse can generate humidity, because we have a question mark how to dissipate possibly excess humidity from the greenhouse, because this water, after all, is taken partly by the plants, but partly is evaporated. So we can make a gift of it to the to the environment of the station.
Very well. So we can conclude our session, our panel, and I thank you very much for your attention, and looking forward to cultivating a meat on the moon. I close this session and enjoy your lunch. Thank you very much.
Okay. Thank you all. So for the speaker, if you can stay a moment here, we can take a picture with the panel. So maybe, Giuseppe, you can join the picture. For all the other people, we start again at 13:40. So we have more or less 20 minutes. Fortunately, probably we will not have queue at the lunch, but for sure we have to start once again with the schedule. So I'm sorry for that, but for sure, actually, we will start with the panel 12 at 13:40. So see you later.
Blue Origin.
Yeah.
the mission, Lunar Outpost U provides power, mobility, and autonomous support. Their systems deliver energy and heat, ensuring instruments and robots survive the moon's minus 880 degrees Celsius nights.
For the attendees of now conference, we have some few. Please give us a little buffer. I think we are fighting against the lunch. We will try our best to start in 5+-ish, depending on the presence of the audience. Thank you for your patience. Please, attendees, have a seat. We are going to start soon. We are fighting against lunch timing. Soon we are going to catch up at our best. Guys, I think you can take your seat. I will call you up here, so we can go in order. Thomas, you're going to be leave that seat. Hot, you're at the end. Yeah. This one. Yeah. There will be separate. Save you a spot.
Cement?
Yeah.
Ammonia?
Yeah.
There are specific.
Please get in, have a seat. We are going to start in a few. Ja.
Geht's? Ist okay? Ja. Gut. Ja, jetzt fühlt sich das Ganze ein bisschen. Dein Kollege war gerade drüben. Der war ganz gut drüben, was sie da war. It was good just now. The other one was quite full. Was? Yeah, I was quite happy.
Welcome, attendees. We are going to start very soon. So, the panel of this afternoon, and thank you for your presence. You know how it's hard to fight just after the lunch coffee. So I do believe we have very interesting substance to show you. And we are very glad to be part of the 9th Moon Village Workshop Symposium. Sponsored by ESRIC, European Space Resources Innovation Center. I'm Olivier Zetfier from the Technoport Technology Business Incubator. What we want to showcase to you today is a set of first policy support by ESRIC. ESRIC is modeling with technology providers for in-space and lunar operations, for example. They are modeling what could be the value chain. And I have the pleasure to have a set today of speakers, starting by Ernestina Bini from ESRIC. We have Thomas Adak from Astroport. We have Séverin Leur from Fibercoat. And we have Roderick Rold from Polymac Space. First, before setting the ground, let me tell you what Technoport is about. Just to give you the vision, we are uniting the community of SMEs, of startups, of corporate players to be able to consolidate an early stage value chain. So this is the Technoport. We have 25 years of heritage in entrepreneurship and innovation. I believe this video will give you a quick overview about what our brand is about and what we are doing. So, currently, with our 25 years of heritage, we are active in the aerospace industry. Our mission statement is to support innovation ecosystem in emerging industries, because we do understand technology and market trends. It's about technology business intelligence. Of course, we work across ecosystem, we provide support. I won't focus on each of the brands you have here, but we are speaking about early stage ventures. We work with research providers, as the ESRIC European Space Resources Innovation Center, and our mission statement is to be able to bring all these players to collaborate together. On our side, we work with startups and spin-off. We have a dedicated brand for this, which is called Deep Tech Venture. We work with scale-ups. We have currently a JV with a little telco company in the name of Vodafone, so we have an acceleration program. And we do work also with corporate R&D. Thales Alenia was sitting with us for launching the operations from Luxembourg. For those who knows Carraro from Italy, this is a big currently tractor provider electrifying their system with us. In short, what I want to bring to you is that we are bringing together the ecosystem to take technological risk and bring new technological value to market, and this will be the case in ISRU today. Ernestina Bini, I call you on stage so that you can showcase how are you working currently into the SRU value chain. Ernestina, thank you.
Hi, everyone. I think this panel is quite important for us, for ESRIC, and as explained this morning, this is really what we would like to do. Means we are searching to connect the research and public sector together with the private one, support them in commercialization, and this is what we do actually for the space exploration.
Here, ESRIC and Technoport, together with the Luxembourg and European space agencies, are building a unified concept of operations that drives every stage of lunar exploration and development. Want to see how it all connects? In every phase of the mission, Lunar Outpost U provides power, mobility, and autonomous support. Their systems deliver energy and heat, ensuring instruments and robots survive the moon's minus 880 degrees Celsius nights. Tumi Robotics leads the prospecting layer. Using Edge AI, its autonomous rovers process data in real time. They scan the surface in 3D, detect risks, and identify resources, producing actionable maps to guide missions. Light2Go Space reveals hidden resources and directs activities to the most valuable sites. Once the terrain is mapped, landers can arrive safely, carrying tools for the next step in the mission. Polymac Space provides the moon's first conveyor for lunar conditions. Their patented MDC moves regolith smoothly and clog-free, delivering a steady flow from excavation to processing. Through laser-based analysis, Light2Go Space uncovers the composition of lunar dust. oxygen, metals, and other components, ensuring every gram is used with purpose. Using this data, Astroport transforms regolith into construction-ready materials. It builds critical infrastructures such as landing pads, roads, and habitat foundations, while providing processed regolith for other applications. Space Backend brings it all together. The cloud-based control platform integrates any asset, payload, or subsystem, enabling AI-driven hardware connectivity and operations for the entire lunar environment. This is the ecosystem preparing the Moon for the next frontier: larger landers, advanced robotics, sustainable resource use, and eventually, permanent human operations. Beyond that, who knows?
Well, I think that the video is speaking for itself. So this is what we are trying to do in Luxembourg, build the ecosystem to support the lunar exploration. And in the video, we have only few of the companies that are with us. So there are more, and a few of them are here with us today. Thank you.
Thank you so much, Ernestina. So one could say interesting showcase that you did with a video. But what we want to bring to you from a Luxembourgish perspective, we are not only showing, we want to say, we are not only saying that this can be a future concept of operation. Yes, we do speak ConOps, but what we want to bring to you is the people, we are special equipment providers who are bringing this technology and testing it under the ESRIC program. And I will call on stage Astrosport Space Technologies representative, Thomas Adak, technical lead. Please, the floor is yours. Let me put up your presentation.
Should I stay here or?
You can, yeah. If you have a return screen, feel at ease.
I have it. Yeah, so when we looked at actually at all the, oh great, at the.
So you need to be here.
I need to be here, yeah. Okay, I will do it manually. So we quickly identified, and I think all of us agree that landing on the moon is very challenging and risky. So we try to understand where we can put our expertise, and we've quickly identified that all these parameters like uneven terrain, the PSI, the plumb surface interaction, and debris on the surface that impacting the safety of the landing and success of the mission and the payload deployment are very depending on actually on the key infrastructures that you can see here on the screen. So basically you start with landing site. Of course you can land on unprepared terrain with smaller size landers like Argonaut or any Eclipse size landers, but if you want to build your business like ISRU activities, you need more landers or bigger landers like for example Blue Moon or Starship. Those landing occurs not only one but multiple times, and at some point the safety of the landing, the risk increase. So you need established and stabilized surface, not only leveled but also compacted and stabilized by other like sintering or melted regolith. You need also structure the power systems. And stock actually your assets on site protected from radiation and temperature variation. All these key infrastructures resemble they look like a construction site on Earth. And this is how actually we decide that the expertise that we have at our company focus on these three families that match perfectly for this exercise. We started with space materials based on the regolith, and then extended to this space construction, ending with a final infrastructure asset, which is the landing pad. And based on these expertise, actually we found that service that can be offered not only for us for building infrastructure, but also to provide a feedstock and analysis and beneficiation of the regolith for other stakeholders, also presenting here on stage. And we try to understand better how the geotechnics of the regolith impacts our activities and how improve the terrain help actually decrease the risk of the landing and increase the success of the missions. With this, the service and expertise, we finally developed our core product, which you can see on the screen and also here on stage. Those are the samples made from LMS, but we are using the same process that you see on the left side, which is a patented technology of furnace nozzle. Basically, it's a microwave heating where we melt the regolith and product actually the bricks that can be scaled down or up depending on the loads and final application that we have, not only for the landing pads but also for the roads, radiation protection or impact protection. This product actually was a startup point for us, and we built all the technology around. And we used our background from structural engineering, from mechanical engineering, and we built what you can see on the bottom line below the roadmap, all type of implements for the excavation, scooping, and compaction that can be plugged to the rovers and allows us to execute those activities on site. The timeline, we are still at between TRL 5 and 6, but we are heading to the next stage in next year. And especially the third one, the compactor you can see on the bottom, it's the third one from the left. This is already existing model developed by University in Adelaide, and this is actually in progress of compaction exercises on testbed on site. And this is what I got.
Awesome. Thank you, Thomas. To bring us civil engineering for operations into the moon, what we want to share with you is that we are uniting and consolidating that corpus of knowledge and know-how. Astroport Technologies today has currently a heritage in that area, and this is where we are searching for collaboration to understand how we can find this trustworthy party. And this is what we are going to express in another presentation. So we have the call, the presentation is coming by the same time. So we are happy to welcome Séverin Lure who is an application engineer in FiberCode. What we want to share currently with you, audience, is how in-space operation is key. And having a player into in-space operation, again, corpus of know-how, corpus of knowledge, and how they are going to tell us the application that they are thinking, starting from in-space and potentially working with regolith. Please, floor is yours. Let me put up your presentation.
Thank you.
Please start.
Okay. Yeah. Hello, everyone. I'm happy to be here. My name is Séverin Lure. I studied in RWTH Aachen in Germany, aerospace engineering. During my studies, I did an internship at ESA working on payload development of a shape memory polymer actuator. And then for Ariane 6, I was also participating in the testing of the fiber optic harness. Then when I came back to the studies, I joined the space team Aachen, where I did structural design for a 7-meter rocket, a hybrid rocket that's supersonic. And now my current role is at FiberCode as an application engineer for space, where I develop new applications with our materials and do a lot of space radiation shielding, and also the ISRU Moon Fiber project that's right now in the proposal stage and will start around March of 2026, so coming soon. So FiberCode, we were founded in 2020 as a spin-off from RWTH Aachen, from an institute for textiles, so FiberCode. We grew quite rapidly. Now we're 68 people in Aachen and even more employees at the other manufacturing sites. And what we do is also in our name, we coat fibers. So we have metal-coated fibers, polymer-coated fibers, and also this Moon Fiber project. And to talk about our products in general, we are across many sectors active, developing from defense, civil, and automotive, and space. For example, radar materials, this is our biggest product at the moment, but we also do EMI and EMP protection, not just for defense, but also for space and automotive. Now we do radiation shielding for space, but we're thinking about going into medical applications with this, electrostatic discharge prevention, thermal management, all the topics where we can functionalize composites. And yeah, Moon Fiber is a special topic to us. We're not coating fibers, but we are using the regolith, we're melting it, we're spinning fibers from it, and then suddenly we have a very unique material on the moon that has significantly higher strength, significantly higher surface area, and yes, just another material to the mix that we can use on the moon. And in this regard, we're working together with ESRIC, with the European Space Agency. We were funded with the ESA BIG program, and we're also closely collaborating with the German Aerospace Center, DLR. Working on these different applications, and next year the small machine will be built that is melting regoliths, spinning fibers, and creating a textile. So this is how we fit into this round. Thank you.
Thank you so much. Been round of applause for Severin. And thank you for not only illustrating, giving us how we are building the substance. We had Econops presented, consolidating a value chain. We were speaking infrastructure with Astrosport. We were seeing how we are thinking currently to operate manufacturing processes. And this is ongoing. It's been in finance. And earlier in another panel, I was saying we need a type of space infrastructure and manufacturing bond that every of us here, part of a public, could invest in so that we can have this type of public-private finance. And I will call to stage somebody who's really knowledgeable about this thing with the experience he has into the space industry. He's going to share with us about material handling and having this both perspective, both terrestrial and space, and how to show the feasibility of what we are speaking about to bring infrastructure into the moon. I call to the stage with pleasure Roderick Hull, Head of Commercial and Operation at Polymac Space. Roderick, floor is yours.
Thank you. Thanks. Hi. Does the mic work here, by the way? Yes. Yeah, it does work. So, hi, my name is Rod. I'm a planetary science originally that then switched to economics. I think that's a pretty rare, pretty rare combination. And then I worked in tech companies for nearly 25 years and then came back working for a lander company on the commercial side. That was my way back into space business. About Polymac Space. I was just speaking on a panel at the other conference here about what are non-space companies, what they can add to the space business or to classic big space companies like Thales, etc. If you look at the expansion into space, there are completely new fields that open up in terms of knowledge that you need to bring to it. ISRU is one great example. This is not really a space business. It is really a business that we've been doing on Earth for thousands of years, mining, handling materials, transportation, logistics on a surface that is now being conducted on the moon. And is it space? I would say it's in the middle. It is space in that you operate in an environment that is really hard to work in. So this is where the space part comes in. But then everything else is, let's be honest, has a very big non-space component. So there's definitely a way how space. Sorry, it doesn't work here. Yeah, I think I need to press on a button first, and then, and then it'll work from now on. Yep, exactly. I don't need to go and explain what we all want to do with regolith. I think we know that quite well. The important point is we need regolith. We need to use it. We need to handle it. You've seen fiber coat, for example, they're developing something that requires regolith, but how do you handle it? Where does it come from? And this is where companies like Polymark Industrial come in. We have over 50 years experience handling bulk solid materials, which is powdered materials, granular, think of cement, think of anything that requires transportation that you normally cannot containerize. And this is a huge business on Earth. So this is where we come from. You need to be able to load, fill, discharge, crush, grind, collect dust, make sure that you don't emit too much dust, drying, sieving, separation, mixing, etc. Again, I don't believe that this is inherently a space thing. So this is where we come in. And we build machines like this, from really big to really small. And when it comes to moving regolith, the pictures that you always see in videos is there's a rover that runs from A to B that holds regolith. Doesn't really happen on Earth. It's mostly done at small and big scale, primarily through conveying systems, conveyor belts, conveying any kind of conveying system. This is what Polymark Industrial does. If you look at this, these systems here, this is all done on Earth. Each one of those has its advantages and disadvantages, depending on the material, depending on the industry, but they all require maintenance. They're technically fairly complex. They will break down. You need to help me, working or not. You need to maintain them from time to time. It's a luxury we don't have on the moon. So if you look at the simplest system that is nearly always used in experiments, you have a screw conveying system, but it has inherent disadvantages, which are that you're really pushing the material forward. You're grinding it. There is a gap between the screw and the tube. Regolith is inherently pulvery, small. It will get stuck. It will start to, due to its abrasiveness, eat away at the material, both at the screw and the tube. And in the long run, you can't really run an operation. So we designed and have a patent on a much simpler system, which is basically a screw that is fused together with a tube. It has no axis. Because it is really one piece, it's like Lego. You can stick it together one by one and then build what we call a regolith pipeline. You need to drive it from outside though. I think the best way is to just show how the mechanics work. You have the classic screw conveyor on the top and you have this modular drum conveyor at the bottom. First you see that at the top you really push the material. You're grinding it. At some level, material will get stuck between the screw and the pipe. It will start to look how it looks like at the top. At the bottom, it moves completely different. It's really rolling down. It's an endless rolling motion. And you also mix the material much better, which is good for sieving. So you can actually combine this with a sieving mechanism. So this is what we do. We have a patent on this that lasts till about 19.5 years. So I think now is a good moment to make sure we try to make this a quasi-standard on the moon. That's why also we joined ESRIC in order to fulfill these visions of the moon in the future. Around this, we're building a whole ecosystem, sensor module, sieving module, preheating module. It can be mounted on rovers. This is just one of the technologies that we have that we can bring from Earth to the moon. Thank you.
Thank you so much. Big round of applause for Roderick. Dear audience, I do believe you are, I hope so, but you're excited just as me to see that this is not about, we need policies, we need support measures. And thanks to ESRIC, who has elaborated a support program to bring these technologies from terrestrial match, being able to do prototyping about this, thinking of bringing that space grade. And we are seeing, and this is the point of the panel today, is about, quickly speaking, I will try to keep my best housekeeping today. We will take one question we have worked throughout our panel about cross-innovation. How do we make this possible? And given the background, if I take Astroport, how you're structuring that team to be able to be agile and hopping between different, I will take the civil engineer point of view, taking different knowledge, know-how, bring it together, and going through space grid and consolidating a value chain. Can you please, Thomas, give you your one word about the key point of cross-sector innovation and how it will accelerate your reach to market?
Yeah, so I think, okay, the core approach for us was the bricks, but the cross-innovation that we applied, actually, it's a geotechnical engineering, and we mastered the process of melting regolith, and now we see that the interface between the bricks and the regolith is a gap, knowledge gap, and also a technological gap. So for us, application of terrestrial geotechnical engineering and experience from geotechnics on Earth, okay, we can discuss about difference in lunar environment and regolith, but the approach for us is still the same, and we have a huge knowledge about the geotechnics on Earth, and we just use it and find it the solution for our bricks.
Thank you, Thomas. And to follow up with Severin, can you tell us, for fiber code perspective, you know, the blend of know-how that you're developing in-house, of course, for your venture as a special equipment provider, but how are you seeing this cross-sector innovation? How are you planning that on your end currently for that to bring value to your venture? Can you tell us about it, please?
I think the important aspect is there that we at FiberCode, we don't just produce the coated fibers, but we also have a modular production system, the production machines we develop and build ourselves. So we have multiple coatings and many applications across many fields, but we scout for potential in new applications and for optimization things, and then see the whole system and accumulate basically which thing will improve the process stability, the output, the quality, and then we choose and prioritize the most important thing. So if we improve something for the defense production, since it changes the machine in a better way, this will also benefit all the other coatings and all the other applications. So we try to, not just optimize a single process, but the whole production across all sectors.
Thank you. That's very interesting to share how strategically you need to think of different types, areas of application to bring better value to your product. Roderick, the point I want to bring to you, we saw your brand, we get the heritage that this brand has. How do you handling that cross-sector? And earlier we were sharing how you're opening the footprint of your brand across different sectors to be able to engage in this ambition, in these ambitious projects such as lunar operation. Roderick, please.
Thanks. So when it comes to moving into space, that's the direction I'm talking about now. First of all, knowing how conveying systems work on Earth will show you where the problems lie already on Earth and how they would become bigger problems in space, well, in our case, specifically on the moon. So our founder, who is also a spacecraft engineer, inherently saw the risk of using normal screw conveying systems. They're easy, they're simple, everybody knows the way they work, but in the long run, because they have the experience, even on Earth, they cause problems based on properties of the material that are even worse on the moon. The abrasiveness being one of them, the fact that the material sticks extremely and it's just hard to work with. So that is one way, and that's how they saw, okay, we need to find a completely new way. On the other hand, we're not a space company, and that's a point that I just discussed with my team just yesterday. How can we grow as fast as possible? The idea is now that we said, look, why don't we just develop the mechanical parts first, bring them to space readiness? I just spoke to Cesare from Thales, right? And I said, look,
would you be interested if we provide you just the mechanical system, but then you build everything which is electronics, etc.? It's much more complex and not really our core knowledge. So we just give you a ready system and you just have to see how you drive it, basically. And he said, yeah, that would be interesting because this is already something that we do. And we can gain from your knowledge, but at the same time we need to work together. So that's for me another cross-sector. So again, space, non-space. Of course, in the long run, if we can also handle the electronics is great. But what is the knowledge that we can bring? How can we bring this as fast as possible? It's really just relying on others to do what we can't do at our core. Yeah.
I get it. Thank you so much for sharing about this consolidation needed effect. And this is why I will give the N-word to Ernestina Bini, because I do believe we need consolidators. And Roderick points of view to say, know where you're good at, you're best at, have your take in it, and find your consolidating partners. Ernestina Bini, I will leave you the closing word, because now for good housekeeping, we need to switch for the event. And this is a good, you know that I can speak of hours. I'm impassioned about this topic. And Ernestina, please give you the closing about ESRIC is launching a new call. We have here the set of early stage ventures, companies who are taking this challenge. What is your invitation for partners for consolidating what you are already doing? Please, a concise closing word from you would be great. Thank you, Ernestina Bini.
Thank you. So as said a few times during this workshop, we are supporting and enabling space resources exploration. So we have different calls through which we are supporting the company. Here you have some examples, and for us it's very important that they are already consolidated in the terrestrial market for different motivation, because you know, this is give already the structure of the company. They are already company that validated themselves in other sectors, so we know they are able to deliver somehow, and in the other case they have also the possibility to de-risk together with us their research and development. So I invite everyone to apply to our call with an idea related to space resources. That is quite a broad concept. We have also communication company in our court, so enjoy and check the call.
Thank you so much for this closing word. Dear audience, I believe you did enjoy, as I did, this panel. I look forward to interact with you, how we can consolidate together a value chain with the players here. Thank you for your attention. Looking forward to interact.
Thank you very much, Olivier. I don't know if you want to make the photo? Sure. Okay, so please. In the meantime, I will ask Professor Lorenzo Olivieri from Padua University to prepare to give the first talk of the technical session. Thank you very much.
Thank you.
Yeah. Thanks.
Non è questo? Quello dopo questo qui. Questo qui penso sia, vediamo un po'. C'è la tua presentazione.
In caso ce l'ho qua dietro, però.
Ok.
Andare su in onda, sì. No, è il 4, non il 3.
Il 4, aspetta. Il 4.
Quello lì.
Questa?
14 e 15.
Non ci sono.
Ok, dai, Moon Village. Ed è questa? No.
Se lei ce l'ha dietro, sì.
Sì,
ok.
Prendo un po'. Aida Torino. Dove la metto?
Okay. Please, Lorenzo, you have the floor.
Good afternoon, everybody. Thank you for being here, and I wish to thank also the Moon Village Association for hosting us on behalf of the GLAMS consortiums. I will start this presentation today. I will discuss about 3D printing for lunar bases. I have seen that this is a topic that we have already listened to in the last panel, but I think we can give few more indications. And just one second, that I'm not. It's not this one. No. 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 Forse questa. Okay, let's see. Okay, now it's moving. Sorry for the delay. So today, after a brief introduction, I will introduce you the GLAMS consortium, and then what we have done in the last 2 years regarding this project. What to say? A lot of lunar missions. We have seen that there is a growing interest on the moon. The last panel discussed how to use moon resources. And if we want to put the man on the moon and make the humanity stay on the moon, we really need to focus on technologies enabling such activities. Among the resources, the technologies we need to use to bring to the moon a lot of materials, a lot of instrumentation. For this reason, in situ resource utilization could be a strategy that is extremely cost-effective, because transporting the material is extremely expensive, so we can reduce the cost of planning and building a base thanks to using the material that is already there. But building something on the moon is not so simple. We have a lot of complex requirements. We have high temperature gradients that can modify the characteristics of the material that we are using. We have micrometeoroid impacts that could damage our structures. We need the materials and the tools to build and maintain our structures. And then we have all the effects of the environment, the vacuum, the low gravity, on the processes and the materials that we want to use. For this reason, we are investigating the lunar regolith that is so much available on the surface of the moon. We speak about lunar regolith, and we think that is just one kind of material, but also from literature we can see that we can have different compositions and of the different compounds of the regolith, with changing percentages of iron, of aluminum, of all the components inside it. And this is just a problem, because if we can use the regolith as a component for cementitious binders, we also need to add an activating solution. And this activated solution, what can we use? This was a big question that has been answered in the last years. And the alkaline solution that could be could be used on a lunar base is just the astronaut's urea. The astronaut urea is an optimal activating solution, and therefore it could be used to produce the cementifying material that we shall use for our base. Also, it would help using such a waste and use it for something useful on the moon instead of discharging it. So this is not just a simple idea, but a real study that has been based on the literary survey because it has been seen that adding urea can reduce the water demand for creating our building material and also to improve the extrudability of the mix. So we are quite interested in finding how this material can behave and if it is fit for in situ additive manufacturing. On those considerations, the GLAMS project was funded by the Italian Space Agency. In 2024, it started its activity. GLAMS stands for Geopolymers for Lunar Additive Manufacturing and Sensing. It is composed by a consortium of both research institutions and private enterprises. It is led by the Center of Space Studies CISAS Giuseppe Colombo of the University of Padova, and it has three main goals under the target of study those advanced materials. First of all, it was to understand if we can use this material for additive manufacturing, then to optimize it for the moon environment, and then to define and understand the production processes that we shall use to do this kind of manufacturing. This is an overview of the consortium funded by, as I said, by the Italian Space Agency, with the University of Padova and CISAS at its first and its coordinator, but also involving two departments, Geosciences and Industrial Engineering. And then we have ICMate and the WASP as the private enterprise involved in the development of the technological processes. Just to show you the material that we are using the simulants representative of the lunar regolith. In the middle, you can see the composition of the average regolith collected by the Apollo missions. What we are using are representative simulants that can be found and also bought here on the ground. Of course, there are kind of differences among the bulk composition and the glass composition in terms of crystal structure, and this can affect the behavior of the mix, but this is still something that we are studying about. Manufacturing, here you can see that, let me see, okay, this is an example of the what we can do with this kind of material, and in particular here you can see the mixing of the material and the testing at small scale of different compounds for testing, and also the manufacturing of the full brick with a complex geometry. With this kind of geometries that are typical of 3D printing, we can also save a lot of material but maintaining the rigidity and of the brick that we are building. Let me go on. In this last month, we have performed a set of environmental tests on those materials in order to understand how they behave with respect to the conditions that can be found on the moon. The first of those tests that we have performed is thermovacuum. So we have replicated the thermal cycles on the moon on samples of the free printed material. This is the vacuum chamber that we have in our facility and that was employed for this kind of activity. Those are the different samples that were tested. The majority of them had a temperature sensor attached on the surface to fully characterize the temperature profile. And after the test, those specimens were collected and sent for analysis to our colleague in the geological department in order to understand if the crystalline structure had changed due to the changing environmental conditions. Also, we have studied how to understand if those bricks were subjected to meteorite collision. One solution is to use monochromatic cameras in order to find the damages, the cumulative damages on the brick, on the external surface. And with a simple layout, a simple system, we can find damages with a good accuracy, with relative errors about 3%. This just was a first tentative. What we are doing now is also making the hypervelocity testing up in order to understand if the material can survive and if the damage that we have assessed before are representative of the real damage from a micrometeoroid. So this is our hypervelocity impact facility that we have in Padova, capable of shooting projectiles up to 5.5 kilometers per second. We have built we mounted our target on a ballistic pendulum, and it will be used to detect how much momentum has been dumped during the collision. So everything is ready for the test that will be performed hopefully next week. We have also calibrated the ballistic pendulum in order to understand from the impact what is the response of the whole structure, and therefore the test activities are ongoing. I was really hoping to come here with the video of the test, but we had no time last week to complete all the activities. It will be next occasion. I'm sure I will be able to show you the video. So I'm at the conclusions. GLAMS has been is a project supported by the Italian Space Agency for demonstrating the building blocks for the in situ manufacturing of lunar structures. We have seen that this has the real big advantage of cost reduction by using material from the lunar surface, the lunar regolith. We have developed and tested the materials and the processes, and then what we really want to do is a technology demonstration possibly in situ. Thank you very much for the attention. If you have any question, I'm available also by mail, and thanks again to this to the Moon Village Association for hosting us from the GLAMS consortium.
Thank you very much. And so I invite, stay here, Matteo Curcio to start for the next presentation. In the meantime, if there is someone that has some question for Lorenzo, please, from the audience, please.
No question? Too much clear?
Yes, I have a question. You just showed the facility of tests that you have in Padova. There is many others. For example, there is one in Boulder University in Colorado that they was able to, let me say, test with dust, with any kind of specification. This is the possibility to access it through the NASA Vita Space Planetary Institute that is based in NASA Ames. You have an idea to do this test, or you're planning?
It would be amazing from our side to do that. Right now we have no direct contact with them, but if there is some facilitator here that can open up
this is,
the access, it would be amazing.
ASI, the Italian Space Agency, will give you the possibility to be in contact with this team.
Okay, wonderful. Right now we are using our facilities in-house because we have them, we can use them. But of course, if we will have the possibility, we will investigate them.
Okay, thank you.
Thank you for the suggestion.
Oh, yeah. 10 minuti.
Di questo per caso? No. solo Londra. Adesso chiedo ai responsabili.
Pereira.
Non ci sono slide, proprio se va su Londra.
Non c'è la tua Ah, ecco. Senti, vedere la tua presentazione, vediamo se c'è il prossimo. Dove sei? Quella di Olivieri.
Londra, 4 e 12. La cartella è vuota.
Ma quella dove abbiamo trovato prima, quella di Olivieri, perché bisogna andare a Moonvillage.
Prima abbiamo messo la chiavetta.
Aspetta, Moonvillage DS. Curcio, eccolo qua.
Deve presentare questo?
È la tua? Sì, siamo PDF.
Allora adesso.
Hi everyone, sorry for the bit of delay. My name is Matteo Curcio. Today I'm presenting my latest work developed at the Laboratory of Industrial Safety and Environmental Sustainability at University of Bologna, entitled Quantitative Comparative Assessment of In-situ Resource Utilization Processes for Lunar Oxygen Production. Before starting, I'd like to acknowledge the help given by ASI, Italian Space Agency, throughout the development of this entire work. So, as we all may know, oxygen is one of the most single pivotal component for space exploration, both as a propellant in liquid rocket engines and, of course, as a component of breathable air. On the other hand, the reason why we're all here today is because moon exploration and colonization is still facing some issues, not only technical issues, but also economical issues, as we saw also in the other presentations. Thus, the idea, why not transporting resources on lunar surface, but producing it directly there. So, for example, oxygen indeed. The problem is that on the moon we have a really hostile environment with radiations, microgravity impacts, and so on. So we need the expertise brought from other areas of engineering in designing tailored processes for particular environmental conditions, and this can come from chemical and process engineering. In this increasingly growing overlap, let's say, between chemical engineering and space sciences is thriving astrochemical engineering, which is a subject of real recent introduction, and I hope that by the end of the presentation you will agree with me it's going to be more and more important in the next years. So with these premises, we wanted to provide stakeholders with an in-situ resource utilization evaluation tool to help early stage funds allocation and decision making in a scale-up perspective, so let's say in a moon village perspective. In order to do this, we developed a methodology with novel quantitative key performance indicators that take into account the entirety of the mission, and then we tested this methodology for 8 alternative processes for lunar oxygen production. The methodology starts with the definition of the process specification. From this, we build a coherent process database from literature. Then the processes undergo some acceptability criteria, and once that pass through the acceptability criteria, have then the indicators calculated for them. In the indicators, we will have a deep dive just in a bit. The indicators are then normalized, aggregated, leading to the ranking of all process alternatives. following the TOPSIS method, which is a multi-criteria decision-making method. And the TOPSIS method itself was then merged with a Monte Carlo-based simulation to provide an uncertainty analysis that basically gives robustness to the methodology itself. So we need oxygen. We need at least 5,000 tons per year based on previous studies at least 95% purity. And being our case study on the moon, we need to produce it from regolith. Starting from this, the process database saw more than 15 processes gathered. Only 8 of them went through the acceptability criteria successfully, either for missing information or no using bulk regolith, but some specific volatiles, for example, some processes were excluded. As I said before, the indicators are defined following the entirety of the mission. So we have the first step, which is construction and onboarding, in which, of course, we have to minimize the spatial encumberment of the equipment we are bringing to the moon. Then we have the launch and flight phase, in which we have to minimize the mass and volume payload. Then we have unloading and assembly that must be as easy and as reliable as possible. Then we go on with extraction and supply, in which is very important to minimize the burden for the mining equipment. Then we start up and operate the process, in which the keyword, as you basically saw in some other presentations, is to reduce the power requirement of the process. And then last but not least, we have storage and usage of the product. The indicators were subdivided in 4 couples. We have mass and energy yield that quantify the extraction need and the energy requirement. Then we have the so-called in situ indicators that basically give us an idea about the compatibility of the process with the in situ feedstock. Then we have the complexity indicators that inferentially quantify the pipes and junction and the equipment needed, so the number of vessels needed. And last, we have the operative indicators, which respectively quantify capital expenses, let's say, in particular for material performance and material thickness needed. As I said before, the alternatives were ranked through the TOPSIS method. I will not say anything about that because we haven't got much time, and these are basically the formulas of the TOPSIS method itself. And then we have the uncertainty analysis, in which we randomized the indicators to address multiple sources from literature, spanning from NASA's reports to ESA to also project in collaboration with the Italian Space Agency. And we randomized also the weights given to each indicators in order to address different priorities that may arise from different stakeholders. Okay, now we have our case study. We divided all processes in electrolytic processes, pyrolytic processes, and reductive processes based on what they use to decompose regolith into oxygen. So we have electricity, of course, thermal energy, and then for reductive processes, we have any chemical agent that usually must be brought directly from Earth. These are the 8 winner processes of the acceptability criteria. We have 3 electrolytic processes, 1 pyrolytic process, and 4 reductive processes. You may recognize some of the names on the slide, such as molten regolith electrolysis or carbothermal reduction process. Here we have the results without the uncertainty analysis, so the first results, let's say. Basically, in these charts, the bigger the footprint, the better the process. Electrolytic processes perform really good in situ indicators and complex indicators because they do not need basically any kind of additional substance from Earth. and they are really simple, straightforward processes. On the other hand, vapor regolith pyrolysis goes really well in operative indicators because it has been designed and tested almost at lunar environmental pressure. Reductive processes, on the other hand, are slightly weaker than the others. In particular, they are penalized by in-situ indicators and complexity indicators because, as I said before, they need to bring additional substances such as hydrogen or methane from Earth, and they need an entire process section to regenerate it at every given time. So this is our first ranking of processes. We have for the podium the vapor regolith pyrolysis process, then we have solid regolith electrolysis, then we have molten oxide electrolysis. As you can see, we have the green part, the upper part, which is a positive footprint, and then we have the red, the negative part, which is the negative footprint of each process. Here we have the results of the uncertainty analysis. So as you can see here, this is an example of what a stakeholder that focuses on mass and energy yield may see. So we have a lot of competition between electrolytic processes and the pyrolytic process that are really near to the so-called positive ideal solution, which is our gold standard, let's say, in the TOPSIS method. Then going on to in situ indicators, we have a reduction of the gap between electrolytic processes and the only pyrolytic process. Basically, for complexity indicators, the situation is more or less the same because, as I said before, in situ indicators, so the compatibility with in situ resources and the complexity of the process are strictly related. And then last, we have operative indicators, which are really interesting results because, as you can see, vapor regolith pyrolysis basically outranks any other process with hydrogen reduction of ilmenite that goes more or less on pair with electrolytic processes, so strikes as the best among the so-called reductive processes. Here we have our last ranking, so we perform more than 24,000 simulations, and the results is that solid regolith electrolysis, which some of you may know as the Cambridge process, is nowadays the most preferable choice in a scale-up perspective. So to conclude the presentation, we developed a robust methodology for in-situ resource utilization processes, chemical processes in particular. We ranked all processes present in literature for lunar oxygen production, and we now know that on this basis, solid regolith electrolysis should be the best choice. For future work, we are going to test the same methodology for different products and feedstock, also on other celestial bodies, Mars, first, obviously, and we are going to get deep down on the reliability and safety analysis because, as we all can agree, they are two really important aspects in space missions and crewed space missions in particular. Thank you so much. If you have any question, I'm really happy to answer.
Thank you. Any question? Please.
Thank you. What is the energy demand, electricity energy demand for the method you selected per oxygen ton or whatever?
Yes, I'll get back 1 second to the indicators formulation. Okay, basically it comes from other industrial studies, in particular from industrial engineering. It's a rewriting of the first law of efficiency, which is used in electrical energy generation, offshore in particular, and it's basically the quantity of power needed to get 1 kilogram of oxygen out of regolith. The interesting thing is that we not only consider the electrical energy, otherwise obviously electrolytic processes would have been real penalized, but also the heat needed, for example, in the pyrolysis of regolith for those processes. I hope I answered.
Any other question? Okay, if not, thank you very much again.
Thank you.
The next speaker is, sorry if my pronunciation, Jan or Jan Pereira, please. The title of the presentation is Adaptive Multi-Role Rover for Extraterrestrial Construction and Exploration.
Second one.
Good afternoon. Well, the lobster robot is not a concept. We are working for the development, and we can show you today something about. We are working a long time in different special materials for any industry. And it's important to understand about the in situ resources. The regolith is very special because it's free, but we need to know how to can do something about. The target is to do some things, different things for our rover. We can the rover is managed by artificial intelligence. Is looking for mining, for cargo transport, for different tasks. Garbage. Is very different than the others because is big, is king size, can walk also, and can change the size for different tasks. Yeah, six wheels, metallic wheels. 6 motor on wheel, independent suspension, because if when the rover change the size, need to have the different, every wheel need a different suspension for work, and can walk also. Bueno, this is the explanation about the surface, the conditions in the surface and Moon and Mars, but this information everybody can get in the Google. What we can do with our lobster? The first we proposed in 2023 in a Congress, we proposed about what can be the first construction. The first construction can be by dry stone wall, like for example in the Earth we have very different examples. For example, in caves like Cappadocia or Petra, or underground under Incuyu. This is the three types, easy types for use the surface anywhere. Bueno, Machu Picchu. Yeah. We have also developing the tools for do different tasks. For example, we are developing also. This is a prototype for our recollect system. Also, for example, we are looking for use the regolith with different causes. For example, this is like a sandblaster machine, but the target is to get the possibility to drilling with the regolith with different granulometry. Vale. The regolith is different in any place geographic. Also, there are different granulometry, and depends the place, the composition is also different. But also, for example, it's different because there are some aspects about the conditions. Then maybe today we have the notice about the composition of the regolith, but in 1 or 2 years the composition is different in the same place because the radiation or anything. So yeah, we can make tests in the laboratory and we can make tests, real tests, but is only a reference. Well, the regolith melt at 900 or 950 or 1000. But the problem is about for melt the regolith we need a lot of energy. This is the problem in the space. And after about the different products we can produce with the regolith, even tiles or including 3D printer. We develop a technology that we don't need energy for. We don't need the melt the regolith because we use a reaction, a chemical reaction that we let us to apply the regolith in continuous, and that let us to build roads or strip landing because we can work like here in the Earth. Of course, the 3D printer is normal. This is the samples that we make with the regolith, different types of the technology, and there are also we make the samples for one United States company about the cover the regolith with gold, 24 carats gold, and we test, we try, and we can do. Well, yeah. The importance of the colony set is to have very good robots, because the humans will wait a little for habitat in Moon or Mars. Yeah. What we can do also, we need to do something else for our rover, because if we want to build the best rover, we need also to give the task and to offer some products for can be inside of the space economy. We have developed also different materials for pressurized habitats. Also, bueno, this is from the spacecraft, jets, or space hotels. We can have different. We can build different materials, panels, and different questions. Yeah, this is, for example, we are involved in a new space community, and one day someone asked me, "What are you doing here?" And we said, "Okay, we will make an exercise about the products, about the panels, about the materials," and we built a CubeSat frame, not the software, 100% both. And this one, we will try next month. We will make the test in the Universitat Politècnica de Catalunya, the test of gauging, vibration, and anything, and maybe we will see what about the result of the test. And that's all. Thank you very much. Sorry, my English is not fluent. I understand. Well, I think you understand my English.
Everyone understand the talk, but if not, please make a question. You're here. So. Any question? No, but I think.
Thank you. Thank you.
Maybe I have a question about your company, but I will do it later. Because you need our technology, but just to understand.
We are a little company. We don't have investors, no public, no private. And this for us is very difficult, because we're progressing slowly, but progressing. We are very happy that what we can do, and we are involved in different projects as suppliers, because, for example, someone have a project, but after don't want to know how to build the project. For example, you cannot go to the supermarket for buy some space materials, no? And we are involved in different projects as suppliers, because we have different products for the different tasks.
Okay,
Yeah.
thank you.
Thank you.
Thank you very much.
Thank you.
So the next speaker is Antonio Niro, Autonomous Moon Power and Environmental Research Element.
Good afternoon, everyone. I'm Antonio Niro, speaker for Ampere mission, where Ampere stands for Autonomous Power and Environmental Research Element, a project born during the years of Master of Science in Aerospace Engineering. Everyone in this room is interested in making the moon a resource, but as we see in the previous presentation, there is a problem, which is the energy problem. Today, I'll walk you through this energy problem, how Ampere aims to solve it, and how Ampere is designed in its three-model architecture, and some final considerations. So, starting from the problem, as we saw, in industrial in situ research utilization plants and construction plants requires huge amount of power to work properly. And as of today, every asset has to think on how to solve the problem of energy, how to make energy and store energy, because there is the clear problem of lunar night, a long period of darkness where solar panel cannot work properly. So this is where Ampere comes in. I would like to say that Ampere can be the first step towards a lunar power grid. Its mission objectives are simple yet very specific, so to generate and store energy, demonstrate the generation and storage of energy on the south pole of the moon, demonstrate the feasibility of power distribution, and set a standard for power distribution to other assets that can be clients. And so last but not least, to have some research purposes, validate some environmental models, such as thermal models, such as dust models or radiation models. Ampere is thought, and the hypotheses are to be a fully European asset, working with Ariane 6 launcher. The telecommunication system is designed to work with the Moon-like constellation, and landing is thought on the Argonaut lander, so the constraint of mass and volumes comes from the allocation on this lander, on this ESA's lander. As of the landing site and the operational site chosen, a trade-off was done, and we can see on in red the landing site that were not chosen, while the connecting ridge 1 is the selected spot for landing, for optimal landing, due to many reasons: safe landing condition for the Argonaut lander. There are some critical aspects for payload survivability, and here we have a higher average illumination with respect to the other spots that we were thinking about. And on the South Pole, there is a clear interest, a clear marketing interest. Most of the mission want to land there, Artemis candidates want to land there, so demonstrating the technology and the distribution of power in this spot is key, is a crucial aspect. Ampere is designed in a three-module architecture. So starting from the payload delivery system, which is basically a foldable ramp with a length of about 7 meters, 6.86 meters, which is a foldable ramp in 5 pieces with 5 mechanical hinges. It's made in aluminum honeycomb covered with carbon fiber strips, and structural simulation were performed on this kind of deployment to ensure that the platform, so Eagle and Scott, can safely descend on the moon surface. Eagle and Scott are basically weighing around 540 kilos together, so the ramp is capable of deploying this structure safely. Eagle is the core of the mission, so the station where energy is produced and energy is stored. While Scott is a demonstrative rover. Since we are a demonstrative mission, we need to demonstrate the distribution of power, and Scott is our future client, the example of future client. Eagle is basically built on a honeycomb aluminum cart. It has some wheels, but the wheels are only used for deployment purposes and for deployment stability as micro repositioning, so not to perform some length paths. And it is composed by 3 modules: lunar payload module, composed by the structure, the thermal control system, the telecommunication system, And we have the lunar sensor module stationary, where stationary indicates that basically the platform Eagle does not move. So every data collecting is performed in a stationary place. And then we have the rover delivery system, basically a system that allows the small rover Scott to be deployed on the moon and to be recharged. The power is generated towards some rollable solar panels with a total surface of 70.34 square meters and a quadruple junction gallium arsenide cells technology. And this allows us to produce during daytime, so when we have the best illumination condition, up to 5 kilowatts of power. And of this power, only 1.6 kilowatts are used by the Eagle station, while the others 3.4 are available for other assets and are available for energy storage. And the energy storage is possible thanks to regenerative fuel cells. Li-ion batteries were too heavy for this purpose, while with only around 140 kilograms of mass, including the structure, we are capable of generating 48 kilowatt hours of energy. And I want to highlight that the process of that the regenerative fuel cells uses is basically a chemical process and also release a lot of wasted heat. And this wasted heat is used in the thermal control system. Basically, it keeps the station warm, and it allows us to operate at a stable operative range between 273 Kelvin and 320 Kelvin degrees. And the thermal control system also has some smart multi-layer insulation with variable emissivity from 0.4 to 0.46, and as well as some passive radiators. Because during the time when we have the maximum illumination, together with the wasted heat from regenerative fuel cells, we have a lot of heat that needs to be dissipated. I want to highlight that the radiators, as well as the rollable solar panels, are embarked with an EDS, an electrodynamics dust shield, because this prevents the regolith to accumulate onto the surface and to keep the properties. These shields are activated when the regolith covers more than 11% of the surface of the radiators or solar panels. Just a quick list of the sensors on board the station. We have some radiator sensors, some magnetometers, and some thermal sensors to characterize the environment. The electricity is then transferred to other assets using two interfaces. One that's wired and one that's wireless. The wired interface is not tested during the mission, but can be available for future assets and future operation where a human operator is involved. While in this mission, the focus is to test the UPFC interface, a ultra-fast proximity charging interface. This allows us to not have a human operator, and as well as not have dusk risks. Here we have a scheme of the control, the PCDU of Eagle, and we can see that the wireless interface is connected to a 120 volt bus, as well as the wired interface is connected to a 28 volt bus. Then small words for the rover. It's basically a small rover, a demonstrative rover, so not a lot of design was done to it, but it has only one job, to move onto the moon surface in a straight trajectory, so not particularly GNC is embarked, and it moves at around 6.4 centimeters per second. And while moving, it has the job to collect data with dosimeters, radiation monitor, temperature sensor. It's basically the equivalent of the suite sensor that's embarked on Eagle. And all of this data collection and recharging is done into a cycle of 9 hours, 2 hours for recharge and 7 hours for moving and data acquisition. The rover is released using the RDS, rover delivery system, basically a system placed under the chassis of Eagle and uses an ejector release mechanism to drop Scott, and the drop is absorbed by the wheels. while also RDS has the job to lower the wireless interface at a standard date of 35 centimeters above ground, so that Scott can come back and recharge after its operations. So Ampere is designed to survive for 12 months and validate these technologies and to set a standard for power distribution. Other assets, while we are there, can charge during this period. For future development, a schedule of this of charging can be done, and also in the future, if the technology is validated, Eagle is a single block for now, so more blocks can be placed together to perform a lunar power grid and meet the requirements, the energy requirements set by the construction and in situ research utilization plans. So thank you all for the attention. If you have any question, I'm free to answer.
Thank you very much. Are there any questions? Okay.
Okay.
Please.
So do I understand correctly that I can speak now, okay? So do I understand correctly that the rover goes underneath your Eagle?
Yeah.
So it's not the far, it's not the RF wireless transfer, it's near field transfer, right?
It's near for yeah. The wireless interface lowered so that it can almost touch and yeah. Thank you.
Okay, thank you very much again. So the next speaker is Mikhail Szczepanskis on the opportunity to leverage spent nuclear fuel for scalable radioisotope power system, enabling lunar night survival.
We cannot access Lisbon. So that was, I think they did a mistake. I can also connect with my laptop. I don't know if we can. I need to ask, but I don't know how to ask the responsibles for this. Do you have maybe a USB? I need to ask the technicians. No, I don't have.
There is no your presentation.
There is in the presentation.
You have the stick? Also.
They put me in a different room.
C'è qualche altra presentazione lì?
Ci sono queste qua del Moon Village.
Okay, we make a switch. So please, Maria Mukarzal, are you in the room? Andrew Thomas? Andrew, have you your presentation on a stick with you? Okay, thank you very much, so that you can upload it. No.
I have put it through the system, but I also...
It's not there, so please.
Okay, I also have it on the stick.
Thank you very much.
So that's the PowerPoint. Yes. This is the PDF. Oh, that's a PDF. Okay, sorry. Okay. Okay. With the fine. Okay, are we on? Okay, thank you very much. I'm very grateful to the Moon Village Association for this opportunity to speak about a little bit about philosophy and social sciences. It's not moving. Hang on. Why is it not moving? It's not moving. Oh, I can do it that way. Okay. Okay.
when I was a boy, a long time ago, my father made me stay up late and see the landing of Apollo 11. It was late, it was 2 in the morning, and when you're a 15-year-old boy, you don't listen to anything your father says. But he told me it was important and I should see it, and it was, and I did. Buzz Aldrin, when he came, he said to me that he was one of 2 people who were the first people on the moon. He was the second man out of the capsule, but he was one of the first people on the moon. And that's his autograph when he came to the Space Center in Leicester, in my country. On the right, you see at the Paris Air Show outside, there was a forum about a term called extractivism. I wasn't quite sure what it was. And it seems to be a movement which is concerned about the development of extractive industries on Earth and, by extension, on the lunar surface. Now, the argumentum ad hominem comes from, actually, this is Rubenstein, 2022, and she makes an argumentum ad hominem about Musk and Zuckerberg and so on, very critical, but a very personal attack. And again, Tamara Alvarez is concerned about the director of ESA and the way in which ESA is speaking to industrial figures. I don't think an argumentum ad hominem is a very good way forward, so I'm proposing a different way, which is looking at scales and a transscalar approach. And basically, Ivry talked about a full calibration of our critical modes. It's a way of encountering texts, and just, you can have a copy of this later, but basically that you can operate at different scales at the same time. Scales are nested, but they give a structure to the argument that you have, not a personal attack. And I consider that there are 2 scales of time which are relevant here. The first one is cosmic time. The second one is human time, which is much tinier. We haven't been here very long in the history of the universe, in the history of the cosmos. Akili Mbembe, this is a second point that I make, talks about colonialism and how he said, and it's in bold, the reallocation of the Earth's resources and their privatization by those who had the greatest military might and the largest technological advantage. And he said that that reallocation of resources, which is extractivism basically, was the colonialist process that he objected to. Just to remind you, Frantz Fanon talked about the small people of a nation. And to the left, you can see a photo from the 1930s from Harbin in China, which has got a hairdresser on one of the, Paris Macher, and in front of it a lorry containing Japanese troops. To the pictures in the middle are the Japanese making railways in Manchuria and a temple. To the top right, you see the French occupation of West Africa in Dakar, and to the bottom, French Indonesia. And I've done what the Germans called Überblenden, a black and white contemporary photo onto a modern color one, so that you can see that the geography is the same, but the political control is different. Dipesh Chakrabarti realizes that when you use the word globe, the globe in the word globalization is not the same as the concept of globe in global warming. Very precise use of language. Globalization is an economic function. Global warming is a physical function. He makes a very strong point that the atmosphere does not care whether the gases in global warming come from a massive volcanic eruption or internally unjust human societies, which he describes as a struggle between humans for the appropriation of land, sea, or space. He also goes on to say that there's nothing in the history of the planet that can claim the status of a moral imperative. And I'm going to spend a couple of minutes on a moral imperative. You see, on the left, you see the magnificent desolation. To the top right is a black and white, I've black and whited a picture I took from an aeroplane in southern Australia of a mine. And you can see that that could be what we may be doing to the moon at some point. And to the left, again, I've done it in black and white. The small one is in color. This is the Gongchang, the factory shown at the National Museum of Science in Beijing. So these are structures on the right which we might put on the front. Question I ask is that willful despoiling of the planet, of the moon? Karl Marx, who wrote about everything, says, and I quote, "The dealer in minerals sees only the commercial value, but not the beauty and the specific character of the mineral." He's talking about gems, diamonds, and so on, that you can trade in gems and so on, but he doesn't see the specific character. And I ask myself, are there planetary specific characters? And indeed, Alois Nemiesh, who was a Czech geologist, spoke in 1936 and said, "The Earth is alive, but not an animal or even a higher being. Its vitality lies in the fact that as a part or complete complex of the mineral kingdom, it is subject to the natural forces that act on it," and so on. And he says, only a living Earth can be the sustainer of everything that represents a higher level of life on Earth. So he saw the continental structure on the surface of the Earth as being a planetary characteristic. And indeed, if you look at, and these are some of my own radio observations at about 30 hertz, 20, 26 and 32 hertz, you can see that those emissions are energy peaks in the portion of the spectrum of ELF around the Earth. Similarly, there are lunar characteristics. The orbit precesses. There is no ionosphere. There is dust. Dust is a nuisance and a hazard. It's also a record of the solar system, of the geology. Doesn't have a magnetic core. It has exposure to, so we have exposure to solar flares. So there is a vitality in this, as Nemiesh says. Its vitality lies in the fact that as part of a complete complex, it is subject to the natural forces that act to it. So basically, the moon is a valuable and vital entity. Moving to some Western philosophy, Kant basically talked about duties, and the duty to life is the overall duty, and there is no threat to life in what we are talking here. We have no duty to inanimate objects, but Kant writes that a propensity to wanton destruction of what is beautiful in inanimate nature is opposed to a human being's duty to himself. So planetary protection is a duty, our duty to ourselves. And if you moved away from the Kantian system of duty to John Stuart Mill or Jeremy Bentham, you talk about the greatest good to the greatest number, Bentamism, and you see that the percentage of the world population represented by Artemis is approximately 27%. But if you take the BRICS, Brazil, Russia, India, China, South Africa, and the new countries, including Nigeria, then that's 55% of the world's population. So perhaps under the utilitarian argument, we should be looking for the greatest good to the highest population of the world and not to the technologically advanced countries. Kant also said that there's a categorical imperative, which is something that is objectively necessary. And I pose the question, is mining the moon objectively necessary? Hypothetical imperative is practically necessary as a means to getting something else. And I'm going to wrap up talking about what that something else might be. So it's stuck. There we go. So it's okay. So let's talk about titanium. Clementine showed in red the distribution of titanium on the moon. This is an example, Chango 1, Chango 5, and so on, specified in particular various oxidations of titanium. There's a production flow on Earth of titanium, and the first stage is a titanium sponge, and then the titanium ingot. Now remember, we're on the moon here, and so there is titanium sponge on the left, and you can see that what we have is a massive factory, and it processes this titanium. What do people do with this titanium? So any import from the moon, any product that you make on the moon to go into Earth will be taxed by import taxes, and that will determine what is worth doing. And so I think the extent of factory production on the moon could be simply the extract of raw ore, or possibly titanium sponge, the first stage processing, possibly the ingot. Then there are some products, which I'll put on my last slide, for use on the moon. But what I think is significant is that if you processed quantities of titanium sponge and you held them in your sovereign base area, then you would be able to be in a very strong position in the international commodity market, and you could fix the price. And bearing in mind that the development of aviation engines in the next 10 years is going to take 90% of the commodity market at the moment, you can see that the mining of titanium sponge, of titanium ore, and the processing to titanium sponge would be very lucrative indeed for the country that could do that. It is also possible to build a rocket moon on the moon. The escape velocity, the delta V, is lower. You can get a peak specific impulse, and you can build in you can apply it in extreme environments. And again, the potential applications of a rocket engine built on the moon could be defensive if somebody attacked your factory, or offensive if you wanted to attack theirs. Planetary exploration for people who wanted to move about the moon. Or you could return the bulk ore of titanium sponge to Earth. Now, I know that the Olympic Dam mine in South Australia, I've been there, and if you go along the roads, they have massive, what they call road transport engines that move all the excavated soil or deep soil, the ore, unsorted, and they ship it down to Port Adelaide and they export it. So it is possible, simply, if there is a mechanism, to process the bulk ore back on Earth. But I think they would do first stage processing to titanium sponge. So, conclusions. On the temporal scale, human presence in the Earth-Moon system is actually relatively new. So on the human scale, we are in the universe. We are players in the universe. But the universe probably doesn't care whether the moon is despoiled by us or by a meteorite. The time frames are infinite. And so, in terms of ethics, I think humans should use their conscience to decide whether you are going to be despoiling the planet or whether you're protecting what Buzz Aldrin called magnificent desolation. And my other point is that to appropriate valuable territory by technologically advanced bodies or countries, depending on how the consortia develop, is a form of colonialization. And I would hope that as a humanity, we have moved forward from that. Thank you very much for your time. The QR code is actually a link to some other work on lunar settlements, which I've distributed around the conference in the last few days. Thank you, and any questions?
Thank you very much. Any question? Yes, one question, please.
So thank you. This is an excellent set of considerations. The question is, what do you recommend?
I knew somebody would ask that. I didn't think it would be the first question. I think my big concern is, as humans, we have a responsibility to ourselves how we go about the interaction with the moon. Kant would say that there's no a priori reason, but we affect ourselves. For me, what is important is that we do not exploit our technological superiority and our logistical superiority to maintain the gross inequalities that there are on this earth. And I think even, the principle of utilitarianism is that you do the greatest good. The greatest number of people are not represented by Artemis. There's 27%. So we have to give serious consideration to who are we doing this for. And so that is my recommendation.
Thank you. Any other question? Yes, please.
Can you hear me? Yes. More than a question, it is an observation. Two kind of things. As in Space Research International, we consider that the usage of materials from the moon and from space, and I think that in all the other presentations that we have seen also in this conference, the materials from the moon should not be used on Earth, but it should be used for expanding the human presence in the solar system. That is, presence on the moon, a presence as we foster very much in space station like Gerald O'Neill devised. So the material from the moon is required for that. And even if you compare the economics, bringing material from the moon to the Earth is foolish. There is no reason to do that. And no one, I think, wants to bring minerals from the moon to the Earth. Minerals from the moon, if you read, for instance, the High Frontier of Gerald O'Neill, can be used to make space stations. And this is the rationale behind using in situ material, because in situ material is required for local use on the moon or in space. So basically, this is one observation. The other observation, you say the BRICS represent the majority of humanity. Yes, Russia, India, China, they all want expansion into space. That's all.
Okay. I hear what you say about the use of materials on the moon and it to be used for the further exploration of space. And that is certainly possible, as I put in on the last slide. I would say that if a nation holds large stocks of a valuable mineral in its early stage processing, which is titanium sponge, then it's arguable that that holding will be influential in the market price, in the commodity market on Earth. Even if you don't actually ship it there, you just need to show that in principle you could. And so I have that doubt. On the second thing, yes, of course, India and China, for perhaps different reasons, want to go to the moon, and they are on the moon, and they want to expand their space programs. Of course they do. I mention them simply because as the BRICS community, Brazil, Russia, India, China, South Africa, and the new BRICS communities, they constitute the majority of Earth people. And so the principle of utilitarianism does not lie with Artemis.
Yes, but it is not Artemis that is about exploiting the moon.
Yes, okay, sorry, but this is a very interesting and also very long conversation. We have still 3 presentations, so thank you very much, Andrew.
Thank you.
So that we can move on. So please, Michael.
This one? Yeah, this one. Okay, you can move those keys. Okay. Good afternoon. Good afternoon, everyone. My name is Michael Szczepanskis. I'm CEO of Deep Space Energy. It's a small startup company. We're based in Latvia and have offices in the UK. Today, I would like to talk about the power on the moon. I will oppose for the one of the presentation before. So just to make some intrigue here. Okay, first of all, just a couple of words about myself. So I hold PhD degree in physics from University of Latvia. I had the privilege also to work at Argonne National Laboratory in the United States for a couple of years. And then I quit my academic career, found engineering software company. It was 8 years ago. Now it's international business, profitable. So I exited that, and since 2022, so it's a very young company, I found Deep Space Energy. Today, Deep Space Energy has headquarters in Riga, Latvia, and also we have office in UK, Coventry. Very young company. We got a bit less than $500,000 in public funding from ESA. And some other projects, also private pre-seed funding, also under $500,000. And we also are member of ESA BIC and Diana NATO Accelerator. And we have partnership with Thales Alenia Space here in Italy, and also Airbus Defense and Space, which actually brings us to supply chain. Nice picture of our team. Okay, so everything I want to use the opportunity to be philosophical, especially after the previous presentation. Everything in our world is about 2 things: transportation and energy. And here in Italy, you know that very well, because even ancient Romans built roads which outlasted the empire and still are here. So it's about transportation. So in my speech, I want to solve the energy problem, but it cannot be solved without transportation. Why? Because actually to deliver 1 kilogram for the payload to the moon is like extremely expensive. Yesterday, Thales Alenia Space told me the price, 1 million per kilogram. I honestly, I don't know whether it's true or not. Maybe it's just too much. It's like R&D price for Europe. It probably it's low, but still is just more than 100,000 per kilogram, right? So it's quite a lot. So that's why when we bring some power assets to the moon, we need to take in consideration what is the price, what is the weight. So, and let's make the very simple math. Let's take the very small rover, which represents scouting and prospecting rover, about 100 kilograms of the weight, and make a simple math, approximate math, to survive lunar night if we want. Actually, we have seen quite a lot of examples that lunar rovers do not survive the night, but if we want to make it sustainable and make a prospecting and scouting of resources, apparently we need to survive the lunar night. And for that, for 100 kilogram rover, small rover, we need 15 kilowatt hour energy. So 15 kilowatt hour energy with lithium ion batteries is 100 kilograms, the same size of the rover. It's quite a lot. So it's no go. Instead, we can use 42 watt radioisotope power, nuclear power, which is approximately 20 kilograms. I will address this calculation later in my presentation. So it's 5 times gain instead of using batteries. And what if we want to operate during night, or we want to go to permanent shadowed regions? So it's a rhetoric question. So the demand will be even higher. So what is a radioisotope power? So it's a nuclear material which undergoes self-decay and produce heat no matter what. No sun, no nothing, just produce heat as a self-decay of nuclear material over the decades. And then if we need heat, we can use it right away. If we need electricity, we need to convert that heat into electric power using conversion system. And historically, in very early days of space exploration, radioisotope power was chosen because it was reliable and cheap. So this is the picture of Apollo mission, and the astronaut just pulled that fuel out of the lander and put it in RTG down near his legs. So it was cheap, reliable, understandable, but it was cheap. Unfortunately, not anymore. It was cheap because it was byproduct of nuclear weapon production. And since the end of Cold War, radioisotope production became prohibitively expensive because nuclear weapons are not produced anymore, at least at that scale. And all production facilities were decommissioned, even in US. So that terminated supply chain. And supply chain was Neptunium-237, that radioisotope which was sourced as a byproduct of nuclear weapon production and also irradiated then in the radiation facilities to produce plutonium-238. As a result, so the material became expensive, extremely expensive. So it's the price per watt. Let's go back to the simple math. There are 2 options how to make it cheaper. Either you make the fuel, so the resource, cheaper itself, or you make the conversion from heat to electricity more efficient. So we, as in the company, addressed the first, the conversion, and we proposed dynamic converter. So Stirling type dynamic converter can convert heat into electricity with 25% efficiency, and we demonstrated that already. It's 5 times more efficient than legacy thermoelectric generators used by Apollo, used by Voyagers, used by everything we know before. So as the example, this 25% efficiency means that 200 watt thermal converts into 50 watt electric, and it needs 2 kilograms of americium-241. This is radioisotope used, anticipated to be used by Europe now. So for RTG, it's 10 kilograms. You see the difference, 2 versus 10 kilograms. So, and this is actually the last but very busy slide I want to walk you through just to show where we work right now. Historically, so military Neptunium-237 irradiated to plutonium-238 created 87 years of resource, which can produce 500 watt thermal per kilogram. So it's not available anymore. We can forget about that. Nowadays, in France and UK, there is a unique situation that they actually reprocess spent commercial fuel, nuclear waste using Purex process to separate plutonium and uranium. And then this plutonium-241 self-decay over 14 years in americium-241, and then this americium can be extracted. So this is exactly the way how Europe now approach this. So americium-241 is the resource. Unfortunately, it costs 20 million per kilogram right now. So we expect the price can go down, but 20 million per kilogram. That means for 50 watt electric, we need 40 million without delivering that to moon, right? Without delivering to moon, it's only for fuel. So now we work with a new opportunity, which is a very extremely actually good opportunity. Other countries around the world do not reprocess spent fuel, nuclear waste, but store it as is. And over 30 years, actually it became the problem. So now it's a severe problem in Germany, Belgium, Spain, to actually, because it's the pile stock of the old fuel, spent fuel, which create the problem, which is nuclear waste. But that nuclear waste, old waste, contained 5% of neptunium-237, which can be chemically extracted if we put into place this processing, reprocessing process, which is anyway needed by countries. And then we can put that in the irradiation facility in material testing reactors. We have quite a lot in Europe and around the world such to produce plutonium-238. And this is already tested at TRL 6 process, irradiation process. So if we done commercial, we have the target price. So we target 2 million per kilogram of plutonium, and then for 50 watt electric, we can use 0.4 kilogram plutonium, which is 800,000 euro. So that is, we target 400 euros per kilowatt electric on the surface of the moon commercially. So this is our business. So we want to offer this power, solar independent, 400 euros per kilowatt electric. Yeah, I mean, I want to end my presentation with very high-end statement. Terrestrial nuclear waste is not nuclear waste anymore. We can transform that into the cheap and reliable energy on the moon. Yeah, thank you for your attention.
Thank you very much. There is just time for one question, if there is. In the meantime, if Mr. Yusuke can prepare itself. Okay, no question. So thank you very much again. Mr. Yamashiki Yusuke.
Oh, here, everything. Yeah, everything is here.
Okay.
Thank you. So how can you?
The
yeah, the video first.
Okay.
Can you put this into the mute?
Yeah.
And the mute, the volume off. And can I operate? Hi, this is Yosuke Yamashiki from Kyoto University. No, you can music on. You can turn on the volume.
Turn down the volume?
Yeah. Hi, so my name is Yosuke Yamashiki. I'm introducing our lunar artificial gravity facility by introducing this video. And actually, because of the time, I will skip the most of the part. But is it possible? Can I increase the volume? Okay. So the lunar travel has to be coming from the Earth and by some of the vehicle. But we are proposing to utilize artificial gravity facility like this. Oh, this is actually from the Expo 2025 in Osaka. So what I'm proposing is to putting that kind of it's a hexatrack and rotating and keeping the artificial gravity on the trip. And then when we arrive to the moon, there is a rotated cylindric facility, which we call it lunar glass. This developed by the Kajima Corporation, and we are Kyoto University is collaborating the development. Actually, this music was composed by myself, so please enjoy. Actually, so what the point is that cylinder is rotating always for 3 RPM, and the diameter is 200 meter, and the height is 400 meter, and we put everything, including the ocean and forest and settlement inside of the facility. And then the point is the gravitational force is like in the rotating angle. This is a summation of the centrifugal force and gravitational force. So the lunar gravity is 1/6 of the gravity of the Earth. So if you have a centrifugal force, you can make an equivalent stage. The point is, can we build like a mini ecosystem on the kind of the structure here, like this? And then sorry, I am moving, I am speeding because of the time. And then from the moon to the Mars, we also use artificial gravity railway system. We call it hexatruck. So hexatruck is a concept of the galactic express using the 3, and also it will be injected by the electromagnetic injection and EM launcher, and then the length should be longer than 3 kilometers, and the rocket propulsion parts should be the half weight with the total mass. And then considering the lunar weak gravity, we can just launch, and when it launches to the space, it will be reaching the station. And in the station, this vehicle will be injected into the rotating cylindrical facility, and that is a hexatruck. And this kind of a hexatruck will be moving by rotating to the Mars. The Martian trip will last 6 months, and then this maintain the gravitational force so that the physical component of your body can be sustained. And then when you reach the Mars, and there is another station, we call it the Martian station, and by this, and then you transfer the train into the different shape, and then coming back. And on the surface of the Mars, we have a similar facility. We call it the Martian Mars glass, but the shape is a little bit different because of the gravitational force is different, right? And inside there is a couple of the structure in the biome, like this. But this is actually, it's a too exaggerated image of the terraforming Mars, but it will take a long time. But so basically, the people will stay inside of the rotating cylinder, which we call the terra window, instead of saying terraforming. So can I move to the next slide? So actually, how can I move this? Right? Yeah, just, okay, sorry. So can you stop this? Okay. Yeah, I will very quickly talk. Okay. Actually, so the important thing is, instead of doing the terraforming, where we propose the terra window, and in the terra window station, you have to supply the oxygen, drinking water, food, and energy. But not only the important thing is the artificial gravity and also the reuse system, and space radiation protection. So this we call it a core society challenge. And also we introduce a bioecosystem and the core society. Okay, I will finish in 1 minute. And the important thing is we want to cultivate the coral in the ocean. The ocean is actually nothing to produce, but the ecosystem ocean is very important. So we are doing the independent coral reef isolated cultivation experience for a long time, 1-2 years. And also, in total, we would like to propose artificial gravity network connecting Earth and Moon and Mars by artificial gravity and also the closure ecosystem. Thank you very much.
Thank you very much. So I'd like to move on to the next speaker, the last one. Otherwise, we are very late, so in case for question, there is time later.
Hello, everyone. Thank you for being here, and thank you for MVA for giving me the chance to present an analog mission that I did this summer. So basically, I'm a dental surgeon, and I did also studies in political science. I belong to SRI, Space Renaissance International, and EMM Pole with Bernard Fowing, Euromoon Mars Poland, which was with whom I went for the mission in Poland. So my degrees are dental surgery. I also have political science from Paris-Saclay. I'm finishing this year a master in diplomacy and negotiations, and I hold a bachelor degree in philosophy, medical philosophy from Sorbonne University. Okay, during my mission in summer, so I served in the crew as a medical officer, and I was responsible of taking urine every day from the crew to see the color of the urine and to measure how much they are drinking water, and also to see the acid in it, the concentration, also blood pressure, and they had to wait themselves every day to see the evolution. It was 10-day confinement. Total isolation. And also, beside this, I focused on a topic that interests me a lot, which is mental health and the human-centered approach and the well-being of the astronauts during the mission. If we go back to the classical philosophy, we have Aristotle, who always used to say that man by nature desires to know. And I think one of the things that motivates us in space sector is to know and to discover more, to go beyond our limits. And we have Descartes with Galileo. They coexisted in the same era, and who considered that everything was chaos, and they were able to organize more the space field. They were from the first people who did that, and they were the ones saying that it was the Earth rotating around the sun and not the other way. On a more modern philosophical field, we have Hannah Arendt, and Hannah Arendt was a bit skeptic about the space race. She was afraid that it will dehumanize the human being. And this is one of the points also that I share with her. So this is why I am more into the human-centered, and I care about the well-being of the astronauts, because they are not machines, unlike everything we saw during the last days. So a small idea about the mission. It's with the Astronaut Analog Training Center in Poland. The region is called Trzepinik, the village so in southeast of Poland. In the middle, you have the picture showing multiple sensors. It had to show the CO2, the O2 level, the pressure, the temperature. So we were controlled virtually to see the parameters, the evolution every day. And you have the map showing actually the different rooms. So you have the main entry. We had a kitchen, bedroom with 6 beds. So basically, the crew should have been only 6 people, but we had a last-minute surprise. A 7th person joined us the same morning, which was actually not really positive news because the oxygen during the mission was only calculated for 6 people. So this is also one of the constraints that we had. There's also a gym and a toilet and a small kitchen. This is a picture that I got whenever you enter the habitat. So on the left side, you have a geolaboratory, and at the end of the corridor, you have the bathroom, the gym, and on the right side, whenever you enter, it's the entrance for kitchen and bedroom. These are some pics from the lab, from the kitchen, etc. Voilà. This is the crew. We had multiple backgrounds, engineers. I was the only one from the medical field, and astrobiologists, but mainly engineers. So. Okay, so one of the experiments, we had the plant experiment. They wanted to see how the plants are able to actually consume CO2 and to give oxygen, and so, which is the goal during any mission, and to produce O2 for the astronauts and in the space station. So this is how they are. In the middle picture, you can see how they put the plant inside a recipient, and you had sensors connected to it, and we see that the result they got is that the CO2 was consumed over time, but the parameter that really affected the result is the light condition and the plant type. Definitely, further studies are needed to work on the plant plant experiment to have more conclusive results. Also, another one is the kombucha. Kombucha is now very also recommended by ESA and NASA to give the astronauts whenever they are on a mission, because actually it's a kind of a herb that is very good for the well-being. It prevents also even constipation. It gives it is antioxidant, so it helps the astronauts to survive in better condition during their mission. The goal of this study was to see the evolution of the kombucha in different types of recipients, so they would know how to send it with the astronauts. It was either in plastic or glass jar. The vacuum vessel showed strongest acidification, but the glass vessel produced the highest biomass. That was the conclusion they got. Also, there's another molecule called the spirulina, which is an algae, also recommended lately by the ESA to be given to the astronauts during their mission. It's also an antioxidant, and it gives them energy since it works on the mitochondria of the cells. So it gives them energy and power during their mission and fights more the sleeping and the fatigue during, especially in long mission. So for them, the medium that caused strong acidity and low biomass was the pure SCOBY. SCOBY is when you do the culture with bacteria and yeast at the same time. So anyway, also further studies are needed, but the medium to use it is still under study, so no conclusive really results. Now we go to the mental health and well-being of the astronauts. So I did some tests called the POMS, so the profile of mental stability and resilience for the people. And you can see here you have 7 colors in each graph, and we had an emergency actually during the 10 days. That we suddenly lost any kind of communication during 3 days. We went into full blackout, no communication, no light, no electricity. We lost everything. So it was a really challenging phase. Each one of us discovered themselves. We didn't know how that we would react this way. Some people cracked, some people cried, some people... Anyway, so we went through many stuff during those 3 days. So one of the tests was like to tell them how to feel 3 minutes, 5 minutes, and to estimate 8 minutes. These are also same tests done for people who are athletes or go through extreme sports, like they do the Mount Everest or anything. So because when the human being is isolated, he will lose the time perception. And this is what happens, especially when they are in space. They are alone, and if any blackout happens, it's important to know that our astronauts, for example, they would know how to estimate the time. Sometimes it helps them for survival issues. So as we see, on the horizontal axis, we have day 1, 2, 3, since the blackout lasted 3 days. And you see that in the beginning, for example, we were able to estimate almost, for example, the 3 minutes, and then you see that the graphics are very randomly showing. Sometimes the 3 minutes, we felt them like 8 minutes. So time, even we lose the control over time and whatever we are feeling with our surrounding, and this is very disturbing. Actually, the feeling is really disturbing when you feel it. Yeah, so it's the same thing whether it was for 3, 5, or 8 minutes. And also here, another example on how it deviated. Day 1, it was okay. Day 2, the 3 minutes, we felt them like 8 minutes, and then it was maybe a bit better on the 3rd day, and vice versa for another astronaut analog. He diverged a lot, so it's very random, very moody. Now, psychological insights about this blackout experiment. So this 3 full-day blackout we had, no lighting, no communication, and sensory deprivation, it forced us to have at least a group cohesion, emotional support, and internal coping strategies. We had very disrupted sleep cycles, super late nights. The 4 a.m. we felt it like 6 p.m. We were full of energy. The 2nd day we weren't able to wake up. So our life was upside down. Increased irritability, emotional sensitivity, tears. Group emotions became more noticeable due to lack of external stimuli also. But by day 3, we started to adapt a little bit, and we found some resilient issues like singing, playing cards a bit, talking, sharing stuff, with each other. So communication was key to us. And this highlighted the importance of empathy, communication, and resilience in extreme environment, whether in space or any extreme sports on Earth. So even when you send Navir people going to Antarctic, for example, they do some stuff also to stay as a team. And this raises actually ethical and policy question for astronauts. I mean, we should make sure that astronauts have real-time psychologist support in analog missions, that they have acceptability of total deprivation as testing method. We were not really aware of the 3-day blackout. How to manage stress through empathy and benevolence, and insights contribute to mental health policies for future lunar or eventually Martian crews. So, because we always think about policies like defense or cooperation between states, but we forget the mental health and well-being of the astronaut. And finally, the human-centered practices that we used are storytelling, reflection, journaling, which we wrote, and they were like emotional lifelines, and so again, policies. And I felt it a bit like a micro-diplomacy within the crews, because we had to do some cooperation, dialogue, and balancing personal versus collective needs, because when under stress, it's very easy to get irritated. So this is to keep in mind. NASA lately emphasizes countermeasures during these emergencies, like humor, storytelling also. So we have to keep in mind all the space mirrors, so ethical issues like for privacy, workload preferences, limited resources. And in resources, as I said in the beginning, we had a big stress concerning the oxygen, because we were 7 instead of 6. Even the food, the hygiene, the sleep conditions, all of these are converged into the ethical framework of any mission. And also importance of informed consent, detailing actual risk and condition to reduce confusion and anxiety. Thank you. If you have any questions.
Thank you very much. Okay, if there is a question, I would like to invite Ernestina Binni for the next panel, last panel of this day session.
You have a question?
Thank you all. Thank you.
There's a question, or?
I have a question. Yeah, please.
In the meantime, yeah, I can answer.
You can do it. Please do it.
Yeah, I mean, there are many questions, but there is just one.
Just one.
The one related to the production of oxygen with plants.
Yes.
Have you at least identified some plants that are more suitable, or is still all together?
They are working on the article. The 2 girls who are working on it told me not to give more details. They want to publish it before, I don't know, so I just kept it. But yeah, it depended. They tried with different types of plants and lighting, and it differed depending on. So these are the 2 parameters for them: type of plants and lighting. Yeah. Right.
Good afternoon, everyone. Here I am. Thank you, Giuseppe. Thank you, Alessandro, for the opportunity to be here every year with Women in Aerospace. So in this panel, I'm not representing ESRIC, but the association. And last year, the Can you change the maybe? Yeah, exactly, but doesn't matter. Last year it was Women to the Moon, and this year is Together to the Moon. Before to start, would you like the three wonderful women that are with me to present briefly themselves? Unfortunately, we know that we should finish at a certain time, and so we are going fast. Thank you, Christian.
So thank you very much for the invitation. So my name is Christiane Bergman. I work at OHB System AG, and I'm the Business Development Manager for Science and Space Safety. That is not exactly the topic today, but as a patient for the Moon and project manager for exploration topics, I accepted the invitation from NRC with a big pleasure and a big honor.
Thank you.
Thank you, Ernestina, and thank you everybody for being here. I'm Veronica Moronese, I'm a space lawyer. I'm a member of the Center for Near Space of the Italian Institute for the Future, and I serve as Director of Legal Affairs and Space Law at Think Orbital. I collaborate with various institutions around the world on the space exploration, but also human expansion in outer space, the construction of human settlements in space from a legal perspective, and my fields of expertise are also space mining and space tourism. Thank you.
Good afternoon, I'm Stefania Grotti. I am a senior research manager. I worked for several years for Politecnico di Milano and Sorbonne University, and now, starting from September, I am general manager and executive director of the University Foundation Milano Bicocca in Milano, and my job is really helping researchers, academics, to develop their research, supporting them to be really excellent scientists. Thank you.
Thank you. Yeah, I'm very glad to have you here to explore how we can go together to the moon. In fact, we had a reflection between us, and you know, we came out with the idea that when we are going to the moon, we are going beyond technology and science, but it's a universal journey, as remember to me, Veronica, and so it's requiring an effort from everyone. We cannot only thinking about science and about technology, but we should think also, as explained before, about the humanity. And there is another point that I would like to check with you, is that because we know that we should involve also the community that are not part of the space community, and a lot of time it's very difficult to bring the message, to convince them to come together with us. So let's start with Christian. Christian, what do you think? Why we should go all together to the moon? Why it's important?
So I will take your words to jump here. You are completely right that it's much more than a technological advancement. This is a journey that will reveal the insights of the past and will motivate the next generation. And as you said, the key challenge here is how to transfer this enthusiasm that we that are in the deep inside in the topic and working daily with this topic, how we transfer this enthusiasm to the people or to a bright public information that it's not exactly inside the topic and it doesn't have this passion that we have. So the importance here is to try to combine communication strategy for all areas, industry, research, legal part, SMEs, institutions, and so that we can together transfer really the importance to these activities, to importance to explore and to show that it's a progress, there is a leap, there is a giant leap for the humanity progress, the activities that we have been working on.
Thank you. Can I repeat what you said to me?
So
or you remember?
I remember that I said to you that the moon belongs to everyone and it belongs to no one. So why that? That is, according to the space laws, nobody can have possess and can colonize a planet, a space. So everyone should take benefit from the this great progress that we do with these activities, and belongs to no one, that is terra incognita. So it's have not been explored, and we need to go there and to explore, but doesn't mean that the nations that have technology advanced should use this add value that they have, or this benefit that they have, to dominate other nations. Should be really a benefit to all of us.
Thank you. So I think it's perfect for Veronica as a space law. When we start the conversation, I said, I took the notes for Veronica. So I said that the space is belong to the humanity. And Veronica said to me, no, this is universal. You should use the word universe, not human. Can you explain better?
So my note was rooted in the very root of the word human, because in Latin the word humanus is tied to earth, to soil. So if technically speaking you are talking about a human, is somebody who is tied to this planet. And when we will be going to space to expand our presence in space, I do not want to use the word colonize, because according to the treaties, we cannot colonize anything in space, because, of course, there is the prohibition of any claim of sovereignty. So when we will be going to space to inhabit it, we won't be doing it as Italians, Americans, or whatsoever, but we will be doing it as a species. And when those settlements will be established and thriving, the people living there won't have any strict tie with this planet. And this is very important, because everything that we, as of today, imagine as universal is always imagined in a geocentric perspective. Even if you are thinking about applying something to everybody, is always somebody on this planet, a national on this planet or whatsoever. But this won't be the case in a distant future, when we will be inhabiting space. And so it is not technically correct to say that space belongs to all humans. It is a universal resource. This leads to a lot of questions regarding what will be the laws applicable to those settlements, because when we think about the human rights, we say, okay, those are universal, but are technically, again, humans, so tied to this planet. It will be very, very interesting in a way more distant future, when the biology of people living in outer space won't be acceptable for living on this planet, so they won't be technically even humans. This leads to so much questions, of course, regarding space law, but for what concerns our today's scenario regarding space law, it is very important to start building those questions that can lead to the creation of a legal framework for those settlements in space, because again, those won't be colonies. Everything that we will create in space will be inheriting in international, again, because there is the prohibition of claim of any kind of sovereignty. And we cannot just have principles in outer space. They will need rules to, again, to rule their everyday life, and also the relationship between the settlement and this planet. And that set of rules will have to be understood and shared internationally, of course, because, again, there won't be the possibility to have one national legislation on a space settlement. So this opens so many possibilities regarding cooperation on an international level.
Yes, there was a point that we said between us that anyway it's important to give the opportunity to participate at the discussion to everyone, right? So also not always Europe, US and so on, but also all the other states, and so work together through the law. Stefania, I should jump. Sorry, this one was an interesting discussion, the one that we had last time. Stefania, what's about the collaboration? Because you are in a research environment, so we have spoken about the importance, right, of collaboration in a research environment, how we can bring that also on the space, activity and so on.
Yes, it's really important, first of all, to explain to everybody, to the public, to the citizens, why research is important. Because every day, you researchers, you give answer to problem, to society's problems. And that is fundamental. And you can for sure, in your small topics or important research topics, do really an important job. But for sure, if you could be complementary with other researchers, with other academics, with other institutions, you could for sure resolve other issues and other problems or other questions that every day everybody asks for or try to give an answer for. That is really fundamental. Now we discuss always about public engagement because the research activities are expensive. In the space, there are a lot of expensive. And then my job, our job, it's really to help the academics to try to find solution and to find opportunities, to find grant, to support them, to develop them, to disseminate the output of the research, and from this output to commercialize the research and develop the patent, etc. And then from that find an answer to new research opportunity. Then I think that it's really a collaboration. The collaboration is fundamental between competencies inside the institution, but also outside of the institution. And then we can only work together and collaborate and find really the right partner in order to give a voice to our research opportunity.
Thank you, Stefania. Unfortunately, we don't have a lot of time, but I'm having last question, the same for everyone, that is mainly what we have discussed. It was which initiative we should promote to facilitate the inclusion. Which one is the initiative that you will promote, or you can promote in your job, or that you think that is more important? I know already the answer for each of you because you are different and working in different fields. So I think that is very important also for the community to know and to take this advice.
So from the industry side, I can say that it's important to have the inclusion from everyone. So you have the SMEs, you have the institutions, you have the researchers, you have the universities, because all of this is connected with educate. Educate is connected with research, that is connected with knowledge. And everything together enables innovation. So if all of us will think the same and we have the same ideas, we can never innovate. We can never solve the challenges that this kind of activities that the planetary exploration put on the table. This is important that everyone work together because in the end, the goal is the same. The goal is to bring something to space. The goal is to make science on the space, is to research something. So our goal is the same. It's just that we need to put all of us together so that we can make it possible. Of course, as an industry, we have some parameters that means costs, but this is also connected with the institutions and with the research, because without money, we cannot promote what we want, we cannot investigate it, and we cannot do science. So everything comes together. For me, from the industry side, it's important that we collaborated together, we are a team, and everyone feels part of this team.
Yes, that's very important. We should feel part of the same vision and ambition. Thank you.
For what concerns space law, the first step should be to let people know that space law exists, because a lot of people do not know about space law at all, and so a lot of times when I pitch or I present space law, people say, wow, this is a new topic, it is actually pretty old. So the first step is to let people know that this is something real, that this industry has some rules that apply to everybody. And those rules have been established to make sure that everybody has access to space. And so space is not something that is only for the rich people or the few spacefaring nations, but it is something that should benefit everybody, both on this planet and in space.
Thank you. Good point.
I think I will stress the dissemination aspect because it's really important more and more to explain exactly that your topics, the space topics, is really something not so difficult to understand and starting really early if it is possible to explain to everybody. More and more we hear now about living labs. It's something that in some country it's not really applied, but if you, as Christian said before, we try to collaborate more and more all together, we can really very early explain to all the people, all the citizens, why this kind of research is really fundamental and that it's not something that we cannot reach. We need just to explain why the space research topics are really fundamental to resolve also a lot of questions in our society.
Thank you. I think that we can conclude the panel on time. And yeah, I think that this topic was very important. And yeah, I'm very glad mainly to close the Moon Village workshop with a message of collaboration between all the parties, all the community, the society, and all the discipline. Thank you, ladies. Thank you. Sì, sì.
Okay, now a few minutes and the closing ceremony will take place. So you can start to take place and in a few minutes we will start with the closing ceremony of the conference.
That's my preferred panel.
It was a speed dating.
Sì, sì.
I saw you online. I'm Svetlana. I'm closing it with you and Alfonso. So
Yes,
I just
Alfonso
wanted to
is,
say,
I don't know, who
maybe
is
somebody
Alfonso?
here.
Where is Alfonso?
Okay, I'm not sure, but
I'm sure he's
I'll leave you to
No. I'm first.
I just wanted to say I'm here.
Okay.
I'm not, I didn't I'm familiar.
Okay. I people Picture? Okay,
Yeah,
picture.
I know.
Aspetta. Dai.
すいません。一応来たことを入れて。
cielo, insomma.
Beh sì, no, perché se sei nell'associazione quindi io veramente dare l'opportunità
sai quante volte lo dico adesso mi scrivo
ma non ti devi nemmeno scrivere, non ti preoccupare, l'importante
no,
è che
perché
partecipi
è una
al
bella cosa,
messaggio,
assolutamente, sì, anche perché l'unica cosa che abbiamo sbagliato è che siamo stati lunghi
non
sui
fai niente, non ti
precedenti.
preoccupare. Io vi ringrazio tanto invece di darmi questa opportunità, hai capito?
No, ma Ida è
Di
anche molto
portare-
attenta a questa
di
cosa.
portare questo messaggio di pace, questo è fondamentale.
Sì, è fondamentale sempre. Grazie a te. Ah, perché dobbiamo pure far vedere i file? Dove stanno?
Esatto, questo ti dovevo dire. Dovremmo averti caricato tutto in
Mica mi avevano detto che c'erano
Londra,
due file.
closing ceremony, presentazione in PPT, scusa in PDF, quindi mettiamo schermo
No, aspetta, il
intero.
video non lo faccio vedere io però.
Sì,
aspetta. Il
esatto,
video lo
questo qui devo capire quando.
Ok, perché sta qua su
Esatto.
questo, esatto.
Allora, sono due file separati, questo qui è il file della presentazione che mi hai mandato tu. Nel momento in cui tu sai di dover lanciare il video devi cambiare file.
Ok,
Che cosa facile, capito?
Devi caricare per
Ma
forza
adesso
così.
lo possiamo far vedere questo come...
Via.
Ah, è vero, scambio di bandiere, mamma mia. Non ce la faremo mai. No, che mi c'ho l'aereo. C'è sta anche la cosa di Mondillage perché...
Allora, per lanciare il video bisogna...
lanciare il
lo
video.
deve lanciare Alfonso, sì, giusto. Dovrai aprire l'altro file spostandoti da qua sul secondo PC e trascinare il video su questo. Gli dai lo schermo intero e poi dai il play e dovrebbe partire. Ti tolgo un po' di schermo.
Sì, soprattutto...
Però vedi che si vede questo schermo qua.
F5, il famoso F5.
No, rimani sulle stendi.
Perché fare
No, questo si può vedere, scusami. Ok.
Poi dalla cartella
Quando vuoi tu. Ok. Dear colleagues, dear friends, thank you for attending the SEAS AIDA conference and the Move Village Symposium. Really interesting, fruitful and inspiring events. To start with our closing ceremony, it's my pleasure to call on stage the manager of the SEAS AIDA conference, Dr. Matteo Filippi.
Thank you very much. Thank you very much. It's the time for numbers and also for thanking people. I start with the numbers. I think that they are important, but not so important. We had a great event here. We had more than 600 delegates. We had 560 presentations around, and 11 great, outstanding plenary talks and great social events. So these numbers demonstrate for sure the success of this event. Now I start with the acknowledgement because I repeat, they are the most important part of this of my speech. I start by thanking the SIAS and especially Cornelia, her team, Beata and Andrea is not here. Thank you very much for your support and sorry, Svetlana. It's a gaff. Sorry, Svetlana. Sorry for that. Yes, of course. All the staff, all the team for your great work. And I take the opportunity also to thank the scientific program that helped us to create, I think, a very good program. Thank you again. A special acknowledgement to Dr. Giuseppe Ribaldi, our fruitful meetings during these months. Were very useful, and we create a great collaboration. Now, on a personal note, I want to thank two families. The first is the Aida family, and in particular, Mrs. Daniela Vinazza. I start with Vinazza, the Signora Vinazza, because she works in the backstage typically, but she's the right person at the right moment in the right place always. So thank you very much. Then, of course, our president, Professor Erasmo Carrero, who over these years made this association a point of reference in Italy, Europe, and worldwide. He was a guide for the association, not only a president, so thank you very much. Then I have to thank also my colleagues from Torino, the Mulciur Research Group, and I mentioned Giuseppe Palaia, Riccardo Augello, Rodolfo Azzara, and Karim Abu Salem for giving us support in preparing the program, the website, the app, a lot of stuff. Thank you very much. And of course, always Mulciur members, speaking of friends, not just colleagues. I want to thank Alfonso, Enrico, Marco. Thank you very much. Then I have a special mention to those who have invested a lot of time, a lot of efforts, and they, I'm sure, didn't sleep for nights. I start calling Nicoletta Bors. Come here, please. She replied thousands of emails with passions. Sure, and thank you very much for your support. Piero Chiaia, our factotum. He is able to do everything, photos, cavalierini, papers, everything. Thank you very much, Piero. And Chiara Franceschini. She coordinated an amazing group of volunteers for these first 4 days. They ran a lot, they check everything in the room, they fix a lot of issues, and thank you very much. Okay, enjoy the closing ceremony and the aperitivo. Sorry.
And now we continue. It's my pleasure to invite the SES President, Cornelia Hillems.
Yes, thank you very much. I would like to thank you, Erasmo, for hosting this conference, this unique event, bringing together not only the AIDA Congress, the SEAS conference, partnering with the Moon Village Association and also with the Aerospace and Defense meeting, and making this such a great event where we could meet all together. Also, Matteo and Nicoletta, you were my focal points in the last weeks and months, and I couldn't even see what was behind this, so thank you very much again, and you did a tremendous job. So yeah, the bar is high. A big praise for this really great event. It will be difficult to reach it with the next SEAS conference in 2 years. I think we've managed to bring together people from all over the aerospace branch, across disciplines, but not only, from all parties, from industry, academia, from research institutions, maybe also from regulators, operators, and also all generations. I've seen a lot of young people, which is fantastic, and young professionals, seniors, and retired people with a lot of experience exchanging also across this dimension. So this is what this event can do, and what I think we have reached here and managed to do thanks to this to the organization. I just want to briefly mention that SEAS also it's our goal or one of our missions to support young talent, and so I just mention it again. We supported the 10 best students, Pegasus students of this year, which presented today, and also 3 students which had to apply and were selected by SEAS and the ESA Academy, and they've presented during the normal program, and so congratulations again, and we really enjoyed that you made it, that we could have you here. So I don't want to speak any longer. We have a tight program. I just say thank you also to all of you participating in this event, because without you it would be nothing. So thank you, and yes, I appreciate it to be here, and the Italian hospitality. Well, what should I say? We all enjoyed it very much. Thank you.
And after the SEAS President, the Moon Village Association President, Dr. Giuseppe Ribaldi.
Okay, so good evening, and I think time is getting late. However, before the closure and of course the thanking, we have an announcement. As you might know, we are going to announce and get the live connection, hopefully works, with the location which has been selected with a competitive bid for next year. Moon Village Association moves around the world every year. And so this next year, the next Moon Village, the 10 Moon Village workshop will take place in Bangkok, Thailand. And so I am now pleased to give the floor in live, let's say, connection, I hope so, being the global organization, to the organization which will host actually the event, which is the Geoinformatics and Space Technology Development Agency. Brief is the Thai Space Agency. And I'm pleased to give the floor to Mrs. Sri Kai, I hope I'm correct, who is the head of space promotion of the Thai Space Agency. She will shortly explain the highlight and of course invite all of you to come in the wonderful Bangkok. So, Mrs. Shikai, the floor is yours, please.
Thank you very much. Thank you very much. So good evening, everyone. So my name is Sawani Sichai, representing G-Star Thailand's Geoinformatics and Space Technology Development Agency. Although I'm joining you online today, it is a true honor to share with you Thailand's vision, capabilities, and our proposal as the next host of the 10th Global Moon Village Workshop and Symposiums in 2026. So G-Star, the Geoinformatics and Space Technology Development Agency, is Thailand's national leader in space and geospatial innovation. We deliver advanced GIS services for government and industry, strengthen human capacity through the professional training, and developed space technology from satellite design to ground operations. G-Star also drives international partnerships, support pilot projects that we are the central role in shaping national space policy and the space master plan. Through these efforts, G-Star acts not only as a technology provider, but as a catalyst for innovation, education, and sustainable growth within Thailand's expanding space economy. In 2026, Thailand will host the Thailand Space Expo. Thailand Space Expo will be hosted from 28th to 31st October, the country's premier event for space technology and innovation. The expo, it brings together government, industry, academia, and international partners to showcase advances in satellites, Earth observation, GIS, and emerging space technology. More than an exhibition, it is a platform for collaboration, driving knowledge exchange, capacity building, and solutions that support economic development, disaster management, and regional sustainability. Building on the momentum of 2025, the 2026 Expo strengthens Thailand's role as an active contributor to the global space community. It reinforces international collaboration and positions the country as a regional hub, connecting Thai capabilities with global partners to advance shared space ambition. And during the same period, Thailand will also host APR South 32, one of the Asia Pacific's leading multilateral platforms for space agencies, researchers, and industry partners. Holding the 10th Global Moon Village Workshop and Symposium alongside Thailand Space Expo 2026 and APR South 32, we create a unique synergy with a substantial regional and global impact. Integrating the Moon Village Association's activities into these flagship events will unite Asia-Pacific space leaders, innovators, and young professionals, accelerating collaboration and cross-disciplinary exchange. For Thailand, this is a prime opportunity to showcase national space capabilities, promote innovation, and deepen partnerships across government, industry, and academia. For the Asia-Pacific region, the combined event strengthens cooperation in sustainable space development, technology advancement, and policy alignment. On global scale, this positions Thailand and the region as active contributors to the Moon Village vision, supporting international R&D, lunar exploration, and real-world space applications. Ultimately, aligning these events amplifies impact, drives innovation, and reinforces Asia's role in shaping the future of sustainable and collaborative space exploration. So thank you very much for attention. On behalf of G-Star and the organizing team, it is my great honor to welcome you to the 10th Global Moon Village Workshop and Symposium 2026 at Icon Siam, Bangkok. Icon Siam, one of the city's most iconic riverside destinations, offers a perfect blend of culture, innovation, and warm Thai hospitality. With world-class shopping, diverse dining, and beautiful views of the Chao Phraya River, it provides an unforgettable experience for all visitors. The venue is also highly convenient, with easy access by car, taxi, BTS SkyTrain, bus, and boat. A wide range of nearby hotels, from luxury riverside properties to modern boutique options, ensures comfortable stays 4 minutes away. So we look forward to welcoming you to Thailand next year. Thank you very much.
So thank you to our future host, and I'm now going to the closing of the workshop because we're running late. So again, I will not do the long list of thanks, but let's try to be a little bit more general. So first of all, I'd like to thank, of course, Cornelia with the CAS, all the organization and all the people which have worked together with her. Of course, Aida in the name of Erasmo, plus all other colleagues that have worked with us, of course, Enrico, Matteo, as well as many others. Also, our people that have been in the office making the live streaming, Glavki, as well as Alessandro. So we have a long list, but nevertheless, I think this was a great event. Thank you so much. I hope there was a lot of synergy. The moon is the next destination, so I'm sure everybody realized. And so with that, I'd like to close and again thank Erasmo and all the people which have been hosting here and declare the 9th MBA workshop closed. Thank you so much.
Let's continue to invite here. It's really my personal pleasure to invite here the president of AIDA, Professor Erasmo Carrera.
Thank you very much, Nunzia. So I'm pleased to be here in this closing ceremony, which was not in the program at the very beginning. So we have decided to make it. It's a good moment. And it's wonderful to see so many people. We are late on Thursday. So it's nice to see that people is still time to stay and to attend this closing ceremony. And of course, I'm happy as a, personal at personal level because I wanted to have this event as larger as possible. So I tried to put these 4 events all together. And this, I think this is the way to continue also for SIAS, for AIDA, because we have to be open and we have to try to connect people from different, doing the same things, but on different aspects, we say different TRL, right? So that's the way it will work in the future, because now it's really much more difficult to see the difference. When you work with industry, research center, university, we are all connected because we are in the university and our rectors, our administration say we have to go to startups, spin-off, and so on. So then people from industry probably have pressure, you have to go also to research, and then research center have to do both, and so on. So it's good to have all these kind of events. And that we also took the chance to host the Moon Village, which is international, and we got some experts from all over the world. And I'm happy that this was done in Torino, of course. That's really nice for me, and because Torino is the city of aerospace since a long time, and it was in the past probably more than as it is now, but we have room to make it more powerful in the next year. So concerning, I think, the conference, I think Matteo, Cornelia, and Giuseppe have already said on everything. So I will have also possibility to thank all the others in the next occasion. So I thank you once again. Was impressed because we have in this room also some senators of the AIDA, and they were happy because they turned their head and see so many people. So they said that's really good for the AIDA to have so many people in our meetings. This is the most important part. So thank you to all, and thank you for attending this event tonight. Yeah.
So it is now my turn. I don't know if I'm the most entitled person to provide these awards, but I'm so proud to be here. And this is about AIDA Service Awards, as you know. And we have spent a lot of words about AIDA yesterday by our president, incoming president, and also by Professor Marchetti. They all mentioned that the best result of the latest year of AIDA is the community that has been developed. And actually also Matteo said this is a family. and we are so proud of it. So any community has a basement, a very solid one, and we like to start with the AIDA Student Contributor Award. And I would love to have Nicoletta on stage to help me with this, and to help me in giving the awards to our students. So let me just give you the citation for outstanding support and meaningful contribution to AIDA mission by active student involvement. I would love to welcome on stage to collect their awards to Francesca Bracaglia, Giulio Candita, Piero Chiaia, of course, Marzia Corsi, Maria De Rosa, Chiara Franceschini, Antimo Glorioso, Giacomo Lucisano, Maria Maione, Rebecca Masia, Martino Carlo Moruzzi, Daniele Scano, Elisa Tortorelli, Federico Toson, Marianna Valente, and Dario Zamani. Thank you. Please collect your certificate. We can have a picture with the presidents. Karim, thank you very much. With you. Let's take a picture. Martina is not here. Where is Martina? Martina. Sorry. Martina Santori, of course. Thank you very much. They've been fundamental in organizing the many events, not only this one, but also all the events in the past few years, not only Aerospace Italy 24, the IC, the ICAS, and so many events we hosted in Italy and elsewhere. Thank you very much. Please. Grazie a voi. So next one is the AIDA Service Award. So after the basement, we have some of the columns of the association, let's say the senior ones. And of course, also this list is very long and collect all the people that have been working in the AIDA and providing a contribution. In particular, for pivotal contribution to the success of Aerospace Italy 2024, advancing Italy's aerospace community in the international scenario through knowledge sharing, public engagement, and impactful initiatives. Nicoletta? Okay. So we have Karim Abu Salem, please welcome on stage. Andrea Alaimo, who is not here. Federica Angeletti, Riccardo Augello, Rodolfo Azzara, Carlo Bettanini, Sara Bagassi, Roberto Camussi, Giacomo Colombatti. For those who are here, I know that many are not attending. Pierluigi Di Lizia, Andrea Esposito, Nunzia Favaloro, of course. Matteo Filippi, Susanna Laurenzi, Roberta Lazzari, Professor Francesco Marulo, Marco Montaruli, Giuseppe Palaia, myself, Marco Petrollo, Mirko Zaccariotto, and Enrico Zappino. This is the team that, of course, together with students, collected so many successes in the last few years for AIDA. Thank you very much. Grazie. Thank you very much. And as you know, we do a lot to our fathers. And I don't know if you attended the meeting yesterday of AIDA, but it was very moving. And this is dedicated to Lifetime Service Award, and in particular in recognition of sustained dedication, exemplary service, and enduring contributions to AIDA and Italian aerospace over a distinguished career. This for us is a very important award, and I would welcome on stage Signora Daniela Vinazza is here, just to help me in delivering the awards, the 3 awards that goes to Professor Cesare Cardani, Professor Aldo Frediani, and Professor Marchetti. They have been the true columns of our associations for so many decades, and thank you very much for teaching. Thank you very much for inspiring us. Grazie. And last but not least, we have a little surprise. I would also ask for this one, the help of Signora Daniela. Sorry for this. And also Piero. Where is Piero? To collect the final award. Because every group needs a solid building, a solid group, but also we need a solid architect. And he has been inspiring all of us and pushing to the limit to have the best events in Italy and in the world as AIDA. So we all recognize this to Professor Carrera, Professor Asmo Carrera, our president. So the Leadership Excellence Award for visionary leadership of AIDA and for advancing Italy's aerospace presence, restoring the association to the strength and the purpose of its most glorious years. Thank you very much. So, before leaving the stage to Svetlana, let me just show you a small video of the iconic moments of the Congress and enjoy the, hopefully.
now sales is taking over, actually. Alfonso, thank you very much for this nice video, but also for your presentation, etc. So it's time now for me to welcome the editors of AIDA and also sales journals. So I welcome Marco Petrolo, Cornelia Hillerhems, and Ugo Lafont to the stage.
Thank you. Yeah, just a few minutes to remind you that these are the 3 journals that are supporting this event, and we welcome extended versions of your papers to be submitted to these 3 journals. All journals are indexed in Scopus and Web of Science. We will guarantee a rapid review process, at least as rapid as possible. And the submissions are open, so from now on, please feel free to proceed. Now I pass the stage. I ask my colleagues if they want to add anything.
Well, there's not much to add. As you've said, just choose the journal you feel the most appropriate to your work or to your research. All journals are published by Springer Nature, so this is maybe also to mention. So the process is the same formally, and yes, we are happy to receive your extended papers and to see them in the journals. Thank you.
I may want to add that for the specific journal related to space, if you look in the world, there is not a lot of journal related to space. And CAS Society is really keen to publish very good papers, and we have witnessed a lot of good contribution to the CAS journal in general and for the space application as well. So please help us to make this journal a reference journal for all this application, and with the excellent talk and contribution we have seen within this conference, we are sure that we will ramping up and keep basically the high level of science accessible for everyone.
Thank you very much. You may leave the stage. So it's done. It's time for me now to present Best Paper Awards, and we have 6 best papers. And then I will start with the first one. So we have papers, they cover different area, and first is the best paper in systems. And the paper title is AI-based aircraft wake vortex detection and prediction for vertiports. And this is from Anton Steven, Niklas Varta, Liz, I'm not sure I can read it, I'm so sorry, and Frank Holzapfel. I'm so sorry for my pronunciation. Are you maybe here? Yeah. The next best paper is in structures, and the title is very long, but it doesn't matter. Regolith-induced abrasion as a critical challenge for lunar materials, experimental insights on fiber-reinforced composites and polyethylene. Oh, this is in my area in materials. And these, oh, I'm so sorry, it's Balestra. I can't read this, Mustar. And then we have Lorenzi Susanna and then Andrea Di Benedetto. Are you maybe here? Okay, please, come forward. the third best paper is in propulsion. Oh, this is something I have been working with too. And the title is Retrofitting of Hairpin Stator Winding Aircraft Propulsion Motor with a Superconducting Rotor. Sounds very interesting, actually. And this is from Andreas Lindner, Xin Yan Liu, and Daniel Walsh. If you can come. Okay, so they're not here. Okay. The next paper is in aviation and ATM. It's for DLR project NICO. It's about feasibility study of an alternate airport assistant for pilots deciding where to divert. And this is from Johan González Cabeza, Soren Petersen, Jean-Philippe Buch, Dominik Niedermeyer, Matthias Weiss, and Anne Pappenfuss. No, okay. The next best paper is in flight mechanics. It's about simulating the potential of an in-space fragmentation of the Lunar Reconnaissance Orbiter. And this is from Nicolo Trabashin, Cynthia Guacomuso, and Lorenzo Olivieri. And the last paper is in fluid dynamics, and the title is Direct Numerical Simulation of Compressible Turbulent Bodily Layers over Prism-Shaped Roughness. And this is from Davide De Pieri, Michel Cogo, Davide Modesti, Matteo Bernardini, and Francesco Picano. I think I nailed these names. I'm sorry. So, okay, they're not here. Congratulations again. And let's take a picture. Let's take a picture together. Maybe together. Yes. Easier for just two. Yeah. So now it's time for me to welcome the onstage current and future chairs of SIAS Congress, and it's about flag ceremony. Let's see how it looks like. Okay, Erasmo and Cornelia, please take your stage.
So we have, from this event, we are trying to have this flag ceremony. So AIDA has hosted the SEAS this year. In 2 years, we will have a new edition of the SEAS conference. And so this will be the flag. This I want to show you. You know, it's going to turning around Europe from now on. So the AIDA is going to give the flag. The AIDA is going to give the flag to SEAS, and SEAS is going to give the flag to the next host. So I give the flag to Cornelia.
So, and Sias will give the flag to DGLR, the German Aerospace Society, which I also represent today as Vice President of DGLR. So the next Sias conference will be in Germany, also in the last quarter of the year 2027, so 2 years from now. And more details will be disclosed soon. So stay tuned, and we will be happy to see many of you there. Thank you.
Thank you very much. Thank you. It's time to close the conference. But before we close the conference, we invite you to join us for goodbye cocktail. But before we start drinking, I want to say something. I want to say thank you a lot for coming and then sharing your time with us at this conference. And I would like to thank the staff, especially for you students, because I feel very safe with you while chairing conferences, and also to IT people, to the organizing committee, and to Italians also for the very nice food and then very nice time here. But I want to say something else which hasn't covered earlier. The conferences, and also this conference, it's not only about presenting a series of presentations and papers. This is your platform for collaboration, because you have made many connections, you have done many conversations, and then please continue with these connections and collaborations, because they're going to build a basis for your future projects, for your future job, and maybe for your future breakthrough in science or innovations. So please continue connections on LinkedIn, but also join our future initiatives. And I wish you all safe travel back home, and then see you in the bar now. Thank you very much.
Microfono. Okay, just to remind everyone to take your clothes to the wardrobe before 6 p.m. and then you can join the drink. Yeah, it's better to go now and then you join the drink. Thank you.